A very good morning to one and all. I welcome you all heartily to the Women in Data Science conference here today. So, without any further delay, I would like to call upon my co-team member Samuel to introduce our first speaker for today's event.
Hello everyone. The first keynote speaker for the session is Snigdha Ghosh Ray, who who works at PayPal, to give a session on actively managing risks with AI.
Good afternoon, friends. Welcome to the fifth day of the WIDS 2020 Mysuru conference. If someone had asked me last year what is the probability that the WIDS conference would be hosted remotely, just based on pure statistical data, I would have said a very low single digit percentage. However, here we are today. Similarly, in the payments industry, we cannot detect frauds just based on statistical data. Perpetrators are making huge investments in building novel techniques to do fraudulent transactions, whether it's for infrastructure, software, or using human agents. So today, my discussion is around managing risks in digital payment space within PayPal with AI. But before I get into the session, let me introduce myself. I have been in this industry for 24 years, playing senior global product and technology executive roles. Currently, I lead product and engineering for subscriptions at PayPal. I also lead transformation of the checkout portfolio. I have led development of several enterprise grade SaaS products with revenues ranging from $2 to $2.5 billion. Some of them I have led from market research to successful launches. However, more in the last 4 or 5 years, I have come to realize that to acquire new customers, engage your users, change customer behaviors, and accelerate revenues by monetizing your data, machine learning plays a very important role. So, going to what's happening in the payments industry, it is a highly commoditized industry where we see investments coming in not just from payment players, but also the mega commerce and digital ecosystem players. This high competition results in low transaction fees charged to our clients. Add to it the high operating cost because of a highly regulated environment. To sustain profitability, therefore, the industry is left with two levers. One, to scale volume of transactions by attracting and engaging more users. Two, by reducing the fraud losses and hence the operational costs. As you will see, just last year, the payments industry cited a $650 billion loss through cybercrime, which pegs the industry loss rate at 1.5 to 1.7% of revenues. However, PayPal reported one-fifth or one-sixth of the industry standard losses. Today, we will discuss how does PayPal sustain such low fraudulent losses. We have a very sophisticated multi-layered risk decisioning system that touches 55 unique flows, makes 100 million plus decisions, and impacts 1.5 billion events on a daily basis. This system is strengthened by 20,000 plus rules, 18,000 plus aggregations, 100 plus models, which are running on high speed infrastructure, processing over 75 petabytes of data. So let us understand, what does this high-powered risk decisioning system do? Let us take examples of a few risks in our industry. Account takeover is a pretty common example where somebody logs into your account with valid credentials. Can you even imagine how difficult it is to identify that the user is a fraudulent user? We have to look at the purchase behavioral patterns, the login frequency, the navigation patterns, and maybe even the keystroke data patterns. Similarly, how about when a valid account user uses a card that has been used by a different account? Is it a stolen card, or are the account holders sharing this card? While these two scenarios may seem to be simple fraudulent examples, what about this case? A highly engaged user with no prior payment defaults makes a high value purchase in a different location than normal. The account that is used for making this payment shows insufficient funds. Now, is this a case of a fraudulent transaction, or is it a case of a genuine cash flow issue? There are some more interesting examples. One of our buyers on eBay placed an order for an Xbox for a few $100s. What he claims to have received is the picture of an Xbox. These are simpler examples, maybe. The most complex scenario is one where a buyer and seller colludes. As you know, PayPal provides seller and buyer protection. There was a very interesting incident way back in September 2016 when an Italian businessman opened an account. For around 6 to 9 months, we did not see any suspicious activity. They were normal transactions. Suddenly, in May 2017, we see 90 transactions of high-value purchases, iPhones and Rolex watches. 15 of these transactions were flagged as suspicious because of buyer behavior. They had not purchased such high-value purchases earlier. However, the buyer confirmed the purchases. A few days later, all 90 transactions were filed for claims, citing the seller did not deliver the items. During the dispute investigation, we identified that the card BIN and the account routing numbers were shared between these buyers and sellers. These examples would have given you a pretty good insight of what our risk systems are trying to attack. Our risk decision systems try to ensure that we set ourselves with an optimal risk appetite. We constantly balance between a great customer experience and sustaining our business profitability. If we set a risk threshold too high, we may decline good transactions. We may have a lot of friction in our customer experiences as they are asked to revalidate or re-authenticate themselves through step-ups. If we put the threshold very low, it could mean that we have more fraudulent transactions through our systems and therefore encounter losses. The key performance of our risk models are therefore measured on the balance between a great customer experience and sustaining business profitability. Let's take a peek at our risk system. It is a sophisticated, multi-layered system. There are data quality acquisition mechanisms where we collect huge amount of data and then we do sanity checks, data cleansing, data enrichment, imputation, and outlier removal. All of this data is then pre-processed by computing variables and aggregations that are then used by components and models. The components and models set risk flags, which are used to arrive at a binary classifier of every user as a good or a bad user with a probability score. Our strategy subsystems use rules and thresholds for every domain, region, and merchant to decide on what is the right action for every transaction. What is the right risk that you want to manage for every transaction? The decisions made by the risk decisioning system is either accept the transaction, decline the funding source, put the transaction on hold, or restrict the account. The suspicious transactions that cannot be auto-resolved are then sent for manual review and resolution. Let us look at some of the key subsystems in RDS. 2,000 plus variables are collected by our systems. We have proprietary best-in-class risk data acquisition and enrichment tools that capture different categories of data: customer data, the purchase, transaction-related data, connection data, and device data. This data is used throughout the life cycle of the transaction by different components, models, to make the right decisions. We do a lot of pre-processing to be able to make risk decisions within a few milliseconds. These variables are aggregations and computations for both buyer and seller. How frequently does a user log in and use a particular funding instrument for purchases? What is the typical funds received by the user from a particular center? Are multiple accounts logged in from the same IP? We have behavioral analytic components that use the underlying data and variables that we just saw. The components are used to answer analytical questions. Is the user traveling? Are the two different account holders related because they are using the same funding instrument? Does the user normally make such high-value purchases? The risk flags that are set by the components and a lot of the data that we looked at earlier are pretty much the assets that are used by our models. Our models use the risk flags to arrive at the classification of the user, whether the user is good or bad with a probability score. These users are then clustered based on the probability score. Any bad activity by a user in a cluster updates the score of the cluster. The transaction network score is finally derived out of the users involved in that transaction. So what kind of models are we using given that there is enormous amount of data that PayPal has access to? In the initial years, when we did not have a lot of data, we used logistic regression models. As we graduated and captured more data, we started employing nonlinear neural network and GPT models that could handle the huge volume of data and a higher processing. All these models, though, were based on human engineered features. As we started collecting more and more data, the models were no longer as efficient and accurate. We use deep learning models today and high compute infrastructure like the NVIDIA 4 GPU to find out the right features and get high performing models. Now that we have all the user scores, what does the decisioning strategy layer do? As I mentioned earlier, the strategy layer has several rules and thresholds. Thresholds that are updated to make decisions for every payment transaction. This could have a multitude of dimensions. It could depend on the user, whether it's a highly engaged user. What is the history of the user? How does this transaction need to respond to the user scores? Meanwhile, we constantly monitor and evaluate our models for efficiency. We try to answer a few business decisions. How many good dollars of business did we decline for every bad dollar from fraudulent transactions that we got? How many good users had a friction experience? How many good transactions could get approved without any risk checks? We often do trade-offs between the metrics that we compute. Well, the catch rate gives us the number of fraudulent transactions that we have been able to catch by using the number of bad transactions that were identified from the total actual number of bad transactions that went through the system. The hit rate helps us identify how much of good business did we lose. What were the total number of bad transactions that were identified versus the number of bad transactions that were predicted and declined? Therefore, there is a constant trade-off between the customer experience and fraud losses incurred by PayPal. The efficiency of our models are measured against the number of accurate predictions versus the total number of predictions. And I shall be happy to share that while we saw the volume of our transactions and the number of users acquired by our network grow enormously during the COVID phases, our risk decision models were hugely stress tested and proved successful. Finally, I cannot overemphasize that in our journey to democratize financial services for all, artificial intelligence plays a pivotal role for helping us make our transactions highly convenient, accessible, and affordable for all. Thank you very much for your time today. I hope you enjoy the rest of these sessions. Please feel free to reach me on LinkedIn or Twitter if you would like to discuss this topic further.
Thank you, ma'am, for the informative session. It was really informative. So the next speaker for the session is Lakshya Sivaramakrishnan, who is a program lead at Women Techmakers India, to give us a session for the topic bias in machine learning algorithms.
Hello everyone. I'm Lakshya Sivaramakrishnan and I manage the Women Techmakers program for India. Today, I'll be talking to you about fairness in machine learning and how it can be applied to systems, tools, and technologies. Specifically, I'll be discussing human biases, how they can creep into our machine learning systems, and how can we address and mitigate bias throughout the development process. Before that, what do you see? You might say bananas, or bananas with stickers on them, or bananas on the shelves. But we don't tend to say that they are yellow bananas. But if you see these bananas, you might say they're green bananas or unripe bananas, right? And as for these bananas, you might describe them as brown, overripe, or good for banana bread. But given this picture of yellow bananas on the shelf, we tend not to mention that they are yellow. That's because when we store our ideas of the world, we store them based on what's typical for different kinds of objects and things. And when these things match our stored understanding of what's typical, we tend not to mention them. And so, for the fact that the bananas, are yellow goes without saying. The banana example illustrates the way humans learn and remember categories based on experience. Because most bananas we eat are yellow, we don't find the need to explicitly call out that these bananas are yellow, right? When we form a category with information such as color as a defining characteristic, this shapes the way we interact with examples that don't fit that mold. This is a form of bias or a cognitive blind spot. And so, how do these kinds of cognitive blind spots affect machine learning? In a typical machine learning paradigm, you start out with training data. The data is collected and annotated. From that, a model is trained, and then data is filtered, ranked, and outputs are generated. We like to think of this as a relatively clean pipeline, but there are so many different types of biases affecting it under the hood. There are biases in the data when we first collect it, reflecting how humans see, talk about, and capture the world. There are biases in how subjects might annotate that data. So let's unpack some of these biases as they're very important to be aware of as we work with machine learning systems. Machine learning models are not inherently objective. Engineers train models by feeding them a data set of training examples, and human involvement in the provision and curation of this data can make a model's predictions susceptible to bias. When building models, it is important to be aware of common human biases that can manifest in your data so that you can take proactive steps to mitigate their effects. Let's look at certain types of biases. Starting off with reporting bias. Reporting bias arises because people tend to focus on documenting circumstances that are unusual or especially memorable, assuming that the ordinary can go without saying. We saw this with the banana example a few slides back. Then there's automation bias, which is a preference for suggestions from systems that are automated, such as machine learning systems, as if they're somehow more objective than information from humans. Then there's selection bias, when examples we select to input into machine learning systems are not a random sample of the world, but rather made up of things that are interesting to us. Selection bias has multiple folds, right? There can be coverage bias when data is not selected in a representative fashion. There's non-response or participation bias where data ends up being unrepresentative due to participation gaps in the data collection process. And then there's sampling bias where proper randomization is not used during data collection. Up next, we have group attribution bias, which is a tendency to generalize what is true of individuals to an entire group to which they belong. Two key manifestations of this bias are in-group bias, which is a preference for members of a group to which you also belong, or the characteristics that you also share. And then there's out-group homogeneity bias, which is a tendency to stereotype individual members of the group to which you do not belong, or to see their characteristics as more uniform. Finally, we have implicit bias, which occurs when assumptions are based on one's own mental models and personal experiences that do not necessarily apply more generally. A common form of implicit bias is confirmation bias, which is a tendency to search for, interpret, or favor information that confirms our own pre-existing beliefs and hypotheses. In some cases, a model builder may actually keep training the model until it produces a result that aligns with their original hypothesis. And this is called as experimenter's bias. Given that we know and understand types of biases, let's see how to identify biases. Here's a case of missing featured values, right? If your data set has one or more features that have missing values for a large number of examples, that could be an indicator that certain key characteristics of your data set are underrepresented. For example, this table shows a summary of key stats for a subset of features in the California housing dataset. It is stored in a pandas data frame and can be generated via the dataframe.describe method. So here, the three features of population, households, and median income have only a count of 3,000 values, which goes to say that about 14,000 values are missing. And these 14,000 missing values would make it much more difficult to accurately predict the average income of households and correlate them with the median house prices. So before training a model on this data, it would be prudent to investigate the cause of missing data to ensure that there are no latent biases responsible for missing income and population data. Another way in which you can identify bias is through unexpected feature values. When exploring data, you should look for examples that contain feature values that stand out as especially uncharacteristic or unusual. These unexpected feature values could indicate problems that occurred during data collection or other inaccuracies that could introduce bias. For example, take a look at this table, which is again from the California housing dataset. The longitude and latitude coordinates in example 4 do not fall within the US state of California. In fact, their approximate coordinates of Mount Rushmore National Memorial in South Dakota. So this is a bogus example that we inserted into the data set, which essentially translates to some form of bias. Another way in identifying bias could be through data skew. Any sort of skew in your data where certain groups are maybe overrepresented or underrepresented relative to the real world prevalence, this can introduce a bias into your model. For example, you may look at this figure and figure out how all the data points are very skewed towards the northwest region of California. If this unrepresentative sample were used to train a model to predict California housing prices statewide, the lack of housing data from southern portions of California would be problematic. The geographical bias encoded in the model might adversely affect home buyers in underrepresented communities. Now that we have learned a few methods to identify bias, let's look how can we evaluate for bias. When evaluating a model, metrics calculated against the test or entire validation set don't always give an accurate picture of how fair the model is. Let me explain this to you with an example. Consider a new model developed to predict the presence of tumors that is evaluated against a validation set of 1,000 patient medical records. 500 of these records are female patients and 500 records are male patients. The following confusion matrix summarizes the results of 1,000 examples. These results look promising, right? Precision of 80% and a recall of 72.7%. But what happens if we calculate the result separately for each set of patients? When we calculate metrics separately for female and male patients, we see stark differences in model performance for each group. In case of female patients, of the 11 female patients who actually have tumors, the model correctly predicts positive for 10 patients. In other words, the model misses a tumor diagnosis in 9.1% of female cases. Similarly, when the model returns positive for tumor in female patients, it is correct in 10 out of 11 cases. In other words, the model incorrectly predicts tumor for in 9.1% of female cases. But let's look at how this data acts on male patients. In case of male patients, of the 11 male patients who actually have tumors, the model correctly predicts positive only for 6 patients, which means the model misses a tumor diagnosis in 45.5% of male cases. And when the model returns positive for tumor in male patients, it is correctly identifying 6 of the 9 cases. In other words, the model incorrectly predicts tumor in 33.33% of male cases. We now have a much better understanding of the biases inherent in the model's predictions, as well as the risks to each subgroup if the model were to be released for medical use to a general population. With this context in mind, let's see how can we design for better fairness. When working with machine learning, here are some of the things that we need to think about to create systems that have positive real-world impact. Consider the problem. What's being represented in your dataset and what might be overlooked? Ask experts. They might provide guidance or suggest changes to what you're working on, which can help your project from a long-term positive impact standpoint. Train your models to account for bias. What do outliers look like? And how does your model handle them? What implicit assumptions might a system be making, and how might you model to mitigate those? Interpret outcomes. Is the machine learning system overgeneralizing? If a human were to perform this task, what would the appropriate social behavior look like? What interpersonal cues might there be to make that would make an ML system perform differently from a human? If you decide to publish with context. Are you sharing examples? What effect might that have? How should technology be directly used? By keeping these things in mind, we can bring the benefits of machine learning to everyone. What's next? I urge you to take a look at this collab activity here using the link bit.ly/ml-fairness. Try out the hands-on example and let us know what you think about it. And watch this video.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool on the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation, because technology should work for everyone.
I hope that video really summarized what it takes to build models that are fair. With that, thank you so much for this opportunity. Hope you have a great day. Thank you.
Thank you, ma'am, for the great session. It was really informative. The next speaker for the session is Shreya Sharma, who is a bioinformatics analyst at MedGenome. For the session for the topic machine learning approach for personalized genomics.
Yeah, hello, am I audible? Okay, so I'll share. Yes, so good afternoon, everyone. So myself Shreya Sharma, and I'll be speaking today on personalized medicine using machine learning. So let me brief you about myself. So I work as a bioinformatics analyst in MedGenome Labs. So I'm a developer in the clinical operations team. So what basically happens is we get patient samples. So we analyze those samples, we sequence them, and the data which is generated, we try and do predictive diagnostics on those data. So we are currently the market leader for genetic diagnostic testing in India. So let me give you a brief overview of how this presentation is going to go. So first, I'll introduce you a bit about the genomics concept so that you can relate to the problem as well as the solution statement. Then once we are ready, we'll understand a bit about the NGS technology and the bioinformatics workflow. So followed by the disease risk prediction model and case studies which show that how this disease risk prediction model has helped. So first, I'll talk about what a personalized medicine actually is. So this is the technical definition which I've taken from Council of Advisors of Science and Technology. So it basically refers to the tailoring of medical treatment according to a particular individual. So all of us, our DNA is unique in a certain way. So what we do is we classify individuals into subpopulations such that each subpopulation has a different response to their treatment. So this helps the doctors to get the right treatment for the right patient. So this enables for safer drugs and more effective drugs. It's cost effective as well as the patient diagnosis. The time is properly managed. So this is a nice image which I found to depict what I was saying right now. So you can observe here that these are cancer patients with, let's just say, colon cancer. So if a doctor just prescribes a particular medicine for this cohort, so the response of the patients would be different in each case. So in some patients, yes, we can see the effect. In some patients, there might be no effect, whereas there might be one or two patients which show adverse effect to that medicine. So if we follow a more personalized diagnostics, using genomic data, their clinical data, demographic data, so we can have tailored therapy for each of the cohorts, which will result in a more effective treatment. So talking about the concepts of genomics. So our human genome, each cell in a human genome, it has 3.2 billion DNA base pairs. So we have 23 pairs of chromosomes and 3.2 billion DNA base pairs in each cell. So 99.99% in fact of the DNA is identical. It's only that 0.01% which makes us different. So 50% of the DNA we inherit from our mother, 50% from our father, and it's this variations in our DNA which actually make us unique. So if there's any genetic abnormality in in our sequence, in our DNA sequence, and if that abnormality is detrimental to us, so we get some disorder, some genetic disease, which we then diagnose further. So just to explain what I mean by variation in our genome. So our DNA sequence is essentially made up of 4 molecules, that is cytosine, adenine, thymine, and guanine, ATGC. So in each of the sequence, you'll notice that there are certain variations in their sequence. So these variations, not all variations are bad, let me tell you that. So that only certain variations might be there which result in a disease. So to classify a variation as SNP, it should occur in at least 1% of the population. For example, some people have curly hair, some people have brown eyes, black eyes. So all that is determined by these SNPs. So they're responsible for over 80% of the variation between two individuals. So if I want to predict a disease, so it's these SNPs which have the information. So I can correlate the genotype and the phenotype of the patient. So by genotype, I mean the genotypic data, the sequence which I have. And by phenotype, I mean the clinical symptoms, or which you can see what is the phenotype of the patient. So mapping both of them, looking into the SNPs, I can build a model and predict okay, this might be the disease diagnosis. How to do that, I'll explain in detail further. So once we're able to do that, we can, administer a drug to an individual, and which would be highly useful in predictive diagnostics. So how we get the genomic data? So essentially, first the patient sample is taken. It could be a sputum sample, it could be blood sample. You take that sample and you extract the DNA from the patients. Once you're done with the extraction, you take out the DNA sequence, shred it into small pieces, and then there are sequences like Illumina has multiple sequences like HiSeq, MySeq. So you sequence these DNA sequences. So essentially, you get a file which is composed of huge data in the sense of ATGC. So you have multiple ATGC sequences, and then further start your analysis from these sequences. So just to give you a feel of what I'm talking about, the big data and how it works, here's a brief workflow. So first you get the raw reads which you got from your Illumina sequences, or it could be any sequencing machine. So once you get your raw reads, which is approximately 100 to 150 GB, you filter those reads based on there's this quality score, Fred score, Q30 cutoff, and there are multiple other factors which you consider. So the raw reads are then filtered and you get a clean read. So the data reduces to 80 GB, 80 to 90 GB. Then you align these reads to a reference genome. So we need a standard, right? So that we can align each and every patient sample's genome to that particular genome. So we have a reference standard. And we align our patient sample to that standard genome. Once we align to a reference genome, there are built-in softwares which are used to call variants. So using that, we can get this final SNPs, like how many variations are there between a patient sample and the standard genomic sample. So we have come down to 3 to 4 million variants. Yes, one sample has 3 to 4 million variants. So now we can annotate those using softwares. So this is how a sample VCF file looks like. You have your chromosome, you have the position, you have your reference and alternate alleles. And there are multiple other things which we need not go into the details of it right now. So where does the problem come? We have the reads, we have aligned the reads to the reference, we've called out the variants, we have the variants in hand, and we've annotated the variants. The problem comes that we can't just give those 3 to 4 million variants to the clinician and say, okay, one of those variants is responsible for whatever disease that patient is having, or whatever the phenotype of the patient is. From those 4 million variants, we need to isolate 2 to 3 causal variants which are actually responsible for the disease. It's actually a needle in a haystack problem. So how to do that? Manually, a big no, because it's time inefficient, cost inefficient. Then if you're dealing with 4 million variants manually, you are prone to errors, and intense manual effort is required. So that's not at all desirable. Moreover, to give you a perspective, so like MedGenome gets 10,000 samples a day. Now each sample having 4 million variants, you can yourself imagine how much time will it take to predict, to identify manually that, okay, these are the 4 causal variants, and accordingly you can administer these other drugs, or you can decide what way to go and what needs to be the diagnosis or whatever. This is not the way, because there is a patient which is sitting there. It's cancer patient who's waiting for a particular line of treatment. And we can't just, if this is the way we go, then we might take 20, you can do the math, we'll take 20 to 30 days to predict for all the samples, which won't be feasible. So there have been multiple solutions which have been proposed. There are GWAS studies, polygenic risk scores, machine learning models. I'll be focusing on the machine learning model part. So what a typical workflow is, we have the genotype data set. Now the genotype data set here, it doesn't essentially mean only the VCF file. There are multiple other features. I'll talk about it when I'm talking about the data collection. So then we process the data, we clean the data, which is of utmost importance, and then we can apply our own machine learning model. Like for example, we have in MedGenome, we have a supervised machine learning algorithm which we use for disease diagnosis. Once you're done with that, one thing which you need to take care of is the training data set which you take. You need to keep some data set aside for your cross validation as well. So Scikit offers many good packages where you can take your training data set And there's this cross validation where you can split your training data set into multiple parts, into multiple folds. So one part acts as the training, other part acts as the cross validation, and this goes so on and so forth in iteration. So that's the internal validation. And for external validation, you need an independent test data set, and then you calculate the loss of function or how the model has performed, accuracy, everything. So let's delve into the details. So first step is the data processing. So in data processing, what we need to do is cleaning of data. You need to reduce the data dimensionality, any noisy or irrelevant data. Especially you want to remove any dependent features. So because that can lead to data leakage. So a very good example of this, I can tell you, like how data influences your model. So I heard that in one of the talks that they had taken, so company it was a startup, and they had built a machine learning model to predict TB using the neural networks. So they were taking the X-ray images of the lung scan. They had taken the lung scan images, and then the model was able to predict with 100% accuracy if it's TB positive or TB negative, which was quite suspicious. And later on, it was noticed that the ones which were TB positive, they had a small pencil dot towards the end of their image. So essentially the model just focused on that pencil dot. If it's there, it classified it as, okay, that's a TB positive patient. Not there, so it classified it as TB negative patient. So later on they had to retract their paper as well. So you need to take care of what the data you have, the credibility of the data. Then you need to reduce the dimensionality and clean the data, because if you provide just any data to the model, it's just garbage in, garbage out. So once you're confident of your data set, you have removed the independent, you have taken only the independent features, the useful signals, and you've removed the other noisy, irrelevant data, you've dealt with the missing features. Then you move forward to selecting your model. So in our case, what we need is to find the two to three or four causal variants. So we need to map the genotype-phenotype relationship, because that is very important. So for that, to study the genotype-phenotype relationships, there are many well-curated databases online like OMIM, ClinVar. So they tell, okay, if this is the variant, then this might be and if this might be the phenotype of the patient. So they correlate the variants and the phenotype. Then you have variant zygosity, variant type, allele frequency. So all this information you can get from your genotype data from your VCF files. Then incorporate the inheritance feature, patient phenotype, and multiple other features we had incorporated in a model. So accordingly, whatever features you want, you can you can incorporate into your model, keeping in mind that they should be independent features. You can give that as an input to your machine learning model. So what we used was a random forest classifier. So once you've given that as an input, the model will give a variant score, a predictive variance score for each of the following variants. So based on that predictive score, you can determine that, okay, if it's a high predictive score, this has more probability of being a pathogenic variant. If it's a low predictive score or very low predictive score, it might be a common variant. So once you've trained your model, you validate your model, you test the predictive power of the model. So for that, for external validation, you need to take an independent data set. So make sure you don't take the data set from your training set itself, because the model has been already been exposed to that data set. So it will be aware of what all is there in that. So you need to take an independent data set to confirm the predictive power, and you can check you can check the performance of your model using your ROC curve, or you can out of bag prediction score for classifiers like random forest to check how well your model works. So, and we can finally confirm that yes, this model works accurately only if it is able to predict the disease risk, and that maps with the clinical diagnosis as well. So there are multiple existing tools which work on this approach which I've told you, like considering the features from the variant, from the phenotype, mapping those features, having a correlation, then considering the databases which already exist like CRDB, OMIM. So considering all those features, there are tools like AutoGA, which is MedGenome's in-house tool. Then there is this tool called Moon, which is by Deployed. That's a Leuven-based genomic startup company. And there are multiple open source softwares as well. So I'll talk a bit about AutoGA, that's MedGenome's in-house disease predictor. So we used a random forest classifier, and it was able to predict diseases for 97 accurately for 97% of the patients. So the top three variants which we predicted, so those matched if we compared with the clinical diagnosis as well. So one of the major advantages of such diagnosis is it happens in mere minutes instead of hours or days. So this is very critical for a patient who's literally waiting, for to start a course of treatment. So many a times we get congenital disorders or infants which are in need of immediate care or cancer patients. So for that, for those diagnoses, this really matters. And one more ability is it's fully automated, and its diagnostic ability is on par with the expert genome analysts. So expertise in the field is important. So once it's so what we observed was that we are getting that expertise with reduced time, which is definitely beneficial. So earlier it used to take us 3 to 4 hours to identify, okay, for this sample these are the causal variants, for this so on and so forth. But with this it works, and we need not supervise it's fully automated, and we get the results within a few minutes, which this thing helps us to reduce the cost as well of our testing kits, as well as this helps the patient as well. So it's time as well as cost efficient. So I'll just tell you about a case study. So there's this CML, which is the most common types of cancer, okay, and it accounts for 30 to 60% of the adult leukemia. So a common drug for this for the treatment of this cancer is imatinib. So one of our patients, so she developed intolerance to this drug. So what happened is she was on this drug for over a year, but there was no progress. So her doctor then put her on another drug, yet she showed no progress. So then finally what they did was she sent her sample, and we did a predictive diagnosis, and we were able to find that there's a mutation, a typical mutation, which she has, which is making her resistant to both of these drugs. So this analysis was really helpful in planning the further course of treatment. So if people are aware that they can go for diagnostic testing, predictive diagnosis, they can definitely save on to their time. So similar cases are there for prenatal testing. So the challenges which still remain, the open problem, it's the identification of the non-coding pathogenic variants. So, and the other thing is the complex disease prediction. So complex diseases like complex diseases like diabetes. So they depend on multiple epigenetic factors, and there are many variants which are responsible for this, and each variant has a subtle role to play. So such diseases which depend on environmental exposures, behaviors that are still a bit difficult to predict. So complex diseases are still a problem. So we are still developing a model to work on the intergenic regions, the intronic regions, so that we can, improve our model further. So as far as the Mendelian diseases, the genetic diseases are concerned, this approach works really well with 97% accuracy. Okay, so thank you guys. And if you have any queries, you can connect with me on LinkedIn. Thank you.
Thank you, ma'am, for the great session. It was really informative. The next speaker for the session is Pavitra Sole Jawahar, who is a staff data scientist at Swiggy, to give a session on the topic face and mask detection using feature pyramid network.
Hello all, I'm Pavitra. I work as a staff data scientist in Swiggy. So Swiggy doesn't need any much of an introduction. So if your food is late, I guess you can tell us that you data scientists have to probably improve your model. But then most probably in Swiggy we actually do deliver by, let's say, the ETA that has been shown to you. So today we're going to talk about a very interesting topic. It's something about how COVID has affected us, and when COVID came up, it was March end. We were on there was this lockdown in India, and in Swiggy we were looking at how else can we protect our customers, how else can we protect our delivery partners who are coming to deliver your food, right? So what we were looking at is we need to make mask compliance a mandatory for our delivery partners. And the first thing was like, okay, when they're logging in for the duty, we have to see whether they're wearing a mask or not. Unless and until then, we cannot do that. So I just wanted to take you on a journey of how we did it. But even before that, right? Like, I'm sure when you're talking about object detection, a lot of people keep using these terms like YOLO, faster RCNN, region proposal network, etc. But I thought, you know what, I'll demystify this a little bit. Let's talk a little bit more about object detection, and then also see what kind of a model architecture we have used for our face with mask detection, and then a little bit more about how we productionize this model, because the model training and the model architecture is only half the story. So I also want to take you forth on saying what are the real world problems that we faced, and how did it affect production, how does it affect productionizing a model, and how else we can preempt it, and also look at the different things that are available there. Also, I'll take you through a little bit of some of the jargons that are there, like what is Kubernetes, just a couple of minutes explanation on that. So without much ado but nothing, let's get started on mass reduction, the real-time mass reduction, that model that we had deployed for Swiggy delivery partners. I'll be sharing my screen. Right. So what is the problem statement here? The problem statement is that at the start of duty, we have to see whether a delivery partner is wearing a mask or not, right? And masks can be of different types, and as you see in this GIF that I've put in, right? So one thing that as our PM Narendra Modi has said, that you can just be sure that you cover your nose and mouth. It can also be a kerchief, it can also be a cloth, but then protect yourself is what has been said. So what you have told our delivery partners is that wear a mask, but if you cannot find a mask also, it is fine, wear a scarf or a kerchief, whichever it is necessary, but then we do emphasize on wearing a proper mask, and it also has been given to delivery partners and it has been distributed to them. So this is the problem statement that we have, right? So let's look at the different type of mask that our delivery partners wear. So one is they don't wear a mask. This is how it looks like, and this is a Swiggy mask that has been given to our delivery partners. And this is I'm sure I've seen this kind of a yellow color mask, which is this FFP2 N95 kind of a mask. Then you have this reusable masks that are available in the market, wherein they have actually 3 layers or 3 ply layers, and then you can wash them and reuse them. And then we have this kind of mask wherein people wear a handkerchief or a makeshift kind of a mask, and then you have this cotton mask that is there, which is only single ply, and some certain things are actually even made homemade masks that people are wearing, right? So there's different types of masks that people are wearing, and we should need to understand that it's basically not just that, okay, fine, a mask should only be black in color or green in color, etc. So we need to also understand how to do this, right? How to go about and do this. But even before that, so what I thought was we will do a quick primer on object detection. This is more about also to understand, even if you have not worked on convolutional neural networks, it's fine. It's more about understanding the problem solving techniques behind object detection, and how we can how we have gone about and evolved this object detection techniques right from 2013 to where we are right now, right? So what is object detection, right? So object detection versus image classification, it's very simple. So I have this cat, and then there is this picture of a dog and a few cats there, kittens, actually puppies and kittens. So here you are, and to the left we say, okay, we look at the picture and say it's a cat, and then in the right we also say, okay, there are these things, and we also see where are the puppies or where are the kittens in the picture, right? So object detection here solves the problem, solves the question of where is an object in the image. So let's look at it from a data science angle, right? So if you have to classify something, how would you do it? So when you're classifying something, it's basically you have different classes, right? Okay, I have apples, I have oranges, I have watermelon. Okay, these are the three different classes. But when we are talking about object detection, we also talk about something called as the position of where the object is supposed to be in, and that is where we also have to find out, right? So let's say you are this software developer or a computer vision engineer or a data scientist, and a manager has said that, you know what, your solution, you have to find my solution for detecting an object in an image, right? So I'm going to take you through more from an angle of how do we develop an algorithm, right? So let's look at object detection as an algorithm, right? So what is the problem definition here? I'm given an image and the output has to be two things. One is the class of the object and the object's position in the image. That is, let's say I have this box drawn on an image and saying, okay, this is an object there. What object is it? It's a dog or a cat? And then if I'm saying, okay, fine, I'm just looking at the image saying, okay, this is a dog, but where is the dog, right? So both the things need to be there. What and where in the picture is the output for object detection. How to represent this question is more like where is the object in the image, right? And we need to actually pin down that. We need to give those output things. So what are these outputs? The output is basically a bounding box, right? So here in this picture, if you see, there are different objects here. You have this car, you have a dog, horse, person, another smaller another person there in the background that we can see, right? So you have this, how do we define this? Okay, this horse is in this bounding box. The bounding box is basically a rectangle, and we say this is a region of interest, and in this rectangle is where you'll find a horse. In this rectangle is where you find a dog, right? So how do you define a rectangle in an image? So image is basically an array, right? It's just an array of numbers. So here again, if you have to do it, so basically I'll say, okay, if you have to put this in a graph, I'll say, okay, fine, this is x1, x2, y1, y2, right? So you have two Cartesian coordinates, and then say, okay, this is this is where the image starts, this is where the image ends. So whichever way we want, we can actually give the height and width of the image, and then we can say this is the top left Cartesian coordinate of the image, and this is how you draw the rectangle over it, right? So the output here is one is a class, the other one is your the bounding box coordinates. So the first thing, right, like you're looking at an image and you're like, okay, I have to find something in this image. What is the brute force way of doing it, like, or which is the easiest way of doing it? And say, okay, fine, why don't we scan the image? Like, and how do you scan an image? Like, you would be putting a sliding window on top of it, and then you will check, just slide it across the image and say, okay, let's see which each box contains an object or not. So for example, this is a sliding window approach, right? So if you see, the green is the bounding box, the sliding window, and then it just slides across. To the right, you see the region of interest, and it will show you the region of interest from that picture, right? So we first see the sea, and then we see the sea, the fish there, etc. So we are able to see all these things, right? So this is the sliding window approach. But what's the issue with sliding window approach, right? So for example, I have to detect a person, right? A person is something like a box, a rectangular box, in which is probably like a portrait shaped box, right? And the other box, probably a sliding window, will be like kind of a landscape shape, basically saying your height is lesser, the width is more. And here in this case, your width is lesser and your height is more. So however it is, what happens is with a sliding window, it's very difficult to tell that this sliding window is where the box is, because each object has a different bounding box, and it needn't be something that is very close to what size of the sliding window we are using. So sliding window was not a great approach, but then it was one of the few approaches that was tried. The next thing people thought was, let's look at an image, and then let's take some interesting regions in the image, right? So what they did was, okay, fine, let's do a kind of a sub-segmentation of the image, wherein, we look at this image and say, okay, these are some of the interesting regions in the image. And the next thing is, okay, I find this region 1 and region 2 together, can I combine it? So what they did was, okay, fine, let's call it the first initial segmentation, right? And then after a few iterations of it, wherein you do something like a greedy algorithm, wherein you combine similar regions to make a larger region, and then you again make these things, like you just make it more iterative. as you see, in the fourth picture, that whatever we've seen in the first picture, when there are really, really small regions, and then in the fourth picture, you see that it's all been like clubbed together, and you have some 7 or 8 interesting regions that we can look at, right? So first thing is, okay, these are the regions that I'm going to look at. In this yellow color region of that fourth image, I can see a person sitting, or there's some other object there. Probably we can predict it, etc., etc. So first thing that they did was sliding window, and the next thing was like, people are like looking at how do we search for a region, right? So for example, if I have to draw bounding boxes in it, right? So this is how it looks like. So we use the segmented region proposals as a bounding box, and we'll say, okay, I think in these bounding boxes we can find some object. So we call them as candidate object locations, and as we increase the number of iterations, the object locations also decreases. And if you see, the blue ones are the candidate locations, saying, okay, we can find an object here, and the green ones are where the real objects are, right? So with this was the first thing that they did, like wherein they were able to find these regions in an image, and then they said, okay, fine, let's apply some kind of a SVM classification, or to be like some kind of a classifier to say that, okay, this image looks this region looks more promising, and it could have an object in it, right? So but okay, fine, but then don't we do these days face time and whatever it is, object detection or a person detection or face detection, don't we do it real time these days, right? Or at least, even if it's not real time, it happens quite quickly within, let's say, 1 or 2 seconds. So but this, when I'm looking at it itself, right, there's a lot of processing that has to happen, wherein we have to find these proposals, and then we have to do it, etc. So the question was, how else can we make this region search better? Okay, so even before that, right, so once this region search algorithm was there, people are like, CNNs are becoming pretty popular. Why don't we use this CNN region search with the CNN, right? So that was the first object detection network, first object detection computer vision network with deep learning that had come in, called as RCNN, right? Okay, so what you see here is you have an image, and then we actually say, okay, these are the regions in the image, these are the bounding boxes I found after this iteration, and I got these some 10 or 12 bounding boxes. Now for each bounding box, let's do a convolution network on top of it, and then let's do find out where the bounding box coordinates are, or where the classification is happening later on. So I'm actually making it look like a 15,000 feet level explanation. So I'm not going to get down to explain how we use bounding box regression or classification. We will look at that a little later in the talk. So here we are, right? So people are like, okay, I've got an image, I've got regions in the image, I'm going to use convolution network on it, because number one, it gets a better accuracy, and then I'm also able to rather than just doing a SVM, I'm able to do something like a classification or a bounding box regression later on. So that was the first RCNN. The same authors were like, hey, why are we even looking at something like 3 or like for each convolution network? Like for example, if I have some 20 bounding boxes, do I have to run 20 convolution networks? It's very expensive, right? And also increases the time. So they were like, why don't we do it with one convolution network? And that's where a convolution network comes into picture, right? So if we have to say something like what a CNN does to an image is something like it extracts features in an image, which helps us to understand what is there in the image. For example, let's say I'm looking at a picturesque scenery wherein I can see a mountain, a house, and a river flowing by. So basically, a CNN will be like, what it'll have a lot of this convolution layers in it, wherein it extracts the feature, and then it pools the features, and again keeps extracting it, wherein the most important features of the image, which describes a mountain, or which describes a river, which describes a house, are given to you, right? So at the end of the day, at the end of the convolution network, what you actually get is a feature map. And this feature map will have all these features extracted, which describes whatever is in the image, whatever objects are there in the image, right? So you have this feature map, and then people are like, okay, I've got this feature map. Why can't I look at the regions here instead of looking at the regions in the image, right? And that's where they were like bringing an interesting point of view called as, with just one region, can we use one convolution network and get it done? And then the next question was, okay, I've got these regions proposed by some algorithm. I have this feature map, and I'm going to map it. I'm going to do some convolution neural network, and I'm going to get object detected from it. That is our fast RCNN. But hey, why do we even have to use an algorithm to propose these regions, right? So that's where your faster RCNN comes in, wherein they were like, hang on, convolution neural networks are pretty powerful. Why don't we use them to propose the regions, right? Instead of pre-selecting the regions. And that's where the faster RCNN came in, wherein you have a convolution network which you run on an image, and then you get this feature map. And with that, using that feature map, we say basically saying that, what can we find the regions that of interest for us where the object could be, right? And with that, later on, they would be like, okay, fine. Can I say whether it's an object is a cat or object is a dog, or where is the cat or a dog, right? So basically, if I have to paraphrase the whole thing, it's all about finding the regions where an object could be. That is our next objective, right? So that's what we have been doing here. Earlier with an algorithm, and then we had computer CNNs running over the regions proposed by an algorithm, and then we also had and then we also had the next thing is a CNN proposing this regions for us. Okay, that's nice. So what do we have here? We have devised an object detection model which uses two stages, right? One is a region proposal network. The other one is the later part of the network, wherein, or the model, where we say, okay, I'm going to use regression and I'm going to use classification. Okay, why do we need to use regression and classification? Regression is basically like, for example, a linear regression is an example of saying, I need to find or project the sales for the next month, right? So that will be in numbers saying, okay, you sold like for 5 lakh cars this time, you'll be selling 5.6 lakh cars this next month, or something of that sort. So you basically have a number. And classification is more about categories, saying, okay, this is a car, this is a truck, this is a bike, etc. So a bounding box regression is basically, we're talking about the two outputs, right? So you'll be looking at the coordinates, which is basically the yellow dots that you see here, and then the class, which is the person. So if I have to say where is a person in this image, I'll have to give all the 4 coordinates, and then I have to say where the person is, which class of the box it is, or which class of the object it is. It is a person, right? In other words, so basically your output is this. What is the probability of what class it is, and your bx, by, bh, bw, which is basically your bounding box. So the next question that came up was, why do we need 2 stages, right? Like, okay, you need to propose what regions are good, and then we run on top of it, etc. But why can't we do it at one shot? I mean, that was a very interesting way of looking at it. So for that, people were like, instead of proposing regions, why can't we look at an image grid and look around for objects? So basically, it's like a top-down and bottom-top approach. Bottom to top is saying, okay, I have an image. I'm going to, create some regions of interest here, and then I'm going to see if these regions of interest actually have an object or not. Top to bottom is, I see an image. I'm going to pick a point in that image, and I'm going to look around the image. For example, right, let's say I'm going to pick something like one red box here, whichever it is. Or let's say I'm going to look at the red box, which is kind of the center of this person that is standing there. And I look around that box and I'm like, hey, I think I'm part of, when I'm looking around this image, I can see a region where there is a person there, right? Or probably the cyclist standing that is next to her, wherein you can say, okay, fine, I'm in this image grid and I'm looking around from this image grid. I'm able to see something. Right? So this is where YOLO came into picture, which is basically saying you only look once. YOLO's biggest disruption when it comes to object detection was that instead of doing a 2-stage detector, it said, why don't we do it just once? Instead of saying, okay, these are the regions and proposing the regions, I'm going to look around. I'm going to stand in each grid of the image, and I'm going to look around and say whether that grid is part or has an image in it or has an object in it, right? For example, let's say a person standing next to a car, and we have a 3x3 grid on top of it, right? And let's say I am in grid 8, right? And grid 8, I can see, from the grid 8, I can see to the left and the right a car, on top and bottom a person. right? So this is where the next concept came in, called as anchor boxes. So what anchor boxes are basically that given a grid cell, right, we actually will look around it. How do you look around it? So basically you'll have to look around it in boxes, right? So some boxes can be like, okay, if it's a car, then it has to be probably width has to be more, because the object is kind of, wherein it's a longer object. And if it's a person, definitely a taller person, so the height has to be more. So you can define your anchor boxes. You can go stand in one grid cell and look around using these anchor boxes, basically saying, okay, I'm going to look around. It's something like a filter that you have, right? I'm going to stand in front of this image, or no, I'm part of this image, and I'm only able to see with this box what is around me, and with this box what is around me. So instead of region proposals, each grid will look around itself and say that whether in its anchor box can it see an object. And it was a very interesting way of looking at it. So if you see, right, this is more of a problem solving technique rather than just a neural network way of looking at it. It was like, hey, how smartly can I look for objects in an image? So the next thing that they did was, since we have anchor boxes already, right, it's not like in a regression wherein, I had to say, okay, the x1 x2 has to be like, for example, let's say it's 50 cross 50 by 100 is my x1 x2, right? And regression is something like, okay, 35 cross 50 is where I get, etc. Now it's not like basically in this case, right, what they are looking at is, this is a bounding box regression. It's not a kind of a single number regression. So if it's a bounding box regression, why can't we just look at, okay, this bounding box, I've got this bounding box, but the real bounding box is probably this is the displacement of the bounding box. So you move this bounding box to the left and to the top, and you probably extend it a little bit to the right. Hey, you got the object that you're looking for. So it is basically using the bounding box as a unit for regression rather than just looking at the coordinates for regression. So there's a very interesting thing that they did, right? But YOLO was, when it came in, it made real-time object detection possible, even with faster RCNN. Though the accuracy was great, it was good, but then YOLO was something that even a simple man can use. It was like, it doesn't need a really very expensive GPU to have it real time. And it also had this really interesting way of looking at the whole thing, rather than saying, okay, these are the regions, and then looking at it. You're going to basically divide the image into grids, look around it using anchor boxes, and these anchor boxes, basically we will be running a CNN on top of it, and then it will say, okay, I think I have enough features to say that there is an object in my anchor box, or there could be an object in this bounding box, or and this anchor box can carry this class of this object, like saying, okay, probably I'm seeing a person here, probably I'm seeing a car here, right? So right. So, but what actually happened was, if you imagine this, okay, an image is, let's say, some, let's look at a 250 cross 250 image, right? And if I divide it into, let's say, some 25 grids, 25 cross 25 grids, whichever it is. And for each grid, if I'm going to say, you're going to have 5 anchor boxes or 9 anchor boxes, whichever it is, you are going to have a lot of anchor boxes which are not going to be useful for us, which is basically something like your background image or information that is not needed for us when we are looking at object detection. And some bounding box, some anchor boxes will have very rich information and say, okay, fine, hey, I think I have already seen a horse here or a person here. Probably I'm this important anchor box that you have to consider in your network and bubble it up. And these are some of the things wherein it's more noisy and we don't get enough information from it. So again, looking at it, this is something very similar to what we'll see, right? Like in each of the center of a grid, right, if you look around it, these red ones are actually the negative proposals, basically saying, okay, there is no object in it. And then your green ones are the real proposal networks, like saying, okay, I think I see an object in it. And the blue ones are our ground truth, basically saying there is an object in it and this is where the object is. So if you see it, the reds are more, but then the greens are less, right? So is there any way we can kind of say the greens are more important than the reds here? Okay, so this is where I was just thinking about, let's say you're sitting in a stadium, right? And there are like some 70,000 people in that stadium. And Dhoni is there, and he's just pelting sixes and sixes, and his famous helicopter shot, and he just goes like and says fish, and then it goes for a 6 again. Okay, so the whole crowd is like shouting. And how do you know whether you, like, let's say you're just looking, or you're just hearing the audio of the whole thing, right? And you didn't know, hey, did Dhoni hit a sixer, or was he bowled out? We don't know, right? So someone there would say, okay, fine, the crowd is chanting, the 70,000 people are chanting, but the three commentators who are there, right, they are the most important ones. You have to listen to them. It's like giving more importance to the commentators than the 70,000 people who are shouting, right? And that's how we are even able to hear a commentary, right? So this is very similar to it. The reds are the people shouting, the green boxes are basically the commentators. So this is where, to improve YOLO, there are two things that people are looking at. One is, can we use something called as a focal loss? Okay, I didn't talk about what a loss is earlier. So in very simple terms, a loss function is something like an objective for the whole machine learning algorithm to learn. That is, let's say, for example, I have this max exam, and in calculus I'm only getting 65, right? And my objective is to, let's say, get 95 or 90 or whatever it is. So I have to get to my objective, means I have to learn calculus a little bit better, or probably make less mistakes, and probably make understand the concepts better, and that's how I improve it. That's how I learn. And it's very similar to this. A loss function is basically an objective with which my machine learning, or a CNN computer vision model network actually learns. So here in this case, when we are looking at the loss function, what we are trying to say is, we're saying, okay, it's something like saying you getting answers correct is more important than you getting answers wrong. That is basically saying, okay, give more correct answers. For example, there is a multiple choice question, and then someone says, okay, if you're going to give correct answers, you get 10 marks. But if you're going to give wrong answer to it, it's -2. Right? So in this case, we will be focusing on giving the right answers. And this is how the objective has been met, right? Like, wherein you have modeled the objective such that the person has to give more correct answers than wrong answers. So in this case, what we're doing is we are modeling the loss function such that it gives more weightage to this green boxes being closer to the orange, to the blue boxes, rather than this red boxes getting more importance. So it's basically the commentator versus the stadium person kind of a thing. So we use something called as a focal loss. The next thing is, what is the biggest problem is that object deduction, it's unlike machine learning algorithm, right? So in object deduction, you have different things, right? Like you just look out of your window there, you see something, and you see some different objects there. You look inside your house, you see a table, you see a chair, you see some other different objects here. So each one, like for example, when you're looking out of the window, you probably will see an aeroplane, and it's high up in the air and it's really small. How do you detect that airplane versus this chair, which is actually smaller than an airplane, but it's next to you, but then it has a bigger view for you, and then I'm able to easily detect a chair versus an airplane, which is really small, right? So the small object, big object problem was there. So in object detection, what people are doing is, okay, we kind of solve the focal loss, like basically saying these are the important anchor boxes, these are the background anchor boxes, let's not focus on it, let's give more importance to these anchor boxes. People are like, we need to zoom in a little bit to understand the smaller objects in an image. So one way of doing it is probably having different resolutions, right? So you could say like, okay, I have this 1000 cross 1000 resolution image. I'm going to do a CNN on top of it, and I'm going to get a feature map. I'm going to do next is 500 cross 500, etc., etc. Okay, what is the intuition behind this? Let's say you have a image, right? And let's say you want to like see some of the details in the image. What do? You zoom into the image, right? You're like, okay, zoom in, plus, 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 plus. Okay, I can see a bird here. So basically, when you are in, what is actually happening is, if I'm going to have a smaller resolution image, I'll be able to find the bigger objects easily. But if I'm going to have a higher resolution image, I can see the smaller objects easily, right? So this was the biggest intuition there. As the slide says, detecting objects in different scales means that you have to use multiple scale images, right? And this was an intuition that they got, and they were working on it. And they were like, okay, I will create a pyramid of images is the next solution that they had. They're like, okay, what do you mean by pyramid of images? Okay, let's take an image. It's 1000 cross 1000, 800 cross 800, 600 cross 600, 400 cross 400. And for each, I'm going to create a feature map, probably saying that, run it through a convolution network and get this. and using that feature maps, do a region proportional network or an anchor boxes on top of it, the YOLO way has just done, right? So even then, right, what is actually happening is if you're going to do it for each different scale, it is too time consuming, and we will not be able to hit the mark that we want having it real time, right? So this pyramid of images was not a great idea, and people are like, okay, instead of pyramid of images, let me just probably do something like feature maps, like basically creating, okay, I'm going to do 1000 cross 1000 convolution, and then the feature map reduces to 750 cross 750, and then using that I'll predict from this feature map, and then I'll again make some convolutions, and again I'll get another feature map of 500 cross 500 using this feature map, let me predict. And then in that way, right, so they were doing that too, but even then the accuracy didn't improve much. And you know why? The reason was that when you are very close to the image, right, you might not have much semantic value. That is, when the convolution neural network, when the layers are closer to the image, basically we have not convolved and got more features extracted to understand or describe what is there in the image, right? So, but then that particular place wherein this, when you're closer to the image, the location of wherever the objects are, that information is there though. So what people said was, let's actually pull all these things together and create a feature pyramid network. Okay, I know it's a mouthful, but I'm just going to now break it down. So we have this image. We need to kind of zoom in to understand small objects and big objects, etc. So what we do is, okay, let's do it in different scales of image and then predict it. Okay, that was not a great shot. And then they said, okay, why don't I do it using only feature maps? With feature maps, when you're actually, the thing is, when you're going smaller and smaller, you're losing this context of where the object location is. So the accuracy wasn't great. So people said, you know what? I'm going to do this bottom to top and top to bottom kind of a feature pyramid. Okay, so what happens is you have a backbone network. Like if you have heard of these words like called as RESTnet or BGGNet, great. So basically your mobile net, NestNet, whichever it is, that will act as your backbone network, which is your feature extractor network, right? And you basically do the usual one wherein you take an image and then you keep convolving on top of it, and then you get smaller and smaller feature maps. Now what you do is you kind of do the reverse. You go to bottom to top. So what I do is with this feature map that I've got, I'm going to kind of increase the resolution of the feature map, and I'm going to add from the previous layer of the feature map, from the previous layer of the backbone network, or it will look something like this, wherein wherein something like this, right? Wherein, okay, if you have seen a computer vision neural network, it's something like this, wherein you have this image and then you have this layers, and this is a bottom up. The top down is going to be like, I'm going to take the last layer, I'm going to increase the resolution, I'm going to add from this convolution C4. So what is happening is we are adding more context. And when in this world of CNNs, the most important thing is how feature rich are your feature maps. How are you including all the information that you can get, the location, the description of the image, etc., in your feature map, right? So basically they were like, okay, first we will run this up, and then we also get a top down, basically including both your semantic information as well as your location information. So basically it's like this backbone network will give you more semantic value, but at the same time what happens is the location features might not get captured. So but the top down will be like, okay, I've got all the semantic value, but I'm going to go down, and I'm going to gather all the location intelligence value from the lower layers. So what you have is a mixture of both semantic value, that is description of the feature descriptions of the image, as well as something like where are these images located, some sort of a location features that are there. So you mix both the things together, and then you get this sort of a feature pyramid network, right? So one is you can only take the lower part alone and say, okay, fine, I just did the whole thing, I went up and came down, I've got more information on semantic value, on location and location features, etc., and I'm going to use the last one feature map that I'm going to use and use it for prediction. Or you can say, you know what, now that I've got different types of feature maps, right, this will also capture something like our zoom in zoom out effect, like saying, okay, this feature map might capture smaller objects more, this feature might capture larger objects more. So I'm going to predict all these things so that it will be able to, let's say, for example, in a picture wherein the chair as well as your aeroplane is there, the smaller objects can be picked up by one feature map, and the chair can be picked up by another feature map. And you can actually do a prediction for all these three. And then, you can do for each class something like a box voting, or saying, okay, you got more probability for this class, and I see that you are in this place. Okay, this is the bounding box that you are in, and this is the class that I'm going to assign you. Right? So this is a very interesting thing that has happened. These feature pyramid networks have been in use for a lot of things. So I've been talking about object detection, right? But object detection is the baseline for a lot of other things like text detection or face detection, etc. Your face is also an object accordingly. Your text is also another type of object. That's it. So basically what we are doing is, your face with mask detection is a type of object detection. And here in this case, what we all learned that, what we are going to do some understand regions. And with regions, basically we can use anchor boxes. And with anchor boxes, probably we need to give more importance to anchor boxes which are more in the foreground and not in the background of an image. And the third thing that we learned is, okay, how well can we even make this feature extraction better such that we can do it for small objects as well as for big objects, right? So we're going to use the same three concepts in our architecture called as retina face. Okay, so I think we did a lot of theory here. So here in this case, right, what I was describing about feature pyramid networks are the crux of the architecture called as retina net. And there was another the people who actually, the authors who actually did the single stage dense phase localization in the wild, the CVPR paper. What they did was, I'm going to use this retina net, but I'm going to customize it and make it more better for face detection. And what we done is, we have taken this architecture. Okay, you did it with face detection. Can we adapt it to face with mask detection, right? And the thing is also, right, when you're using this kind of architecture, it's also very important that you don't think about, okay, today I'm only going to face with mask detection. But what if later on your business or your product team comes and says, hey, I want to know what type of mask it is. Or business says, we're not able to recognize who is wearing that mask. Like, is there any way I can see that is the right person that is wearing it, or is someone else? Facial recognition with mask. So you basically, when you use a very feature rich backbone along with the very contextual anchor boxes or this kind of architecture, these things will also help you with the downstream task, like, for example, your facial landmark recognition or facial recognition, etc., etc. So let me just go show you how we did it. Let me just show you the one second. Okay, so I just built a small app because this is the model, and I just wanted to show the image as well as the output. This app is created by PyQt5 using it's a Python GUI that you can all use. It's pretty easy to use. So let me look at some of the demo images that I've got for you, some different types of images. Okay, so let's look at something like this, right? So there is this person wearing a standardized mask, which is like a reusable mask. Let's see how a model reacts. So basically, we are able to, that's a bounding box that we have got, and it says it's a mask. We are able to detect it's a mask. Let's say I'm going to give some other, this is sort of like a bad lighting kind of image, wherein there's a lot of lighting and we're not even able to see the image properly, right? And in that case, it says there is no face that is detected. And it's not even saying there is a face detected and the face doesn't wear a mask. So our model doesn't really do well, especially for these kind of images, wherein, it's kind of blurry and then the face is not seen properly, right? And let's say something like someone using this kind of a mask. Yeah, it detects properly. The next is something like a cotton mask. Does it detect properly or not? Yeah, it does detect. So you also have our Swiggy mask that we are providing. Yes, it detects. And someone wearing a helmet as well as the mask. Yes, it detects, not an issue. So someone wearing a cap and then doing this, it deducts. And someone wearing a kerchief, something like a makeshift kind of a mask, not an issue, it still deducts, right? But okay, I've been showing all the good stuff where the model actually does a good work. Again, a different kind of a mask, it deducts. Okay. Okay, we saw what the bad lighting is. There's something called as a motion blur, right? In this case, it did not detect, right? One is probably the model, right? It's very blurry. Probably the model is not doing well when you have a lot of blurred images. The other thing is probably, this kind of a scarf, or probably the model thinks, okay, it's pink in color, and I have not seen a mask that is pink in color, so I don't think it's a mask, right? So the next thing is, okay, so basically,
Excuse me,
yeah.
ma'am. Sorry to interrupt you. Actually, the audience are not able to see your screen, ma'am.
Oh, is it? Sorry. One second. Oh, that's. I'm really sorry. This is it. One second. Let me just get the demo running. Can you see it now?
Yes, ma'am.
All right. Okay, so let me just run it again. Okay, so okay, so I'm going to show something like image of this sort, wherein, yeah, this one wherein, okay, he's wearing a reusable kind of a mask, and you see the red bounding box. That's the bounding box that says, okay, this is where the mask is, the face with mask reduction. And then the next thing is you have Swiggy mask, wherein someone wearing a helmet, right? Does it deduct? Yeah, it deducts with the Swiggy mask and also with the helmet. That's not a problem. And the next thing I wanted to show is someone wearing a cap, right? Is there an issue there? Not a problem. It's still able to detect the bounding box slightly off, but it's, I would say the IOU must be something like IOU is basically your the region in which you have to look at, like basically saying, this is the bounding box that we're expecting, this is the bounding box that you've got, and there is an overlap of say 95% or 90%. And someone wearing a kerchief, right? Not a problem, still deducts. But let's say someone wearing some other kerchief. This is what I was talking about, wherein someone is wearing a pink color scarf. Probably the model has not seen enough pink color scarves, and also it's kind of blurry, and the model doesn't do a good job of blurred images. This is a cotton mask, and the model does a good job. It's able to do it. But here, for example, I'm going to show a place where it's a failure case. It doesn't detect. And you know why? Mainly because of the lighting. And it's just because if you see this image itself, right, it's sometimes in computer vision it's so obvious that, oh hey, I actually see it, why is the model so dumb it's not able to figure it out. But here in this case also about the input qualities, the image quality that has to be good. It doesn't have to be your DSLR camera, but at the same time the light has to fall on your face. Illumination issues in computer vision are a big challenge, and this is one of the things wherein it doesn't detect. Probably the same person who's, let's say, he kind of stands in front of or a little bit well lit situation, or even in daylight, you wouldn't have had an issue. So this is another one more wherein it's a false positive. Wherein again it's a very bad lighting and you can't even see the image, right? So the reason why I'm showing you this is this: when you are doing computer vision models, right, one is understanding the intuition of the model is very important, yes, but that's half the story. The other half is understanding your real world problems. We have got images even which are like really worse than this, and sometimes you also have to place some constraints saying your model cannot do everything. Like it can probably handle 80% of the cases, but the 20% where it's extremely bad, we have to put a constraint saying, hey, I think you're standing in a place where the lighting is not good. or you're just like probably keeping a thumb, or you're just like moving your phone a lot more and your selfie is getting bad. So probably we need to add some kind of a check there. If it's an Android app, probably we need to keep a an Android app, write a small check saying, include your OpenCV library there and say, hey, can I run a Laplacian or some sort of a brightness check saying, okay, it's too bright, can you, or too less bright, can you stand in a place where it is a little bit better. So basically give a small check, a kind of a sanity check that will help you get your input parameters better and your image quality improves, right? So yeah, in this case again, it's a failure case, right? So let me go back to the Okay, so we just saw the demo. The next thing I want to talk about is data augmentation. So you've got images, you've got a data set probably, but you see the real world problem, right? Wherein the lighting is less. Probably you can increase the contrast, you can decrease the contrast of your images in the data set, increase and decrease the brightness a little bit, add some kind of a blur artifacts in it, just, make the image a little bit blurry or noisy, or add some more kind of noise in it, just like, wherein or reduce the resolution of the image really bad, or just add some kind of a noise is basically like a white noise kind of a thing that you see in your TV, right? You can add something of that sort. So with these things, when you actually distort the images to some extent, right, you're also making the model a little bit more reliable when it's not going to be given an ideal input. So data augmentation is a very important thing. And okay, now the next question, this is the next part of the talk I want to talk about. How did we productionize it? What are the important things there? So what we did was, I'll just show you what we did earlier. The model V1, which we took to production within, let's say, a week or so, was that we used a data set called as a MFRD data set, which was available and it is open source. So please check if there are any license issues. I know in India we don't check that, but it's very, very important because it's also about being ethical. It's a lot of work that people are doing. So MFRD is a data set that I had used, and we trained on it. But what I saw was that this data set, right, it had a lot of Southeast Asian faces in it. And with Southeast Asian faces, it's also that in India that our skin is slightly darker, our skin tone is slightly darker, and it's a bias of that model that when you have a darker skin tone person, it doesn't even detect properly, right? Just like how Lakshya was talking about model bias, etc. So we were like, okay, fine, let's work with this. But if you have to reduce the bias, it means that we also need to create a data set of our own. So what we did was, when people were starting to like getting selfies, getting it done, we did an annotation by ourselves, wherein we got these in our app. We are able to get this images. So we did a small annotation tool wherein we took 20,000 images for V2 and 20,000 images for V3 model. And when you're looking at these images, right, it's also about how you are curating these images that becomes very important. Let's say, for example, you're running a SQL query and say, select 2,000 images from this data set. I'm sorry, from this database table. And okay, now I've got this CSV file. Oh, okay, fine, let's go annotate. No, it doesn't work that way. What if it's the images have only morning images, right? And morning images is not a problem. Like it's the lighting is good and it's not going to be a problem. What about during evening? What about during night? What about in different cities, right? In probably Bangalore, it's different. I mean, your distribution is different, data distribution is different. In Chandigarh or in let's say Jaipur, etc., and other tier 2 cities, how is it happening? Do we need to also collect some images there? We also need to look at that, right? The other thing was very interesting, wherein sometimes it's per delivery when we have to check, or when they have delivered something. So basically there could be one delivery partner and you could have done some, let's say, 10 deliveries. And if I'm going to not use unique delivery partner IDs, I would be using the same 10 images of that person, right? And the same mask. So it can again skew my distribution. So it's also about looking at, okay, fine, each person gets one chance in the data set kind of a thing, right? So when I'm saying 20,000 images, it should also be 20,000 different persons' images, not just, let's say, okay, 15,000 images of different people and 5,000, there's a lot of repetition or something of that sort. So that will be a problem again. So this is a very interesting thing that we did. It's also about annotation is a very important thing. When you're looking at a data set creation, If you have someone in your team that can do it, if you have like 2-3 people to do it in your ops team, great. Build this kind of a simple tool out, or you can also use an open source tool, and you can put these images in. It will be very helpful for them to do it, right? The reason why I also built this annotation tool is that I wanted the annotation process to be faster. It's like more or less like how else can we utilize our ops team to really do it quickly, like annotation within like say for an image within 30 seconds. How else can we do that? The other thing is also we're all humans. There's going to be some kind of a problem when we're annotating it. So it's also good to have someone annotating it, the other person checking it. So it's called the maker checker kind of a process. We use this, and the error rate was less than 3% for us, right? So we had a really good data set of 40,000 images. I mean, it's also about that, when you're saying resource utilization, you can't say, okay, I'm going to have like, I need 1 lakh images, and I need this 10 people annotating it, etc. You also use the resource that you have and make the best out of it, right? And model 1, we had used MFRE dataset. The score was around 88%. The accuracy was around 88%. With model V1, sorry, it's model V2. With the Swiggy dataset, it was 92%. And right, so this is more about the model architecture, model training, and data distribution, data augmentation, etc. How about productionizing this model, right? So when you look at productionizing the model, so the thing was, when you're a computer vision practitioner, one thing that you should also look at is we have to stand on top of the shoulders of these geniuses, these giants who have done a lot of work for us, right? So this retina phase, the paper was written by the authors. They are also given the code and said, hey, the code is Apache license or MIT license, whichever it is. You can use this code. You can change the code if you want, but then you have to train your own model. You have to use your own data and train your own model. So it was a MXNet based code, and we were like, okay, fine. MXNet is also very interesting. It's kind of in between PyTorch and TensorFlow, I would say, in my experience. And you can write MXNet in any language, in Java, in C++, in Python, etc. And the next thing is, for productionizing it, we use a Kubernetes-based scaling. So, okay, I know you must have heard this Kubernetes word being tossed around a lot of places. So why Kubernetes? What is this? So, for example, right, let's say at night 3 a.m., not many delivery partners are going to be around. But let's say at around 11:30 or 12 o'clock, a lot of people will log in for the lunch shift, right? So when people log in, probably the requests per minute, that is when I'm going to call an API, I'll say, okay, we call it like, okay, how many times are you going to call this API per minute? It's basically your request per minute. I'll say, okay, fine, it's 5,000 requests per minute or 10,000 requests per minute, which is like a little, which means that you need to have more API copies to counter it. The sense, let's say you're going to the bank, only like 2 people are there, and then there are like some 10 counters. Then you are like, okay, the other 8 people are not being utilized, right? So it's good to have just probably 1 counter for 2 people is good enough, or 2 counter for 2 people is good enough. Let's say suddenly there's 100 people are there in the bank, and then there is only like 2 counters. So many people waiting, and it's a lot of time being wasted, right? So probably you might have to increase the counters to, let's say, 10, and probably your time to time to turn around or tat or whatever, it reduces. So Kubernetes does that. So basically, when it's a very lean period of time, it will be like, okay, I'll just have this 10 instances or like 2-3 instances that are running that can just handle the APIs that are going to be called right now. How many times the APIs are going to be called right now? And let's say it's lunchtime, and it'll be like, okay, fine, I think let's scale up and probably put like 300-400 instances so that we can handle this load better. So Kubernetes does that, and it does a really good job, and it's very interesting to also learn more about Kubernetes, because at the end of the day, it's not just about understanding a model, it's also about how you're going to put a model into production, right? And the next thing is, there was another one more thing wherein basically we're doing CPU inferencing here. We don't do GPU inferencing, mainly because of cost. And CPU inference is good enough for us, because I just need the model to reply, let's say within 1 second or so, or 500 milliseconds, half a second is good enough. It doesn't have to be 20 milliseconds with a GPU. So to even make it better, there's another one more library called as MKL, which is a numerical library in which it makes NumPy or pandas, those your CPU inferencing really faster. And this is our API error rate, which is like less than 0.1%, and 50% of the API requests are handled within 400 milliseconds. and the 95th percentile is probably around 700 to 900 milliseconds. The 99th percentile is probably around 1 or 2 milliseconds, 1 or 2 seconds. So I was talking about this pre-processing check, right? So this is one more thing wherein you can use brightness, contrast. It's basically called as natural scene statistics, and then you also have this interesting image properties that you can use and say, hey, I don't think your image that you're trying to capture is good, and you can probably have a check there and say, can you take a better image with a better quality, right? So this is also something that we can do. So yeah, that's pretty much about what we have done. The few things that we're doing right now is what kind of a mask are they wearing? Is it something like a kerchief, or are actually wearing a proper mask, something like that they've got in market or that we have distributed? The next thing is also facial landmarks, right? If you're known face detection, basically facial landmarks is basically giving your coordinates to your nose and to your mouth, etc., and your eyes, etc. And this is also something that's very important later on if you're going to, let's say, do a 3D reconstruction of the face or face with mask detection, etc. So facial recognition, how do we use the same features that you have derived from face with mask detection, this retina face model, how do we use that, right? So these are things that we're looking at. So yeah, that pretty much comes to the conclusion of my talk or my workshop, whichever way you want to perceive this. So my Twitter ID is PaviSJ, and you can also reach out to me in LinkedIn. Type Pavitra Solai, and I'm kind of going to be the first person on your search. So that's pretty much it. If there are any questions, please let me know.
Thanks for the session, ma'am. It was really informative.
Cool. So do we put anchor box on every grid? Yes. So basically, right, Umang, what happens is that you can also make your own anchor boxes, basically saying, okay, I'm going to do a 3x3 kind of an anchor box, or I'm going to make a 9x9 kind of an anchor box, or I'm going to say 3x6 or 6x9, whichever it was, right? So yeah, the whole point of the reason why I even didn't go into the in-depth of convolutional neural networks is that deep learning, especially computer vision, is you have to understand object detection really, really well. And it's basically, I have paraphrased the whole of a 5-hour lecture in 1 hour. So I might have missed a lot of these minor details, but just get this point that, it's more about problem solving, as well as also using a lot of common sense, saying, okay, hey, how else are we going to improve our features, right? That is the most important thing. So yes, that's pretty much about it. So great, guys, thanks. Any other questions? So yeah, I think what I would say is, right, if you want to get into computer vision, right, do some courses if you want to. Probably Coursera, or there are a lot of these object detection courses. Or if you like reading, read a very good blog, but be at it. It's okay, you might not understand in the beginning, but just be at it. Okay, because you have to get these basics, right? It's like your data structures when you're getting, let's say, for your developer or whatever you're doing it, right? It's like you need to know your data structures, otherwise you're not going to become a software developer. So it's similar to that. Cool. Thanks a lot, guys. Thanks for the opportunity, WiDS. Thanks, Usha. Thanks, Samuel. Thanks for arranging this for us. It was a great talk. Thank you.
Thank you, ma'am. Yeah. So the next speaker for the session is Kavita Yogaraj, who is a data scientist at IBM Quantum, for the topic Introduction to Quantum Computing.
Hi everyone, can you all hear me?
Yes, ma'am.
Hi Samuel. Can you please add Carmen as well?
Sure,
Kavita
ma'am.
and Carmen. You added, okay.
This is an two speaker session. So the other speaker is Carmen, who is an AI data science and quantum computing at IBM. So both of the speakers are going to give us a session on introduction to quantum computing. Welcome, ma'am.
Thank you. Go ahead, Carmen.
Okay, hello everyone. Thank you so much for inviting me to be with you today. I'm really happy to share the next hour with all of you. And I hope that Kavitha and I will make clear what quantum computing is and what are all the online resources that you have to keep learning on your own. So I'm going to go ahead and share my screen. Okay, can you see it now?
Yes.
Okay, great.
Yes, ma'am.
Then let's begin with the agenda. We're going to talk about the motivation for quantum computing, why we need this new kind of computers. Then Kavitha is going to explain the basics of quantum computing, how do they work, how do we build them. So she will talk about the hardware as well, and how do we use them. So she will focus as well about the software. And we will end up talking about the Qiskit community and showing some specific examples that are related to AI in the section that we will call quantum machine learning. So let's begin with the motivation for quantum computing. Why do we need this kind of computers? And I always like to start with this slide where you can see the big picture of what are the biggest three trends right now in computing. What we call classical computer is what you already know. It's not just the usual laptops that you see, but also high performance computing, servers that include GPUs for acceleration in the case of some scientific calculations, or also deep learning trainings, for instance. And this area of computing has been inspired by mathematics. Here, the basic unit of information are the bits, and is what we are more used to today. Then, thanks to AI, we have been starting to look at nature and how biology works and how the human brain works. And we have a new kind of computing, which is neuromorphic computing, where the basic unit of information is inspired by neurons. And finally, when we have started looking at a very concrete part of physics, which is quantum mechanics, the part of physics which studies how matter behaves at a subatomic level, at the level of subatomic particles such as electrons and so on, we have developed a whole new kind of hardware which behaves according to the laws of quantum mechanics. And that's where quantum systems come into place. And here, the basic unit of information are what we call qubits or quantum bits, which Kavitha will explain to you about a little bit later. Okay, and I also always like to talk about this supercomputer, which currently is the most powerful supercomputer in the world. It is called Summit, and it is made of more than 9,000 processors. It has 27,000 GPUs, and it is able to perform 200,000 trillion calculations per second. So why am I showing you this supercomputer? Because I want to ask you, if do you think there is any problem that this supercomputer cannot solve? And it may be hard to believe, but the answer is yes. There are still some problems that we call intractable, because even for this supercomputer, for the most powerful supercomputer in the world, it will be too difficult to solve. When we say difficult, we talk in terms of computational cost. So it means that it will take too much time, or that the computer is not big enough. And to give you a little bit of background, who came up with the idea of building this new kind of computers, these computers that behave according to the laws of quantum mechanics? And here you have a photo of the first conference of physics of computation that was celebrated in May of 1981, and it was hosted by IBM and MIT. And in this picture, you may see most of the people who are considered the fathers of quantum information theory and quantum computing. Not just the people who are and appear in the picture, but also the person who took the picture, which is Charles Bennett, as you may see in the bottom of the picture. And a person that came to this, that attended this conference, was the first one who challenged the world to build a quantum computer. And it wasn't just anyone, but it was the winner of a Nobel Prize in physics, Richard Feynman, the well-known Richard Feynman. And he did it with this quote that is now part of the history of quantum computing. He said that nature isn't classical, and if we wanted to simulate nature, we'd better make it quantum mechanical. Okay, so what are these kind of problems that are intractable, that not even the most powerful supercomputer in the world can solve, and that Richard Feynman was talking about, these problems that he found in nature? Here you have a slide with a very simplified classification of problems in terms of their complexity. Okay, so we have basically two big classes. The first one are easy problems, which are the problems that we can solve using classical computers. And then we have the hard problems, which are the ones that we cannot solve with classical computers. And what do these hard problems have in common? Why do we say that they are hard? What they have in common is that as the problem size increases, the time and the computational resources that we will need to solve that problem increase exponentially. That is, they increase very, very fast. So for instance, consider an optimization problem where we add some more scenarios. Just by adding a couple more of scenarios, the time and the computational resources that we will need to solve that problem, if it was a hard problem, would explode. So it would not be feasible anymore to solve it with a classical computer. But we already know from for some time now that if there existed a quantum computer, there are some quantum algorithms which solve some of these hard problems efficiently. And let me just stop here and let's think about all the amazing things that we have done just by solving these easy problems, are small proportions of all the problems that we know. We are able to send a satellite to the space. We have been to the moon. We are able to talk to people who are in the other part of the world. We have done research in material science, drug science. We have done amazing things by just solving a very small part of all the problems that we have. So imagine the potential if we could explore a little bit further. And Kavitha is going to tell you about some of these use cases, potential use cases that we have for quantum computing that are some of these hard problems that we can solve with a quantum algorithm running in a quantum computer. And from here, I'm going to head it to Kavitha, and she's going to explain you how a qubit works.
Thanks, Carmen. I'm going to share my screen as I will be taking two websites. Let me know when you can see the screen. It's easiest. Okay. Is my screen visible?
Not yet.
No, ma'am.
Okay, now, yeah. it is
Yeah.
visible now.
Okay, good. I want to make this full slide, right? Okay, you can see the screen now,
Yes, ma'am.
and it's full screen. Okay, so we were here, and Carmen explained why we need quantum computing. And when we come to quantum computing, sorry for the noise here. There's a construction going on behind my house. I'm sorry about it. So when we come to quantum computing, we will have to work with quantum bits. It's not going to be the classical bits that is 0 and 1, what it was in our normal classical computer, right? So here it's going to be quantum bits. When we come to quantum bits, there's the fundamental thing has to change here, because we are talking about quantum mechanics being the underlying theory of quantum computing, right? So it can, in quantum bits, that quantum bits called as qubits, it can take the value of 0 and 1 at the same time. But when we measure that, it will either collapse to 0 or it collapse to 1. So the circle that you see here shows that it can, the direction of it is, this is 0 and this is 1. When it says that x is at in this position, it says that it is at partially more of 0 and less of 1, which is basically probabilities of it being in 0 and probabilities of it being in 1 is what we measure to classical bit. So quantum bits are generally are basically in 0 and 1 combination. So a bit difference between bits and qubits, we just saw that bits are always 0 and 1, whereas qubits are in both of these positions, right?
Kavita,
Now let's come to coffee. Yeah.
Just sorry to interrupt you. Could you try going full screen? It's not full screen.
Really? It was full screen.
From current slide, you could just play it.
Yeah, I was there. Isn't it full screen? Let me know. Is it full screen now? Is it full screen now?
It's better, ma'am. If you could like remove the side slide part, the left thing.
I can't see that actually. My screen for me looks like completely with just one slide.
Okay. It's okay, ma'am. You can continue. Not an issue.
Okay, I'll just go with this now. Okay, so everybody loves coffee and tea, right? We have caffeine in that coffee tea, and the molecular configuration of this caffeine is really hard. And with bits, we will see how much bits it takes. But with qubits, we can represent the molecular configuration of caffeine in just 160 qubits. In just 160 qubits. And when it comes to bits, how many bits do we need for the caffeine configuration is 10 to the 48 bits is what we need to represent the energy configuration of a single caffeine molecule at one given instant, which is basically that 10 to the 48 is these many numbers, and that takes about 10% of total number of atoms in the earth. So basically we are talking about two huge number of qubits, sorry, two huge number of bits to be done in classical computers. Whereas coming to quantum, it just takes 160 qubits. Now let's see something amazing about representing other molecules with respect to bits and qubits. Water takes 10 to the 4 bits, whereas qubits will be like just 14 qubits. You are able to represent the molecular combinations of water. So has others basically. So what we are trying to say here is, with lesser qubits, we are able to perform the same thing what a classical bit was able to perform, lesser number of qubits, because we just spoke about qubits can be in both 0 and 1 combination at the same time. Because of it being in many state at the given time, we can do many things. With classical bits, either it is 0 or 1, right? But with quantum, it is not going to be just either, it is going to be and also. So because of that,
Kavitha, sorry to interrupt, but it's not changing from the we keep. Okay, now it's in the new slide.
Now
it was we were seeing the caffeine slide all the time. So okay, now we are in the molecule one. Okay, perfect.
So
okay,
is it okay now?
thank you. And now we see the PowerPoint presentation, but not in full screen mode.
It's not in full screen mode. How do I go to full screen mode? It's presenter view is what I took.
I think that maybe when you press share screen from StreamYard, you have to select entire screen. Maybe that's the problem. I'm not sure.
Share your entire screen. Okay. I'm now sharing my entire screen. Let me go to my PPT.
Mm-hmm.
Is it now good?
Okay, now it's perfect. Thank you.
Okay. I was just sharing one application before. Okay. So we just saw that bits to qubits, a little bit of comparison. We're going to go in depth why it is qubits, lesser number of qubits can do the same job as the classical bits of more classical bits. Potential use cases of quantum computing, because when we learn about quantum computing, right, we all think about how are we going to use it, where are we going to apply, and which problem is it going to solve, right? So today we are able to solve many problems. In this screen that you see, rows and columns here. In the column, there is industry or a sector that you can call. So it's a chemical or petroleum sector, and distribution logistics, which is basically travel and transport, aeroplane industry, or simple Amazon package delivery industry, right? Financial services is all about your credit card, debit card, transaction management, and portfolio. So other financial work actually comes under this one. Healthcare is predicting the heart disease or heart attack or other diseases, or and analyzing the genome, right? So Pavitra spoke about genome also. So basically, this is many sectors quantum computing applications are available today. I am specifically focusing on optimization and AI ML at IBM today. So to give a glimpse of vehicle routing problem and trying to connect to the motivation, what Carmen explained, vehicle routing problem is basically a traveling salesman problem, which actually is an NP-hard problem. Everybody knows that this is a traveling salesman problem. It's an NP-hard problem. NP-hard means it's difficult to compute in classical computers. So that means whatever the result you get is basically most approximate result, right? We are trying to do the same thing in quantum, and we are able to solve that in quantum machines using optimization area of algorithms, basically. And in AI ML, there are a couple algorithms currently now available in quantum machines. They are quantum SVM algorithm, just the same thing as SVM, but it is quantum SVM. So there are a couple others algorithm also, just like CNN, there is QNN. So I'm focusing on these two areas. And in these areas, we are able to solve the very same thing that what we can solve in classical machines. So there you go. That is the use case of quantum computing to the business world. Now that we said quantum computing can solve many of these problems and other use cases, how can we measure that it's doing the good job, right? That is, the measurement happens through quantum volume. Quantum volume helps us in measuring the quantum device performance, basically, and that performance is going to be measured in terms of volumes, and the device performance can be measured. Recently, we increased the quantum volume in one of the quantum machines. So quantum volume, when we say quantum volume has many factors for it to be measured. For example, let's take a couple factors here. Calibration errors, right? How well the calibration errors talks about how well the electronic behind this quantum machines, right, can control for programming, the electronic controls for programming and measuring qubits. So how can this ensure the accurate operation, and how can this ensure that correct error mitigation is happening in quantum machines? So one factor is calibration factor. So let's pick coherence, right? Coherence, how long the qubit stays in a usable state, because qubit can be in usable state, sometimes it cannot be in a usable state. So the coherence decides how long this particular qubit, we say we have 65 qubits, the maximum qubits today available at IBM Quantum. So out of 65 qubits, how many of them are in calibration error, how many of them are in usable state, that is for coherence, how many of them are in measuring state. So basically depends upon all these factors, quantum volume is actually decided. Okay, so there are many other factors here. Now that we are talking about quantum volume, I just want to show a bigger announcement that happened from IBM. So IBM roadmap, IBM has produced a roadmap for scaling the quantum technology, and that scaling has been done like this. Last year, 2019, we had 27 qubits. Today, 2020, I think this was launched in September 5th or so, 65 qubits has been launched. So it is basically doubling from 25 to 2019 to 2020. And 2021, they're planning for 127 qubits. So has 1,000 qubits in just 2 years, actually. 2020, we are in 2023. In 3 years, we are planning for 1,000 qubits. So, and they have thus explained the path for 1 million qubits. So when we say about qubits, we are also focusing on the performance as well, which is basically the quantum volume, right? Which is basically the quantum volume. So here is a coupling map that I would like to mention, which is basically 0. You can see 0, 1, 2, 3, 4, which is actually connected in a chain, and the last number is 52, right? So last number 52, 0 to 52, says that it is 53 qubit machine, and this is how they are actually chained. This helps in error mitigation, all other factors basically. This is how the qubits are actually placed, is what this coupling map is showing to you. Circuit optimization. I want to take you to the software area a little later. So now the basics of quantum computing, right? Basically, we just spoke about what is quantum computing and why we need quantum computing, and also the bits and qubits. For that, there are fundamentally 3 things here. That is superposition, entanglement, and interference. These are the main 3 principles of quantum mechanics, which helps build a quantum computing machine, basically. So superposition is nothing but having a qubit, which is quantum state, that is both in 0 and 1, combinations of 0 and 1, and that's basically a bit of probabilities here and there. Measurement is after it is in both 0 and 1 combinations, it has to be collapsed into classical bits, which is 0 or 1. So that collapse happens based on the probability, basically. So measurement forces a qubit to be measured to either 0 or 1 for classical level. Entanglement, basically 2 or more qubits are tightly connected, and they both are, if you measure one quantum state, 1 qubit state, you know the probabilities and possibilities of what the quantum state is in the other quantum machine, other qubit, basically. So they both are tightly dependent on each other. So that's what entanglement means. Quantum gates, just like we have classical gates, there's quantum gates as well. We will see a bit detail. Interference helps us in deciding the right answer. So we speak about superposition and measuring to classical bits 0 and 1, right? So when we measure, we want to be sure that we are measuring correctly. We are not measuring wrong, right? So interference of quantum mechanics helps us in measuring that accurately. So a bit detail about superposition. You see 0 and 1 in blue here. This is called as ket 0 and 1 is called as ket 1. So this is a bracket notation. It's bracket notation, B-R-A-K-E-T. Quantum state can be in a superposition state. That means it's a combination of 0 and 1, and A and B, they both are complex numbers here. this condition, we can actually express that in a Bloch sphere. So this circle is called a Bloch sphere. X is down there, and x is basically 1, and then the phi is basically the theta movement. So this is actually showing us at what position it is between 0 and 1 here. So this is showing between 1 and 0 what position is at this one. So basically, this is what people mean when they say that a qubit can be 0 and 1 at the same time. So this is a superposition state. So as we are in superposition state, I would like to bring a Schrodinger's cat example that Albert Einstein and others actually came up with. So Schrodinger's cat is, a cat can be dead or alive, being in a box, but only when we measure, we know that it is dead or alive, right? So basically, thinking very logically, it could be in a dead or alive condition, both at the same time, because we are thinking like that. So now 2 to the 1 is the number of qubits is 2 to the 1. There's only one qubit, and 2 to the 1 represents the quantum state. And now we have 2 to the 1 is 2 quantum state basically. So A and B are complex numbers here, and so the quantum state with one qubit can be in 0 and 1 combination basically. If we have 2 qubits, then we have 4 quantum states. And the constants A, B, C are complex numbers here. So here, both of these qubits are 0, 0. In this state, it is in 0 and 1. In this state, it is 1 or 0, 1, 0. In this state, it is 1, 1. So similarly, if we have 3 qubits, we have 8 quantum states. If we have n qubits, then we have 2 to the n quantum state dimensions that's possible. With 2 to the 64, these many quantum states are possible, right? Now coming to 2 to the 27 qubits, 2 to the 27 qubits gives us quantum state which is more than there are atoms in the observable universe, which is really, really huge, right? So this is why we mentioned caffeine configuration, a molecular configuration can be represented using just 160 qubit, whereas representing it in classical qubits takes about 10 to the 48 bits. Okay, so this all is possible because of the superposition that is happening in quantum computing underlying the quantum mechanics theory. So now comes the measurement, right? Measurement is nothing but whatever the superposition state it is in. Being a classical computer that I have, I can't understand what is superposition, right? It has to be collapsed into 0 or 1 state. So how that happens is we measure by observing ket 0 and ket 1, and we check the probability. When we check the probability of it being in 0 is probably 55, and it being in probability of it being in 0 is let's say 60, and the other one is basically 40. Then we measure then we are collapsing it to 0 basically. The example says 75% of chances becoming 0, ket 0. So the probability of it being in 0 is 75% chances basically. So that is how measurement happens, and measurement is one of the basic phenomena of measuring result that is working on quantum computing to classical machines. So entanglement, right? This is a very important feature actually of quantum machines. With 2 qubits, we get combinations of 4 combinations we just saw, right? What does this 0 and 1 means? 0 and 1 means basically with the first qubit is 0 and the second is 1. A, B, C, D, they both are in complex numbers. We saw that already. If 2 or more of them are non-zero conditions, then we cannot separate. We just spoke about it. But let's see whether in quantum physics, right? The entanglement of particles describes a relationship between their fundamental properties. Basically, they are somehow related. They're fundamentally they're related, and that cannot have happened by chance. It has happened because there is a momentum, there is a position, there is a polarization, right? So knowing the characteristics of one particle tells you something about the same characteristics of another particle basically. So that is what this entanglement means basically. So for example, think of a pair of gloves. Okay, if you found a right glove alone in your drawer, you can be certain the missing glove would fit your left hand also, right? Because you have put it in your right hand, your left hand glove is missing right now, and you're very sure or certainly sure certain is basically the probability that whenever you find the left hand glow, you will fit it in your left hand, right? So the two glows could be described as entangled because you bought it at the same time, thinking that they both are at the same measurement of your hands, right? So as knowing something about one would tell you something important about the other. That isn't random. That's not in random in nature, or it's not a random feature. So, but basically, their fundamental properties are entangled. Okay. So this is one example of entanglement that I can give. So this is again the bit of mathematical formula of representing the entanglement. Now let's come to gates. You know that classical machine also has gates, and we are all very familiar with, and we have studied way back in the first semester or second semester of engineering, right? What is AND gate, OR gate, NOT gate? So in quantum computers also we have something similar, but they're not the same. But in quantum circuits, the gates are reversible that change the quantum states of 1 or 2 or any of these qubits. It can change the quantum state and it can come back to the original state. That's the fundamental phenomena or the beauty of quantum machines. The gates can be reversible. Hadamard gate, this H stands for Hadamard gate. All there are 3 qubits here in this representation: Q0, Q1, Q2. There are 3 qubits. All the qubits are in 0 state fundamentally when it starts actually. H is a Hadamard gate which puts the qubit 0 into a superposition state. Superposition state means we already know that it can be 0 and 1, right? Or any combination of 0, 1. We measure it. The pink thing that you see is a measure icon. When we measure it, it collapses to 0 or 1. It can't be in the same state basically, because and qubit 1, qubit 2, if they both actually have the same Hadamard measurement, they both can be 0 or 1, and it cannot be same 0 and 1, because qubit 0 was measured to be 0, let's say classically, and qubit 1 can be measured to 1, because the superposition state of Q0 and Q1, they both are independent here. But the superposition says they are dependent, but that applies to only this qubit, because they both are not entangled. Entangled means here qubit 0 and qubit 1 here, they both are connected here. You see that there is a plus sign. This is a C0 gate. C0 gate is basically a control gate which measures depending upon the control criteria and a target bit basically. So that's about quantum gates. There's a lot to study about quantum gates. I'll give you guys the reference. Now I'm moving to interference. Is one of the basic quantum basics basically. So this one will allow us to measure or get the probability which is increasing in nature for the right answer, not for the wrong one basically. So now you see blues and reds here, right? Red is basically the wrong answer, and interference helps us in measuring the probability amplitude correctly. Okay. So the red is really high here. We know that even though red is really high, the probability of it being wrong is higher than it being right. Now that we learned a bit basics about basics of quantum computers, let's move and see how IBM Q's quantum computing machine looks like. So this is how it looks like, and you see this is a chip where quantum qubits actually stay, and it's all real gold. This is in a fridge in a very low temperature. It's maintained, and IBM Q's quantum machine looks like this, where it's in the case basically, and yeah, 15 millikelvins. That's how the fridge is maintained here. And this is a circuit board where the qubits are on this chip basically. This is what the qubits are. And the quantum devices, we actually saw the 53 qubit Rochester device. I think in early September 5th or so, we released 65 qubit machine, which is the largest qubit machine from IBM Q. This is Yorktown is a 5 qubit machine, and there are Mellabone is a 16 qubit machine. And 53 qubit machine is Rochester device. So there are many quantum devices, and there are quantum simulators also. I'll talk about quantum simulators when we come to the quantum software area. So let's actually move on to real quantum machine, IBM-Q, right? So from here, I'm going to go to the website where IBM-Qs are available. So quantum computing website is this one, quantumcomputing.ibm.com. Here, anyone can go create their user account. So once you create your account, I'm just trying to show something. Once you create your account, this is how you will be landed. And you will have to install QSkit. I'll talk about QSkit a bit later. But there is a key here. I want to mention this part. Key is the one which helps us in getting connected to the IBM-Q devices. Okay. So here, there are many things. I will go to Quantum Lab to show you guys that we can use a couple of things. So here there are QSkit tutorials. So pick something easier. Let's say circuits are the basics basically. And getting started with QSkit. So actually we are right now in IBM Quantum Computing Cloud. In that cloud, we have opened a Jupyter notebook and we are actually getting started with QSkit. We are not installing anything in our local machine, right? Everything is up there actually. Everything is in the cloud, even the Jupyter notebook, even Python 3, everything is in there. So QSkit is also there. So there's code already written there. Try to understand what is it's doing here. There's a book that I'm going to refer to. And they're building circuits here. They're building circuits, they're drawing how it looks like. And quantum computing actually, the basics of quantum computing is linear algebra and quantum mechanics, which also is on linear algebra. So we will have to go study that. And we are working on some simulator. I'll talk about simulator. And we are executing the actual quantum program. So, but this is actually running on a simulator. And now we have a result of the state vector basically. And this mapping is also done. So basically with this, anybody can get started, and IBM Quantum Experience is not limited for only people who are from IBM. Anybody can use it. So recently in India, we actually launched a QSkit India Hackathon coding challenge. It got ended September 17th. Now I'm going to go for Circuit Composer. So that is whoever are very comfortable with Python, right? You can actually do it. So Q0, Q1, Q2, there are 2 qubits. I'm just going to have only 1 qubit now. And let's say I want to have just the X gate. Where is X gate? I'm just trying to get the X gate here. So Q0, when it starts, it's in 0 position. But when it is measured, it is in 1 position, basically. Means X gate is nothing but a NOT gate in classical machine. So we just measured it to be 1. Now let's put Hadamard gate. Hadamard gate is basically a gate which creates superposition. And now it's measuring already. The probability of it being in 0 or 1 is equal. It's 50% probability. And this is also 50% probability. So we are just seeing the superposition state of a quantum machine right now. Okay. So this is, and we can actually measure it to classical bit, that is C1. We've just measured it. And when you measure, you get 0 answer now. Means it could be in 0 or 1, but when we measure, it has to collapse because its probability of it being is 50%, both of them. It is getting collapsed to 0 state here. So this is a simple example or simple circuit that I can show here. Okay, there's a lot of theorems, Bell's theorem and other things that's there, and we need to understand the basic linear algebra and the matrix behind all these gates basically. So now I will go back to the PPT presentation. I hope I have introduced you guys to IBM Quantum Experience, how to build a circuit and how to actually go look at quantum labs. And there are already QSkit tutorials that you start with basic circuits, then go with circuit advanced, then go with any of these problems. And I'm working on optimization and ML area. But this is a way to go, guys. And you can also create a new notebook, or whatever you have created. You can also work with whatever locally you have created. You can actually upload it here to the quantum computing cloud, and you can work there also. So I'm just going to show one of my code here, where I'm using the IBM Q's API key. I just want to show that, because I have showed API key. I have not shown here, but I have loaded account, saying that load my account with my API key, because my API key should not be visible, because so I have taken it out. We load our account basically, because and I have already set my API key here. We are just loading, and we are directly connecting to IBM Q devices basically. Okay, so now I'll go back to PPT presentation. We were there at IBM Q. I hope we learned a bit. IBM Q experience. We also saw the graphs actually. That's a city plot. Now, so this is what we saw, and we can see the results actually. I will show the results. Here is the results. So I had just run in something 2 days ago. It is saying that which machine that I have used, who is the provider, and the result is here. Okay, the result is here. I should also be having the circuit. So I had done a complex circuit, and this is the circuit for the result basically. And you can get the QSkit code also when we run the result. We can open in Quantum Lab. So this is a circuit which has been automatically generated for the programming I was doing. Okay, so we can go look at the result, and we can go look at the documentation. What are the jobs which are still running? Okay, so I will now go back to the presentation. In this presentation, we are just talking about the open access and the premium access. Open access let you access up to 16 qubits or 27 qubits, I guess. If you want to have premium access, then you should be in IBM Q network. To be, clients actually typically get 65 qubit access, which is the highest number of qubits from IBM Q. So now let me take you to QSkit. So let's getting started with QSkit is what the slide says. So here we can learn about QSkit, which is actually showing how to work with quantum machines. Okay, I'm going to. Quantum machines are available through cloud, but if we want to access it, there should be a software which actually lets you access it, right? So that software is this QSkit, KISKIT, QSkit. Okay, so this QSkit or SDK helps us connect to quantum machines. Okay, this also has this SDK also has simulators, which actually you don't have to access every single time, even if you're running errors, right? If you're still developing, you probably do not want to access IBM Q. IBM Q machines actually, as I show here, the results, it says, is it in Q position? What is the estimated time for completion? Because today the number of devices available are less, and then if there are many circuits, billions of circuits running, then you will be queued. So when you're learning something, or when you're actually accessing, trying to work, maybe simulator is a best idea, and then real test can be run in real machines, real IBM Qs. So what does this QSkit actually has? It has access to circuits, it has quantum algorithms, you can access the quantum hardware as well, and has Carmen explained qubits. The quantum computing machines can be built with in different flavors, and IBM has provided it in superconducting qubits. And you can also work with noise mitigation, how to work with noise in quantum machines. So I will go ahead for documentation area. From Qiskit.org, you go to documentation. And in this documentation, we can get started with Qiskit actually. So the latest version of Qiskit is 0.21 version. And here there are many elements: Terra, Air, Ignis, and Aqua. So these are the 4 elements. I'm going to talk about getting started with Qiskit. So we first install Qiskit. You can install in Windows, Mac, or Ubuntu. So this pretty much explains how to install also. I'm going to go with the elements of Qiskit. In Qiskit, it's fundamentally divided into 4 areas. Terra is the fundamental area, which actually is required for Ignis, Aqua, and Air. Air helps us in simulating the experiments. Aqua has all the algorithms, quantum algorithms or chemistry or optimization algorithms. Ignis helps us in working with noise, basically. So this 4 are, and Terra helps us in circuit and other things, right? So this 4 areas of this Qiskit SDK are 4 different elements, which are basically the foundational block of this SDK. Okay, so this is the Qiskit. And here, when we go to getting started with Qiskit, and this Qiskit.org is an open source also. Anybody can go ahead and study here. So here, they're just building circuits, right? Which we also saw in our IBM Q experience. So Air, I said Air is a simulator, and Air.get backend, you're getting the Quasum simulator. So this is one of the simulator basically. And we are creating a circuit, quantum circuit. 2 stands for 2 quantum bits, 2 classical bits. And circuit of H of 0, the quantum 0 bit is actually added with a H gate, which is a Hadamard gate, then control NOT gate. Then you're measuring 0 to 0 and 1 to 1. This is quantum and this is classical. So you're measuring quantum bits to classical bits. And then you're executing the job, and you're executing in the Quasum simulator using the Air backend. Air is basically one of the element that we just saw, right? So quantum circuit execute, we get it from Terra. And we have not used any quantum algorithm here. So we have not used quantum Aqua element yet. And this is how the circuit looks like. And it has been measured and collapsed into 0052 probability, 1147 percent probability. So the way we work step by step in Qiskit is we import packages, initialize variables, create gates, visualize the circuit, run the simulate the experiment with the simulator, and visualize the circuit, and we are done with the measurement also, right? We simulate the circuit experiment and measure also, and then visualize the way we have done. So this is how the basic step would start like on Qiskit. You can also learn about gates in the same Qiskit.org material. So this is the element we were just talking about. Qiskit community, right? Anybody can join the Qiskit community. There is a Qiskit Slack as well, Stack Exchange. There's a lot of, everybody asks questions in Stack Exchange, you can get it answered also. And we have blogs written in Medium. And Twitter is one of the favorite handle basically, where you can actually know about Qiskit or any quantum news basically. And quantum also has GitHub, and this GitHub is open source. If you are right now not at a state where you want to learn quantum, but you are at a state where you know Python very well, you want to contribute to Qiskit community, what you can do is come to this Qiskit, which is open source, right? You can actually be an open source developer as well. I have done a couple contributions. So go to the issues. I'm just opening Qiskit Terra, which is basically the fundamental. Go to the issues. Me and Carmen, we both are Qiskit developer advocate. So we both have done this work to be a Qiskit developer advocate, working on the open source contributions as well. So here, pick a element like good first issue. It is basically going to be very simple, but we can actually, when we do this, we become more acquainted with Qiskit. And then when we learn Qiskit, it's easy for us to learn IBM quantum computing machine, how it is working and such. So yeah, I think this is what I wanted to speak. And GitHub, we spoke. Slack exchange, we have Qiskit Slack also. So if you go here, Carmen, do you have it handy? The Slack part? It should be somewhere in the Qiskit org itself, right?
Yeah, it's in the bottom of this page. Yeah.
Okay, here, Slack here. Okay. You can stay connected by joining IBMQ, join Qiskit Slack. So I have already joined here. So yeah, so you can join here and try to learn if you're interested. And there's a big community where people are contributing, people are asking, people learn. And there's a new challenge going to come in, I think it's going to come in Japan, or Tokyo, I'm not sure. So it's a new challenge is going to come in the month of October. We are just done with the India challenge, so anybody can learn actually. So that's one message that I would like to pass here on Qiskit and quantum. Yeah, learning to program a quantum computer. We just learned about Qiskit, and there's a lot of YouTube videos. And Abraham Asif, called as Abe, he has done fantastic hello world videos on how to work with Qiskit as well. So you can go Google or YouTube on Qiskit. Basically, you can learn about that. And a lot of contributions. I've gone through these two, IBMQ experience and the Qiskit. So if you're interested, go ahead for further papers, and you can read about it here. We thank you. Is there any questions that we would want you guys to answer? I will stop sharing right now.
Thanks for the informative session, ma'am. Both Kavita and Carmen, ma'am. So the session was really informative. So as of now, since we have speakers lined up, we won't be taking any sort of questions, but we'll give the audience your social handle so that they can basically ask you the questions. Yeah.
Okay, great. Okay, so thank you everyone, and thanks for the opportunity of talking in this event.
Thanks everyone. Thanks for the opportunity,
Thank you.
Samuel, Arya, and Usha. Thanks for inviting us. Thank you.
Thank you, ma'am. So next up, we'll be having Sanjukta ma'am. So Samuel, if you could introduce her. Okay, so I think there are some network issues with my co-anchor. So I'll be introducing our next speaker for today, which is who is Sanjukta Datta, a junior data analyst at Cognizant, and she will be handling the topic genomic perspective of biology and sequencing. So let's move on to that.
Hello, one and all. So today my topic is genomic perspective in biology and sequencing. So genomic perspective is a basic topic, which is genomics, which is a very, very important part of biology these days, because every study we do is a part of analysis or something like that. So genomics is a very important part, and we shall be discussing about this perspective, and sequencing is a part of this study only, so I'll be talking about it briefly. And so let's start. About the speaker, which is me, Sanjukta. I work at Cognizant in Kolkata, and I basically postgraduated in bioinformatics, and I'm interested in genomics and NGS data analysis studies. So, basic overview of genomics I'll be discussing today. And in this presentation, you shall get an idea of it in biology and how genomics play a role in today's world. So let's get started. Introduction. So in an introduction as a basic part, we can say that our genetic information is stored in DNA or RNA. So in order of nucleotide bases, which is arranged in polynucleotide chain, which is the main genetic information or instructions. So a gene is basically a sequence stretch of nucleotides which encodes a specific protein. Now humans have thousands of genes, and in their DNA molecule and in our body we have so many genes, and we can get our genetic information is stored in DNA. So so many informations are there. So the entire nuclear DNA is called a genome. So we can get confused that what is a gene and what is a genome. So a gene versus genome, gene is a locus on a DNA molecule, whereas genome is total nuclear DNA. Okay, like a total set of DNA where all the sequence of chromosomes are there, entire genetic material of DNA or non-coding sequence, everything is there in DNA, in genome. So that's the basic difference of gene versus genome. And if we study about genome, then we can obviously know a lot of things, lot of information regarding our chromosome or our gene or other parts of the gene. So it is a huge study, and we can know step by step. So a basic introduction in genomics after knowing genome is genomics is the study of complete set of DNA or of an organism, including its sequence, organization, function, and evolution. So basically, omics refer to a large study of large comprehensive biological data set, because any omics attached to any study, like any particular topic, like apart from genomics, there are also proteomics, metabolomics, and other types of studies are there. So we generally will talk about genomics, and it is a study of full genetic complement of an organism. So genomics, we can say that it is a part of biology where all the detailed study or the DNA or the gene level study is can be done. Okay, now let's proceed about its history. So a very brief history, I would say that actually the genome study started from this human genome project, which was led by this famous person, Francis Sellers Collins, and it was started on October 1, 1990 officially, and completed in April 2003. And what was this human genome project? This project was in a, it was the first time when the entire the genome or the entire structure of genome was studied, was built. Okay, so it reads nature's complete genetic blueprint for building of a human being. So human genome was uh, seen, was observed for the first time. Okay, so this was his previous initial part from where this genomic study started, and then we come to the research area of genomics. Now the research area of genomics means that when we study genomics, we don't study as genomics, we study as a various parts of genomic study, and those are different parts. Those includes different parts like functional genomics, structural genomics, epigenomics, metagenomics, or comparative genomics. Now one by one I will briefly say about functional genomics. It focuses on the dynamic aspect like gene transcription or translation or protein-protein interaction, all the functional aspect of our system, as these processes which I told, as the aspect of genomic information of DNA sequence. So it mainly answers all the question about the function of DNA at the level of genes, RNA transcript, and protein products. Then we come to the structural genomics. Structural genomics seeks to describe the three-dimensional structure of every protein. So we generally use to study all the structural part of the genome, or structural part uh, of a system, of a study which we are focused on. So we can say it describes three-dimensional structure of every protein encoded by a given genome. So a genome encodes protein of like in the central dogma, or in a system, basic system of our human being, or living organism, sorry, is like all the proteins are made by a particular from the gene, then protein comes. So then we can see that how a genome uh, encodes a protein, and we can study on that basis on the structure of it. So this genome based approach allows for a high throughput method, and mainly determination by a combination of experimental and all sorts of modeling approaches. The main difference between structural genomics and traditional structural prediction, or you can say to predict a structure, is structural genomics attempts to determine this structure of every protein, not on particular protein but every protein, a set of protein that a genome is encoding. So this is a basic idea. Then we come to epigenomics. Epigenomics is mainly the study of complete set of epigenetic modification. Now, epigenetic modification on the genetic material of the cell. So, epigenetic modification is actually the reversible modification on a cell's DNA or histones that mainly affects gene expression without altering any DNA sequence, or any modifications, we can say, uh, that happens in every step of our transcription translation. So we can say that is that as epigenetic modification. So it's a part of this process, and this study of complete epigenetic modification is mainly epigenomics. Next we come to metagenomics. It is mainly the part where the study of metagenomes are there. Metagenomes mean genetic material from environmental samples like bacteria and like that. So genetic material, uh, we can say that as metagenomes, and we can study on that basis. Then we come to comparative genomics. For the like application, it is mainly a study where we compare each and every organism on the basis of evolutionary relationships. So using all kinds of evolutionary details or classical genetics, we can see the difference in population, species, patterns, its phylogenetic trees, etc. We can compare all those evolutionary relationships, or every part of that evolution, or that species difference. So we can easily track based on this comparative genomics. So it is a very highly demanding study nowadays. So this is an overview of research areas in genomics. Next we proceed to sequencing. Sequencing is simply, in a layman's term, we know sequencing is determining exact order or exact sequence or order. So in sequencing of genomics term or biological term, we mainly see how in exact order the basis of a strand of DNA is placed. So by sequencing, we can know that part of the DNA or that strand of the DNA, and thus we can have the idea of this genetic information. So there are various ways of sequencing, DNA sequencing. Mainly sequencing has like it is we can say it is not the type, but it is an evolution. Like initially, on very earlier in 1977, Maxam and Gilbert method was used. It was single stranded DNA was cleaved at specific location with the help of chemicals, such as specific like specific chemical like polyacrylamide gel, and they used to sequence this DNA. So Maxim Gilbert was one of the first method of sequencing sequencing. Then we come to Sanger sequencing. Actually, the technique was developed or advanced accordingly. So Sanger sequencing, they use the chain termination method, where dideoxynucleotide sequencing was it was called because they use special type of DDNTPs to for the sequencing. Now it is a process where this phosphodiester bond cannot form in the adjacent nucleotide, and then the chain can terminate, and then the DNA can be taken, like it can be read. So it is a part of another advanced method than Maxim Gilbert method. So mainly we need that sequence of the DNA. So if we terminate the chain, if we terminate that part of that DNA strand, uh, and then we read that strand, slowly we can get the idea of that particular nucleotide. Like if it is breaking on adenine, then it will give the signal of adenine, that on adenine it is breaking. Then on the next it is breaking on guanine, so it will give the signal of guanine. So like that the reading can be taken, and then we can see the sequence of the DNA. So like this it was the sequence was taken and it was recorded. By that, next we come to the automated method, which was a bit different from Sanger sequencing, as the gel which they used in the process was carried in a single lane. So the basic idea is same, but the technique was different, or the process of carrying that sequencing or process basic process was different. Next, we come to pyrosequencing. It was also almost idea is same, but process they use three enzymes and not like single polymerase. They used DNA polymerase, luciferase, and sulfurylase. So pyrosequencing was also a part of that conventional method. Then whole genome sequencing is sequencing of the whole genome. uh, Almost they are same, but then the final sequencing technique is next generation sequencing, which is the high throughput method, and that is the most recent, like not most recent, more advances are being made right now, but next generation sequencing is one of the most used, we can say, because in biology or in genomic study every person is doing this NGS technique. So let's talk a little bit about this next generation sequencing, or we can also say it is a high throughput sequencing. So in this high throughput sequencing, basic step is first we used to prepare the sample, or we can say library, where all the reads are taken, where all the libraries of this DNA are taken. Then PCR amplification of that target sequence is done, where amplify the strands are amplified, and then in the machine, or your sequencing machine or sequencing technique, uh, they sequence, and it has a huge process, because in high throughput sequencing or NGS there are various parts of like various types of sequencing also. But since I'm giving an overview, I can just tell the basic step, that is PCR amplification, and after that sequencing occur. And after we get the sequence of this DNA or RNA, we can then analyze it through our bioinformatics technique. So analysis includes various types of studies. So those are the main bioinformatics approach, or the dry lab approach, which you can do in the coding, or through coding, or different softwares are there for that analysis purpose. So from there all kinds of studies are being taken. So these are the evolution sequencing tools, where first generation is the Sanger sequencing, Maxim Gilbert, where these kinds of it was most conventional part. Then second generation was this actually second generation is still going on, that is high throughput, where we can see various types of machines like ion torrent, illumina, those are most famous. And then the third generation which is coming, it has already arrived, actually PacBio and Oxford Nanopore. So those are way advanced technique. They give long read sequencing, and first and second generation gives short read sequencing. So obviously in a long read is better than short read, because more detailed information of that particular study or gene or whatever can be obtained in the long read sequencing. So yeah, and this is a very very brief overview of this genomics. And as a conclusion, we can say that the technology is to analyze DNA has become increasingly widespread, and ensures the employer to have information which is like it is a useful, and it has a huge scope in future, huge opportunities to improve our wealth. And a lot of information can be gathered in the upcoming future of biology, as well as we can say data science, because it is an integrative approach where both biology and data science or you can say computer disciplinary studies are taking or getting integrated. So it is a very very prospective or method or study rather. So that's my topic, and I hope you can get some idea of genomics now. And these are some references that I gathered, and you can contact me in the LinkedIn profile, or my email is this. And thank you. That's all.
Thank you, ma'am, for the informative session. It was a great session. So the next speaker is Kushi, who's a security delivery specialist at IBM, who's going to give a session on NLP-based chatbots.
Hi everyone. Let me share my screen. Okay. Hi everyone. Good afternoon. This is Kushi here, and I'm going to take a session on NLP-based chatbot. Before moving on to the session, I will give a small introduction about myself. I have a total 6+ years of experience in the field of web automation, web technology, and AI technologies. I'm a machine learning enthusiast, so I started getting interest in machine learning about 3 years ago. And currently, I'm extensively working on automation field using Python. But my other areas of expertise are also in web development, automation, Python, and C# when it comes to programming. And last but not the least, chatbots and NLP when it comes to artificial intelligence and cognitive therapies. So you can also reach out to me on LinkedIn, and also I have a profile on Stack Overflow. Now moving on to the session, this is my agenda. So it's pretty straightforward and simple. Introduction to chatbot. I will start off with what chatbot is, what is the type of chatbot, what are the use case of chatbots. And then I will move on to introduction of NLP. NLP stands for natural language processing, and I will talk about the basic techniques which is extensively used in NLP, and how we can incorporate NLP with chatbot and then develop NLP based chatbot, and how you can get started after this session. And typically I have purposefully I have made this session as non-technical as possible, so that it becomes more generic. And my main motive of putting forward this session is to give more idea on what chatbot is, what NLP is, how you can integrate in your organization and in your projects, and how you can leverage the different types of use cases that comes along with the chatbot. Now coming on to what are chatbots. Chatbot is a conversational agent that interacts with users using natural language. So here conversational agent stands for any kind of machine, app, or application which will be interacting with a human. So instead of human interacting with a human will be interacting with an application using a very natural language like English, Hindi, or Kannada, or any Spanish, etc. So when it comes to interaction, there are multiple ways or levels of interaction we can talk about. There could be text-based interaction. Like for example, when we interact with a chatbot in Facebook Messenger, so it's just completely text to text based kind of interaction. Then we also have speech to text interaction, and text to speech interaction, and speech to speech kind of interaction conversation. Speech to speech conversation, ideally we can exemplify with Alexa or Google, okay Google, Siri. So these are all can be termed as speech-to-speech interaction. Now, when we want to develop a chatbot, there will be certain components that we need to keep in mind. So basically there are three types of components when we want to develop. So the first component is definitely it's going to be user interface, UI, with a channel. Channel as in stands for a platform where you are going to publish your chatbot. It could be a channel like Slack, Facebook, Skype, or if you don't want to publish on existing channel, then you can publish your bot on a browser based web chat where you need to have your own cloud infrastructure where you can publish your uh, chatbot. Now, second component is NLP to understand intent and entities. I'm going to cover this point in upcoming slides. Now, the third component is conversational context. This is also somewhat interrelated to NLP as well. Conversational context stands for ability to understand the current interaction based on the previous conversation or the history of the conversation. So, for example, if I'm asking to a bot, tell me what is the temperature of Bangalore, and a bot will give me a response. Okay, the temperature of Bangalore is 25 degrees centigrade today. And then I will go on continue asking, okay, what about Mysore? So that means if bot is not able to understand the previous conversation, so the current conversation the bot will not be able to understand. So what about Mysore? This sentence doesn't imply, or I have not specified explicitly I'm asking for temperature. I'm just asking what about Mysore. So if the context is understood, then the bot will be able to understand and then give me a reply, okay, the temperature of Mysore is also 25 degrees centigrade. So that's what is meant by conversational context. Now, coming to types of chatbots, there are multiple ways we can divide categorize chatbots, but generally we are categorizing it based on the complexity and the intelligence level of chatbot. So there are basically three types of chatbots we can categorize. The most unintelligent type of chatbot is menu button type of chatbot, where there is no free conversation, there is no free flow of conversation, and is just pretty much monotonous, and there is there is minimal level of intelligence required. So you just go and check okay, if you want to top up your if you want to recharge your application, or if you want to recharge your sim, then the bot will say, if you want to recharge for 200 rupees, press 1. If you want to recharge for 300 rupees, press 2. So that kind of monotonous and unintelligent kind of conversation, you can have it in the first category of bots. And then second category is little less dumb, you can say. It's keyword recognition. So instead of having a full-blown intelligent conversation, it will recognize certain keywords and certain criteria based on which it will give you the replies. Now, the most complex and the most intelligent level of conversation you can have with a chatbot is using contextual kind of chatbot, where it will also not only understand context, but it will also use lot of different ML algorithms and NLP related complex algorithms that will process your language and then give you an appropriate customized level of replies. So now coming to use cases of chatbots, there are two basic types of chatbots divided. One is reactive and another is proactive. As the name is suggested, reactive means when a bot is not initiating the conversation. The user or the customer is initiating the conversation, and then the bot will reply to the queries or the interaction what user is trying to say. So there are majorly frequently used types of reactive use cases are customer service, customer support, suggest product, and inquiry. So it's pretty much straightforward. Like for example, if you want to book a flight, or if you want to order a pizza, so such kind of services can be provided by reactive bots, which is categorized in customer service. And supposing you want to you want to raise a ticket or you want to raise a request to customer support and want to give the feedback of a particular product, or if you want to complain or if you have a concern or a grievances kind of thing that you want to put forward to the organization with respect to a product, then you can use customer support of case of chatbot. Then there is also suggest product. So if you have bought something on Flipkart or Amazon and you have a history of purchases, order history is there. So based on your previous order history, you can also suggest some new products or compare the products. Say, for example, what is the best phone available in the market with 15K of budget. So such kind of inquiries or queries can be also put forward by chatbot and can reply based on the ML and NLP techniques. And finally, it could be just a plain old inquiry in the sense you just want to know some kind of information. Supposing your organization has developed a bot and has published it exclusively for the employees, and you want to inquire about get informed on the policies, compliance, procedures. So such kind of inquiry you can straight away go and ask. It could be just a quick Q&A maker, like question and answer kind of interaction. You can do that using interactive kind of inquiry kind of use cases. Now proactive is also there. Proactive in the sense it's unlike reactive. User will not be initiating the interaction. It will be bot who will be initiating the conversation and giving you the details and information. So two major forms of proactive interaction would be reminders. Um, the bot want to remind your anniversary or friend's birthday or to-do lists. So such kind of reminders can be done, and it will automatically remind based on the inherent programs. And then notifications and updates would be there. Supposing you want to track down some product, you have ordered some product and you want to know what is the status of the product, so where it has been shipped, is it been detached. So such kind of proactive interaction could also be done using chatbots. And now coming to utterances, intent, and entities, as I mentioned, so whatever the interaction would be there, so those all the kinds of interaction that is being given by the user, it has to be drilled down to intents and entities. So whatever is the case, so whether it is hello or whether it is I want to book a flight or I want to book a restaurant. So all these interactions has to be drilled down to intents and entities. So this is the basic building block of any NLP or a chatbot, you can say that. So utterance is basically anything the user is typing or saying. It is just a plain old English sentence or statement. But once the user has uttered something or customer has uttered something, then it has to get processed. So it has to process into intent. Intent is basically nothing but user's intention. What is user trying to do? So it is often a verb. And entity is all the things that are associated with the intent or the things that speaker is referring to. It's basically what modifies an intent. So just say, for example, I'm saying that, hey bot, please book a flight from Delhi to Bangalore today at 5 p.m. So out of this entire statement will become an utterance. And intent will be what is the intent here? It will be booking a flight. And entity will be the things that are associated with it. So there are 4 things that are associated for flight booking. So one is source, that is Bangalore. Then second is destination, that is Delhi. And then date and time. So date is today's date, and time is 5 p.m. So these are all the this is how the interactions are drilled down. Now coming to natural language processing, when I speak about intent and entities, all these can be done using natural language processing itself, and it is shortened as NLP. Is a branch of artificial intelligence that deals with interaction between computers and human using a natural language. And there are a lot of use cases for NLP, and one of the common use cases are you might be using it on a day-to-day basis, language translation like Google Translate. and word processors. Word processors, Grammarly are a very cool example of NLP, and interactive voice response, and sentiment analysis and review analysis. These are all pretty famous right now. Say, for example, if a product is launched on an Amazon and there are 1,000 reviews over that product, so what is the generic sentiment of for the for that product? So what is it bad, is it good, or is it neutral? Such kind of sentiment can be analyzed by fetching the review data of the entire product and analyzed it based on NLP. And last but not the least, it has to be used on chatbots, personal assistants like OK Google, Siri, Cortana, and Alexa. Now, when we talk about NLP, so there are lots of techniques that are used. So NLP is a very huge topic, but when we want to implement NLP for any of the projects that we want to develop, so there are multiple sub techniques that we want to use, and out of lot there are 5 major techniques that is being used most of the time. It is used extensively, and those are all called as syntactical analysis. So what do you mean by syntactical analysis is, when we are interacting with somebody, we are using a language, and every language, whether it is English or whether it is Hindi, Latin, Spanish, Greek, or anything, so these kinds of languages will have its own grammar. So once we understand the grammar, once we understand the rules and protocols of that particular language, then we will be able to understand the context. We will be able to understand what the other person is trying to say. So if we don't know the grammar, we will not be able to understand that. So a grammar stands for what? It's basically a syntax. It's basically rules and regulation. And this means that if you're using this kind of tenses, if you're using this kind of punctuations, then that means that you are doing so. Like, for example, comma stands for pause, and full stop stands for ending the statement. So these are all the grammars. So when we talk about grammar, grammatical and understanding in computer perspective, then we do something called a syntactical analysis. So whatever the information is being fetched, we analyze it based on certain techniques. So one of the 5 techniques are one is tokenization. Another I will be covering up in other slides, like lemmatization, stemming, and entity recognition, etc. But please keep in mind that NLP techniques are language dependent. So since grammar of each and every language is different, syntax of each and every language is different, so that is why it is important that each and every language will have different kinds of syntactical analysis and NLP techniques. It is not necessary that if you're using some kind of tokenization some kind of procedure for English, so then it will be same for Chinese or Spanish or Latin, etc. So the first technique, that is tokenization, stands for drilling down the entire statement into a smaller chunks. So here you can see in this diagram, the text is there, the cat sat on the mat. This is one statement, but we want to drill down to smaller chunks that we call it as words. And here we are calling these words, or the smaller chunks, the smallest unit of this information, as tokens. So everything is being since in English language, each of the word is separated by blank space, so it will be tokenized based on that. But if we are talking about some other language, it need not be blank space, it could be something else. So that is why, again, so NLP techniques will be language dependent. Now coming to the next technique, the lemmatization and stemming. This is also extensively used in NLP. So what it does is basically it generates the root form of inflected words. of any word that we are using, so that will have its root form. So it will remove the suffix or prefix and then get the root of that particular word. So there are both lemmatization and stemming are somewhat more or less similar. What it does is it takes out the root of the word, but it is slightly different. So when we come to stemming, as you can see in this diagram, so change, changing, changes, changed, and changer. So these 5 words are there, and everything is being drilled down to change. So that, I mean, it's not meaningful. It doesn't have any meaning of its own. But what it does is it removes the uncommon words, uncommon suffixes. Basically, it removes all the uncommon suffixes and then puts a word that is pretty much common. But lemmatization is, you can say that it's slightly more intelligent. It produces a meaningful word that has some kind of meaning. So all these same 5 words will be drilling down to change. So this is what we call as lemmatization. And why we use lemmatization or stemming is because there will be several words that will be having several different types of different types of tenses or grammars or suffixes, but the meaning will be same. So in order to narrow down the analysis, we use stemming and lemmatization. And now coming to part of speech tagging, or we can also say as POS tagging or grammatical tagging. I think we all know about it when we used to read English during our school time. So it's nothing, just dissecting the sentence into the part of speech and as part of speech and tag it along with it. So here you can see that I want an early upgrade is a statement we have here, and for each and every statement we have the words, and everything has been tagged into the part of speech. So I stands for pronoun, want stands for verb, and early stands for adjective, noun, upgrade stands for noun, and an is an article. So these kinds of techniques will help you to understand which one you can eliminate and which one you have to retain it. So ultimately everything, we are using these techniques to understand the intent and entities of the statements. Now coming to named entity recognition, I have mentioned about what are entities, right? So entities are basically things that are associated with the statement. It's not an intent, but all the things that are associated with the statement. But entities can be of different types. So previously when I quoted, when I want to book a flight from Delhi to Bangalore at 5 p.m. So Delhi and Bangalore is what? It's a location, and 5 p.m. is what? Time, and today is the date. So these are all the kinds of categorization we do for the entity. So NER is a technique where we categorize the entities and then understand what are these types of entities which we have detected right now. So in this statement, in this paragraph, it has been talked about Albert Einstein. Albert Einstein is a scientist, and it has spoken something about that. So here Albert Einstein will become PER. PER stands for person, and Germany, Munich, and stands for LOC. LOC means location, and where he later on began his schooling at Wiltpord Gymnasium and entered some polytechnic school. So these two are then again subcategorized into organization. ORG stands for organization, and again Zurich means location. So these are all NER, which is actually very important when we are developing a bot, and especially when we are developing a free flow conversation bot, which is intelligent and also context based. Now, sentiment analysis, as I've already mentioned, sentiment analysis means we are analyzing the sentiments of the particular person whom the application, the chatbot, will be interacting. So on a large basis, in general, the sentiment will be drilled down into 3 types of sentiments: the positive, neutral, and negative. If the experience of a customer is fantastic, it seemed to be like a positive kind of sentiment. And then if it is okay, it's neutral, or negative means it's a negative kind of this thing. So but sentiment analysis, sentiments can also be broken down into various other types of sentiments like happiness or sadness or anger or disgust. Such kind of sentiments can also be broken down. Now, when we want to fuse chatbots with NLP, so this is the generic diagram of an NLP. We have already spoken about NLP and how we are going to inculcate NLP in chatbot and then create an effective intelligent chatbot. So this is the diagram about it. NLP cannot be running by itself. It needs some kind of data. So this data will be taken from database upon a request. The database will have all kinds of data set, and we will also have other kinds of ML algorithms through which we can decide what kind of replies has to be given when the user is interacting with the chatbot. So that's when the data set will be used for data modeling and training when it comes to machine learning. NLP is also there, but NLP has a lot of other machine learning algorithms and techniques which is kind of little complex. But when we are retraining the data set again and again, which is the basic concept of any ML procedures, so then we give an output, and that output will be given in the form of message generator. So that's how we use NLP in chatbots. Now, how you can get started? How to get started is if you're not a hardcore programmer, then you can start off with with a framework which has lesser programming skills that needs to be required. So like framework based chatbot development. So the framework based chatbot developments are pretty straightforward. It doesn't need a lot of programming skills because the framework itself will give you a lot of facilities to leverage and build a chatbot. So one of the basic major examples of framework based chatbot is Microsoft Bot Framework, which is a Microsoft product, and it's open source. And it also have some other facilities like Q&A Maker and Lewis AI. If you're using Lewis AI, that means you are also inherently using NLP in that. So Lewis AI itself is a product. It's a web application where you can get all the NLP related techniques apply on the data, and you can leverage it using an API. So once you publish train those models using dataset, you can publish it, and those APIs after publishing, you can use it in your application. And you can get more details on Microsoft Bot Framework on https://dev.botframework.com. And similarly, there is also something called as Google Dialogflow, which is a Google product. It is also pretty much similar to Microsoft Bot Framework, but it's a Google product, and it also uses somewhat similar technique like NLP intents and entities, and it's pretty much ready-made. You really don't have to do a lot of programming in that. But if you want to do a lot of programming and customized, high level of customized and intelligent chatbots, which is catering to your very highly customized needs, then you can do programming based chatbots. And I've been doing Python based chatbots programming using different libraries. Python is one of the best programming through which you can develop a chatbot, because it has a lot of libraries that you can directly use, and it's open source. So for UI, you can use Flask framework or Django. And for NLP techniques, the most widely used technique library we use is NLTK, followed by Spacey and Rasa NLU, Chatterbot, TextBlog, etc. And for dataset modeling, you can also use TensorFlow or Keras. In combination with all these libraries, you can develop a cool chatbot and publish it on your channel as per your choice or requirement. Now, coming to conclusion, I would say that chatbots are highly effective tools when it comes to education, incident response, e-commerce, and a lot of industries are using chatbots right now. It could be a simple chatbot or it could be a complex chatbot itself, but they are used extensively right now, and it's ever evolving. So right now we are just doing voice-based interaction. Maybe in future We will be doing the facial recognition system and then interact it, and also use facial expression to recognize the sentiments as well. And the aim of the chatbot designer should be to build tools that help people, facilitate people and their work, and facilitate the process. If there is any repetitive task, that can be also automated using chatbot. And but it is not to replace the human role totally. It's basically enhancing the interaction and then providing a better level of facility and accessibility to the user to initiate human conversation. Yeah, so that's all for now.
Thank you, ma'am. It was a really informative talk. Ma'am, and could you share your PPT like one of the audience wants it?
Yeah, sure. Shall I share it here itself?
Yeah, ma'am. In the chat section or the private chat, anywhere it's fine, ma'am.
Okay. Okay. Let me do that. Just be online. How do I do that? Shall I just drag and drop?
Yes, ma'am.
I'm not able to share it.
Ma'am, not an issue. We'll have time to put that into the chat, so you can do that. Yeah.
Yeah, sure.
So thank you for the talk, and it was amazing. So Samuel, we can move on to the next speaker for today.
Thank you.
Thank you.
Yeah, so the next speaker for the session is Dimple Bansal, who is a senior data scientist at Coincide.ai, to give a session on the topic building custom scalable face recognition pipeline.
Hello everyone, I am Dimple Bansal and I welcome you all to WiDS workshop wherein we are going to talk about how we can build custom scalable face recognition pipelines. So just a brief introduction about myself. I am IIT KGP alumni from the batch of 2015. I have 5 years of industry work experience wherein I have worked on various verticals such as retail, telecom and media. Currently, I am working as a senior data scientist at 2.ai, wherein we are trying to build an AI platform so that businesses can build and deploy AI use cases at scale. So a lot of use cases that I have worked on over the career span of last 5 years would be recommender systems, search engines, user personalization, product rankings, supply chain optimizations, and so on and so forth. I'm also a public speaker where I have published few interviews talking about the application of AI in business use cases. Now let's move on and let's talk about the potential use cases that we can serve using these facial recognition algorithms. So I have tried to broadly classify these use cases into 3 categories. These are enhanced user experiences, something that we get to see almost every day. So it's automated face tagging by Facebook, photo grouping by Google Photos, in which they try to gather all the photos of a single person into a certain folder. And then we also observe that a lot of gadgets are coming up with face recognition unlocking mechanisms along with the number locks. Now, coming to the security, these algorithms are also being used to identify the criminals in forensic investigations and law and order enforcements. Now, coming to the digitalization, especially in the post-COVID era, where a lot of things are moving online, so there is a need of an art to automate a lot of things. So, just to recommend few, these are biometric attendance systems and, if possible, online polling booths. Now coming to the pipeline flow that I'm proposing here. So it is a 4-stage process where we start with data curation, then comes the cleaning part and model building and then inferencing. So in data curation, the use case that I'm going to talk about is how we can build the celebrity recognition algorithms. So since we're talking about celebrities, there is no dearth of data available online. But at the same time, I would like to bring to your attention that the data that we are curating, it should be diverse enough along these 5 dimensions, which are expressions, emotion, pose, age, and makeover. This is to ensure that the algorithm that we are building becomes invariant to all these natural or induced variations. Now coming to data cleaning, so right now we have folders wherein we have these folder name as the celebrity name, and within that folder we have collected all the images that we could. Now we need to clean the folders because it might so happen that some of the images might get mislabeled or might get mapped to wrong folders. Or it can be a case where the images, the particular image is having multiple people, so only one person face is something that we would like to retain and discard all of the irrelevant faces. So for that, we have to first detect the face, where we need to get the bounding box of a face, and then we need to encode the face. So the way encoding works is it tries to identify the key landmarks of a face, and then it tries to embed the face into 128 or 512 dimensional embedding space. And the architectures that are available out there are learned in a way that similar looking faces are closer in embedding space than the faces which are dissimilar. Now to clean the faces which gets wrongly mapped, we have to use graph algorithms such as community detection and graph clustering, which we will talk in details in a while. Now moving to model building, so I'm proposing 2 sort of models. One can be classification based models because it's a multi-class problem like we know. The other thing can be approximate nearest neighborhood search. So both these algorithms have their pros and cons, which we are gonna discuss in a while. Now moving to model inferencing part, the inputs that we can expect would be of 2 types, the images and videos. So we will also talk about how we can optimize the inferences that we are making to the model so that we can optimize the total runtime of the pipeline. There is one more point that I would like to bring to your attention. So when we are gathering the data to initialize the pipeline, we should only look out for the data for which we are more confident, right? But as and when we are testing and evaluating the observations, the test observations for which the prediction confidence is very high, we can channel these observations back to the data pool so that the entire pipeline becomes a semi-supervised approach over time. All right. Now moving to data cleaning. So the first algorithm that we need to talk about is community detection. It's a graph algorithm wherein we see that all these nodes that we see are basically the faces with their respective embeddings. The edge represents the space between 2 embeddings. So we can see that there is this condensed, dense, and tightly knit set of communities at the center of the graph, and rest all nodes are basically far away from the center. So these are basically the anomalies or the outliers that we need to reject. Now to give you an example, so this is the community set that I got for Angelina Jolie. So these are top communities which are having the maximum amount of observations. So like we can see that these 2 communities are basically trying to capture all sort of possible facial expressions, makeovers, and stuff like that. And these 2 top communities is something that we can retain, and all the long tail communities we can reject, assuming that those all communities are too small and hence contain the faces of the people which are irrelevant in this folder. All right. Now moving on, there is one more approach that I'm proposing, which is graph clustering. So for this, I would like for all of us to take a while and appreciate the robustness of this embedding. So if we see that all these faces are pretty diverse in a way that they belong to different age range of this actor, and then there are different facial expressions, then we see that there are different makeovers that this actor is having in different photographs. So it's pretty robust, and it's trying to identify this person and put all the relevant images into one single cluster. So I would propose that clustering to me sounds to be a more appropriate algorithm in this use case. But yeah, we can go ahead with community detection as well, where we will have to merge the top communities. And here in this case, like we can see that it's a pretty big cluster. So all the clusters in which the number of observations are pretty small, that we can reject under the same hypothesis that they might be noise to the data. Now moving on, the kind of anomalies that we are trying to remove here. So in celebrity dataset, what I observed, the anomalies that I was receiving were mostly because there were images wherein there were siblings, there were spouses, then there were contemporaries, and sometimes they were around the lookalikes or stuff like that. So, but we need to appreciate the fact that in the first left-hand side image, we see that there is this girl which is a lookalike of Angelina Jolie, which to a human eye looks pretty close to Angelina Jolie, but somehow this algorithm understand that this belongs to some other person, and hence it has created a different cluster and has put that person in a different long tail, which we can reject. Now, in the right hand side, we see that in Audrey Hepburn, there is this Marilyn Monroe cluster, which means that there were a lot of images in which both these actresses were being compared. So yeah, so we see that there are a lot of such clusters as well. Now moving on to model building. So coming to the classification model, so it's a multi-class classifier, and there are a lot of algorithms that we can use in ML and DL space. We can use a transfer learning on the embeddings that we have got, and then we can have a downstream task to build a neural network on top of these learned embeddings. But we need to look into the fact that some of the algorithms are lazy learners, whereas the other ones are eager learners. So what I mean by lazy and eager, so it basically means that, let's take an example of KNN algorithm. It's a lazy learner because of the fact that there is no model learning that happens. So whenever you pass an observation for it to predict, it tries to locate the nearest neighbors, and basis that it tries to aggregate the prediction of all those neighbors in the training data set. For regression, it generally takes the average or the weighted average. For classification, it takes the model value. So the advantage of lazy learners is, so in case we want to add more celebrities or more faces, in that case it helps because we need not retrain the model because there is no training happening as such. But having said that, it's very bad on inference side because it has low QPS, queries per second, and high latency. So it depends upon the eventual use case. But in case we know that this is a set of identities that I want to recognize, and that is something which you can provide beforehand in the first iteration, then I would recommend you to go for eager learners, because then there will be a learned model and the inferences will be fast. But whenever we add new faces, we need to retrain the model. So now I'm proposing one more solution here, where I'm trying to merge the pros of both the models, and I'm saying that what if we can skip the model training, but at the same time leverage the neighborhood algorithms because of the fact that they are lazy learners, right? So I'm proposing approximate neighborhood algorithms, which are basically greedy search algorithms, where they try to limit the search space in which they need to locate the neighbors. For that, what they do is they try to index the observations in a way that whenever a query observation comes, they need not find the neighbors with respect to all the algorithm, with respect to all the observations in a brute force manner. Instead, they look out for neighbors only in a limited search space. So index search in a way is very fast as compared to brute force. But I think you must have guessed by now, but it's gonna come at a cost of lower accuracy. For that, we need to tune the algorithm while building the index in a way that we can maintain a balanced trade-off between the accuracy and the retrieval speed. For that, what I'm saying here is, So model building we can avoid. So because model training is definitely more trickier than tuning the tuning the parameters for building indexes, and this way we can leverage the pros of both the modeling techniques. Now coming to the inferencing part, the first input type that we can get is an image. So depending upon the model that you have chosen, if you have chosen a classification model, so we have to first detect the face, and then we have to get the embedding, then pass that embedding to a classification model, which is going to return a predicted class with the probability score. But what if you choose an indexing nearest based neighborhood algorithm? In that case, the embedding of this phase needs to find the most similar matches in the training data set, and then it can return the model value of that predictions, and you can return the relative frequency as a confidence score. Now coming to videos, this is a video in which there are three key people. There are two people who are being interviewed, and then there is one host. So we need to basically identify all these three people in this video. So video is a collection of a hell lot of images, because let's say this video is 20 fps. So we can't literally run the inference on each and every frame. So we need to optimize the number of inference calls that we are gonna make to the model. So for that, I suggest that we need to first extract the keyframes and then build the phase clusters on all the keyframes that we have detected. So in this case, like I said, there are three people. So I got three phase clusters, and rightfully so. One is for the male celebrity, the other one is for the female celebrity, and third one is for the interviewer. So in these clusters, we near duplicates we can remove, and we can run inference only on the candidate pairs or candidate set of subset of these faces, and then we can confirm the prediction on these candidate sets. In this case, we can limit the number of inference calls we are making, and at the same time we can increase the we can have a better performance accuracy. I believe we have some time left, so I will quickly take you through the code base to understand the algorithmic implementations. Just a moment. Yeah, so this is a script to detect the bounding box, for which I'm using a very popular library called face recognition, and this method called face location is going to give us the coordinates of the bounding boxes, and then I'm using the matplotlib functions to basically add a rectangular patch on the detected face. Now moving on to the encoding. So in a given celebrity folder, there are gonna be multiple image files. In every file, there might be multiple or single faces that we need to detect and then encode. So I'm using the same face recognition library, and this method called face encoding is gonna give us the 128 sized vector embeddings. So I'm iterating over all the files in this directory, and to utilize the available resources in an optimal manner, I am using a multiprocessing library to iterate over to basically iterate over all the files and process them in a parallel fashion. Now I'm creating a dict with all these four keys: the name, the celebrity name, image location, embedding, and the location, basically the coordinates of the bounding box. And then I'm dumping all these dict items into a TF record to be consumed by the subsequent models. All right, and now coming to community detection, I'm using this library called NetworkX. Here we are reloading all the TF records for a given celebrity, and then we are gonna create a graph, in which we are basically gonna retain the nodes for which there is a edge distance lesser than a certain threshold. So we are making an adjacency matrix. We are using Euclidean metric to get the distance between two nodes, and we are making an binary adjacency matrix, and we will be retaining the pairs which are pretty close to each other, and we will discard the rest of them which are distant to one another. And using the adjacency matrix, I'm getting a graph, and from that graph, then I'm using these matplotlib functions to depict the graph visually in a spring layout. Then, like I have shown you, for every community we have a sprite image which shows all the images of the faces in a grid structure. So this is what this script does. And after that, we are generating the dict, community-wise dict with all the four keys, and then we dump only the communities that we want to retain in this TF record files. The same thing we do with the graph clustering. The only thing that changes is it is rather than dumping the TF records for communities, here we do it for per cluster. So for clustering, we are using Chinese whispers algorithm. So for that, the same thing repeats, where we are using the adjacency matrix building graphs, and then we are getting the clusters and sorting in the descending order of their size. Then we are getting the sprite image for all the clusters, and then we are dumping the TF records in a designated path. Then moving on to model building path. So if you are choosing the classification approach, so you can experiment with algorithm of your choice and go ahead. But I'm using the second approach for the index based nearest neighborhood search. So I'm using NY algorithm to build index of on my training observations. So here I'm reloading all the TF records from all the celebrities, and then I'm using this to basically create two files, the index files and the mapping files. The index files is gonna have an identifier and the index, and the other file, mapping file, basically is gonna have the identifier and the true label mapping. Now coming to the model inferencing part, for images, so what we are going to do is we are going to detect the face, embed the face, and then we are going to find the most similar matches. For that, I have a script called similar face detection, where I am loading the index files, and then I am using these two methods, find similar vectors and find similar items, which is going to return the most similar matches as per the query embedding. So that's exactly what's happening here. So once we find the most similar matches, then we are gonna get the mode of those similar items, and then the confidence score will be basically the relative frequency, which is gonna be same as the items which are gonna have the name same as the model value divided by the total top n matches that we retrieve. Then I'm annotating the image with the bounding box and a true label on top of it. Now coming to video inferencing, like I said, in video we need to first detect the keyframes, then we cluster all the keyframes to identify the different faces, and then in a given cluster we run inference only on a subset. So that's exactly what's happening here. So after detecting the keyframes in a video, so I'm generating this adjacency matrix, and then I'm building a graph. On that graph, I'm building clusters. Then the sprite image I'm saving per cluster, and then from every cluster, I am retaining few. I'm choosing basically few candidate faces on which I would want to retrieve the most similar match and basically make a prediction on. So that's what exactly is happening here. So I think that would be all, and so this brings us to the end of the session. So I thank you all for your time, and I hope that you find this session useful, and I would like to thank WiDS for giving me this exciting opportunity. So these are my personal accounts which you can reach out to in case you want to discuss anything in detail, or if you have any query, feel free to reach out. So thank you all and good luck.
Thank you, ma'am. It was an informative session. It was a great session. So the next speaker for the session is Jnana Lakshmi, who is a product manager, emerging technologies at Whaley, to give a session on the topic blockchain evolution from Bitcoin to Algorand. Welcome, ma'am.
Samuel, thank you so much. Thanks everyone for being able to join me today. So let me share my screen and just give me 1 second. All right. I hope everybody is able to see my screen and see the inception that's going on.
Yes, ma'am.
Awesome. Okay. So thanks everyone once again for joining me today. We are starting at about 4:39 on my watch, let's say 4:40, right? And I have asked for 2 hours because this is not just going to be an introductory talk, but along with the introductory talk, I would also want to do like a code along session with you all. So the idea behind the code along session, along with the introductory talk about blockchain, is that you not only understand what blockchain is, you not only understand the technology, but you're also able to convert that into, what you do in a day-to-day life as a technologist, as a programmer, right? How do you actually implement, some kind of solution? Let's say we'll not be implementing a solution, but we'll get started somewhere, right? So the idea is to make sure that you don't get intimidated by the topic blockchain, right? You understand when you look at the code that we'll be doing today and the kind of things that we will be working on. Very nice, very interesting stuff, as well as very, very easy, right? Even for beginners as well. So that's the idea, and that's why I asked for 2 hours, and Usha and the other organizers graciously gave me the time. So thanks a lot. And yeah, welcome today to this topic, which is going to be blockchain evolution. We'll talk about how it originated from Bitcoin and how the new frameworks, new and upcoming frameworks are, taking the world over by storm. I'll be talking about an interesting framework called Algorand, which we will be using for our coding purposes as well. And as Samuel very nicely described, I'm Jnana Lakshmi, also known as Gyan. I work as a product manager at Wiley Next, and I'm also the ambassador for several blockchain technologies, blockchain frameworks, organizations that exist as of today. Some of them are Algorand, Eternity, and Polkadot. And I also work a lot in the space of artificial intelligence and data science, and that's how I'm kind of here, right? So let's get started. The agenda for the day is the origin story. We'll talk about how everything started, a sneak peek into the technology itself, right? So I would suggest if you're all watching through your phone, then it is time to migrate to your laptops, to your computers, right? Because we'll be doing some hands-on, you'll be looking at some stuff yourself. The blockchain promise or the advantages, right? So what are the advantages and what does blockchain offer? Introduction to Algorand, the framework that I spoke about, and then we'll do some coding, some hands-on as well. And I end it with Q&A, of course. Feel free to ask me any questions, keep asking your questions, keep putting them. And, we'll take like a 20-minute break, a 20-minute talk, and then we do a break, and then I'll try to, answer as many questions as possible. So yeah, I mentioned in all the social media that I'll be doing a giveaway. Well, the giveaway is going to be a cryptocurrency known as Algo, right? And for that, what you need to do is you need to download the Algorand wallet on your mobile and share your wallet address as well as your email ID through which you signed up on the wallet, right? So once you download the wallet app, I don't know if you can see it because my phone is like really small, but the wallet app will have the Algorand symbol, like a small A. And once you download the wallet and you register, you create an account for yourself, right? You see your account, your name, and then there's like a QR symbol right next to it. So once you click on the QR symbol, you get a QR code and an address that is your wallet address, right? This is how you will be recognized on the blockchain. And you need to copy this address as well as the email ID that you used and share it with me. And top 10 lucky folks will get some algos. You will be able to, I'll do it right after the workshop itself. You will be able to see the algos in your account. The idea is well, of course, to encourage more people to understand what cryptocurrencies are, what tokens are, and not just that, but how they work in association with the technology. And there is another interesting concept called staking, which you will learn when you keep these algos that I'm sending to you in your wallet over a period of time. So the idea is to introduce, of course, the technology as well as help you understand these different concepts, right, that work uniquely. So yeah, feel free to post your wallet address and your email ID, and you will definitely be getting a surprise. So yeah, let's get started right away into understanding why we are here, what this technology is all about, right? So in the year 2007, 2008, when there was a huge financial crisis that happened across the globe, right? A lot of economies, you could say, collapsed. There was a huge dip in terms of employment. And it was one of the biggest events that happened on well in the world, right? If you could put it that way. What exactly happened at that point in time, right? During the huge financial crisis, a lot of banks, investment banks, and all these centralized institutions where your money is held declared themselves as being bankrupt, right? So what that means is if you have any investments stored in any of those banks, right, those investments, once the bank has declared as bankrupt, there is no way to retrieve the entire investment, right? So, and if you haven't invested a significant amount of money according to the investment bank, but not according to you, then there is no way that they will give you as much importance to ensure that all of your money is returned, right? So, this was one of the events that inspired a lot of people across the globe to think about how the financial system overall in the world works, right? We put our trust in these centralized institutions or centralized bodies, right? For example, banks, other intermediaries, investment banks, right? Organizations where sometimes where we go to get our personal loans, right? So all of these are centralized bodies, right? So they control everything, they control your money. And this is where people started thinking about this unique concept called trust, right? The idea of trust came about in the during this crisis as to how much can you actually trust these financial institutions to keep your money safe, and at what point in time will it be in such a way that you are completely there is a huge transparency in terms of what is happening. Will that point ever come, right? So one of the biggest things, and this is one of the examples that I always want to start with because it has such a huge impact on how things shaped up. But one of the other things also that we talk about when we talk about Web3 technologies like artificial intelligence, blockchain, quantum, IoT, right? One of the biggest things that is missing in the Web3 umbrella when it comes to data is trust, right? If you think or if you have heard of some news that some of the apps are scam, right? There was a recent news about, Zoom. Having some issues, and people just immediately uninstalled Zoom and started looking for other alternatives, right? Because security, data privacy, all of these things are so important. And one of the biggest things that was missing in the Web3 technology umbrella was trust, right? And to solve this problem is when one person or a group of people, which is still not cleared, known as Satoshi Nakamoto, wrote a paper known as Bitcoin, a peer-to-peer electronic cash system. This paper was released in the year 2009, which was right after the great financial crisis of 2007-2008, where Satoshi Nakamoto proposed an electronic cash system known as Bitcoin, right? And Bitcoin, the underlying technology of Bitcoin is the technology that we hear of, speak about, or are familiar with, known as blockchain. Though there were different types of solutions like online cryptography, digital signatures, etc., that were already in place, right? Blockchain provided a new kind of system where you can transact online, right? You can actually exchange money without having to go through a third party, right? Right now, for our credit card systems, for our banking systems, for our net banking, for transfer of money, we are still dependent on a centralized third party like a bank or any other intermediary. But this was the first ever system that said that you can transfer online without needing to trust a third party. But what do you trust instead of a third party? You trust the system, you trust the network. And what is the network made of? The network is made of all the peers who join the system. So essentially, what you do is there are some underlying computer algorithms which ensure that transactions can happen in a smooth way over the network, but your trust is actually on the network itself and not on a centralized body. This was something that was completely different, and this is where we can say that the origin of blockchain started. This paper solved a very important problem for electronic cash. The problem was known as double spending problem, right? Because electronic cash is dependent on computer algorithms, it is easy to forge the cash and replicate it, right? Whereas if you have paper cash, when you go to a shop, somebody can always verify whether it is 1 rupee, 2 rupees, 10 rupees, 100 rupees, right? Just by looking at it. But electronic cash, it is easy to forge. And this particular paper brought about a technology that solved that problem of double spending. So through the next couple of minutes, say the next 10-15 minutes, we will try to answer some of these questions, right, and understand how the whole ecosystem works, right? What is a blockchain network? What is it actually made up of, right? How can we become part of the network, right? And when we talk about blockchain, we also sometimes state it as a distributed ledger technology. So when you think about these terminologies, what do they mean? What is a ledger, right? And as I explained to you, we will then come back to the slide to, just do like a summary. So what is blockchain, right? What is a blockchain network, and what are these blocks really, right? So a blockchain is a chain of blocks, each of which are connected to each other, like linked lists in programming, right? So and what do each of these blocks contain? Blocks contain of a set of transactions which are all clubbed together and combined to create a block, right? And each of these blocks are connected to each other. This technology is also known as a distributed ledger technology. Why? Because all of the transactions that are happening in a public blockchain, right, are all present in one ledger. You can think of a ledger as a notebook, right? As a place where you store information. And if you think about a notebook, the analogy for a notebook in a digital system, think of it as a file, right? So a ledger is nothing but as simple as a file where all of the transactions, every transaction happening on that particular blockchain, which you're a part of, that network which you're a part of, will be updated on the ledger. And the ledger is present with everybody who's a part of the network, right? What is the blockchain network? The blockchain network is a connected set of nodes or peers, right? Who are who basically form the underlying network, right? Like when we go online, we become a part of the internet, right? That's a network. That's the World Wide Web, right? And similarly, there are different blockchain frameworks which have their own network. And by creating an account on that particular network or on that particular framework, you become a part of the network. As simple as that. Set of connected peers or computers, right? They're also known as nodes. And yeah, that's it is open source and it is immutable, right? So almost every single blockchain framework that is out there today where people are building business applications, it's all open source, right? And the information, that the transactions that are clubbed together, right, the information that is clubbed together and created as a block is immutable. That is, you cannot change the information very easily. I'll show you in just a bit how. And of course, this brings about the concept of decentralization, right? Because you are now functioning in a network which is having some rules, which you agree to the rules and you have joined that particular network, right? And you know that you can transact amongst the entities on that particular network. Sometimes you can even cross transact. That's a little advanced concept, but think of it this way, right? That you're forming a huge ecosystem. Right now, if you think about the Bitcoin blockchain, there are, I think, over a billion users, right, who are using this technology. That means all of them are a part of the network, and you are now not dependent on any centralized agency for your money to move around, right? For your value to move around. So you can not just move money, but you can also move assets, right? Which I will talk about in just a little bit. But you can now move around value, right, over a digital network without the need for a third party to step in. And you don't need to pay that third party a lot of fees. Instead, you will be paying minor fees to your network so that your network is able to perform that operation, right? So that brings about a sense of decentralization. So like I said, I'll show you a sneak peek of what blockchain really is, what the blocks are. So if you can see my screen right now. I hope everybody's able to. So when you think of blockchain, right, let's start with a block. And I'm sure all of you are already familiar with the concept of hash. So if you just, you know, every data that you write or any kind of data that you write onto the blockchain, it's all hashed, right? There's a SHA-256 hash that we are seeing as of now, and hash is nothing but a unique string that is generated, and for every piece of data the string is completely different from each other. So you can see that even if I just add one character, right, the string changes completely. And for every data that is similar, that is the same string will be generated again and again. So like this. So that property is called determinism. So if you see, when I add y, you get some other value. When I add this, you get some other value. So I want to share this link with you to kind of experiment, if you would like. I'm sharing it. I don't know if you are able to see it since it is happening on the YouTube live, but I'll share the links nevertheless later as well for you to practice, right? So let's take a look at how a block actually looks like, right? This is interesting. So this is how an actual block in a blockchain would look like. You see there is a block ID, there is a nonce. This is a unique number which is used to trace this particular block in the blockchain. And then there is some data. Like I said, the data is going to be set of transactions, right? So let's take our usual folks. Alice sends 10 bitcoins to Bob. Suppose this is one transaction that happened, right? Let's say there's another transaction that happened that Bob sends 20 bitcoins to Dave. Okay. So now this is my block ID. There's a nonce. There are certain set of transactions that I've clubbed together, right, and put it in this particular block. And there is a hash that is generated for this particular data, right? Now, when I say mine, what it means is this block will now be added onto the blockchain. Right, so let it mine. It takes probably a couple of seconds. If you're interested to check out this website, it's andersbrownworth.com, right? And it's pretty cool for doing some hands-on. Now, this block is mined, right? Now, let's see how a blockchain looks when there are a couple of blocks, right? So there is some data here, then there is some data here, then there is some data here, right? So first, this block gets mined, one block gets created, right? And I'm just writing some random data. Don't worry about it. And this is the first block, also known as the Genesis block. So every block is connected to the next block using hashes, like I mentioned. So the hash of this block is BF57F, right? That is generated. And this particular block is connected to this block by storing the hash of the previous block here. So you can see that this block's hash is being stored in this block, right? And similarly, the second block's hash will be stored in the third block, and the third block's hash will be stored in the fourth block, etc. Right? This is how your blockchain progresses. Now, what happens first when the set of transactions come? It is stored and then it is mined, right? So now this block is mined and it is added. Now, when we talk about immutability, right? Immutability, like I mentioned, is that you cannot easily change the information that is present in the blockchain, right? So what does that mean? Once these blocks are mined and added to the blockchain, right, you cannot suddenly change the values that are present inside, the transaction values. So suppose you try to edit something, right, over here, then what happens is this block becomes red, right? Earlier, the block had some other value when it was mined and added. So when you try to change some value in the block, this block becomes red, right? The hash of this changes. Then this block, but this block is having some other hash, right? It is having it is saying that the previous block's hash should start with 500 something, right? Sorry. So now this block shows, so this block's hash, if I change, then you see the whole blockchain becomes red, right? Because this mined something else before, but once I change it, the hash changes, therefore reflecting as a ripple effect in all the other subsequent blocks, right? And this is where the idea of immutability comes in, right? I don't know what character was there. But the idea of immutability is that you cannot change information very easily on blockchain. And this is one of the biggest principles pertaining to security that blockchain uses. That the data that you add or store in a blockchain is highly secure because it is secured by these hashes which are connected to each other in the form of blocks, right? So you cannot just change the data very easily in a blockchain. All right. One more thing that I wanted to show you, right? When I spoke about distributed ledger, I told you that every peer who's a part of the blockchain will have a copy of the ledger. So how does that look? Suppose you have an account on the blockchain, right? You will be seeing this particular block. So the whole distributed ledger is nothing but your blockchain, the data in your blockchain, like I said, the transactions, right? So this is your distributed ledger. This is how your distributed ledger would look like. Not exactly this, but similar, right? So if I type some data over here, right, and so let's say I mine it, it's going to take some time. Now whatever is present over here will actually be reflected with all the other peers, right? That is the idea. And when you see the block ID, the nonce, the same thing will be reflected across all the peers. Let me remove this. So okay, so it becomes a 11316 nonce, right? Just so that it's all the same everywhere. So if you see in a blockchain, one of the other strengths or one of the other ways where immutability or security comes into picture is that if one person tries to change something on their local copy of the ledger, right, it will not be reflected in others' copy of the ledger because you are only making change in your local copy, right? In order for you to make a change in the global copy, which is present with everybody, you need to add another transaction referring to that transaction, and then that will be added in a block and then added onto the blockchain. That's the only way you can make a change into in any data that you're having, right? So there are two ways immutability or security comes into picture when it comes to blockchain. One is you cannot change the data that is present in the block itself because it is having the support of hash. And the other one is because this whole information is present with everybody who's a part of this network. Suppose it's a Bitcoin network, then it's about these billions of people who are present on the Bitcoin network. Everybody has that data, right? So if you just try to change something that Alice, instead of giving 10 BTC, gave 15 Bitcoins to Bob, you cannot just change that in your own ledger, right? Which is likely to happen in information when you have paper ledgers, right? When you think of supply chain use cases or any other use cases across the globe, when you have a paper ledger or even like a MySQL database, it is easy to make the change in your local copy and then claim that that is the correct one. What is the way to validate that, which is the correct entry? What if there is disparity in financial entries across different databases, right? How do you ensure that which is the correct one, right? So that's where blockchain kind of brings in that security aspect. All right, we have taken a sneak peek. So just to give some closure into the basics, so because now we will be progressing to the next set of concepts. There are several use cases, like I already mentioned a couple of them, if you think about supply chain, how do you want to store data? How do you want to make sure that data is the same across all the entities who are working in that particular supply chain? Or if you think about banking, right, how do you ensure that you can seamlessly transfer money, transfer value, transfer assets to each other on a digital platform without the need for a centralized agency, right? So some of these use cases we already know, but there are a lot of use cases across different industries. So if you see finance industry, then there's trading, deal origin, POs for new securities, equities, fixed income, and whatnot, right? So across every industry, there is a use case that you can actually see, or that you can, where you see that blockchain can be useful in solving certain problems. So I had a use case video which I wanted to play. I'll probably play like 1 minute or so we have good amount of time for the rest of the concepts.
Ma'am, while sharing, you need to you have to click the checkbox for sharing the audio. Ma'am, can you unmute yourself?
Oops, sorry. Okay, just give me share screen. Okay, it's not giving me any checkbox. Um, let me try now.
Is known as the
Is the
backbone of
audible now?
cryptocurrencies. But the tech community
Yes, ma'am.
has been finding
Yes, ma'am.
other
It's
innovative
audible.
ways to apply the technology. So let's take a look at just some of its potential uses. The banking. The existing banking system is complex and often slow due to multiple layers of intermediation. Blockchain provides a secure way of sending digital assets without these third parties. Not only could this simplify the banking process, but it could also open the doors for those with no previous access. Deeds, facilitate transactions, and even grant access to properties through smart keys. The technology could streamline property sales, saving buyers time and money. In third is legal services. In a similar way to real estate, blockchain could disrupt the practice of law through smart contracts. These are legally binding contracts that are written in code so they can be executed exactly as intended. Next, we have online voting.
Okay, awesome. So we were able to see a couple of use cases. I hope that was slightly useful. I will also be sharing my screen, and I hope, yeah, I hope the organizers can share across as and when, and if not, then can be done later as well. Okay, so now that we are familiar with some of the use cases, let's talk about different types of blockchain that exist, right? And just a little bit glimpse into one of the types that we will be again doing more deep dive into, right? So the one that we will be looking at today is permissionless blockchain, right? So there are two types of blockchains. One is permissioned blockchain and one is permissionless blockchain. And as the name states, in a permissionless blockchain, anybody can join the network, right? The network is free and open for everybody to join. Whereas in a permissioned network or in a permissioned blockchain, it is a fairly smaller network which is created amongst certain parties who want to exchange information, right? Who have some asset or value transfer that they need to perform with each other, but they don't want the data to go out there and to be viewed by all the public, right? They may be dealing with some kind of sensitive data which is organization specific. In that case, they can create their own blockchain known as private blockchain, where they have some rules. There are some set of identity rules and documents that are required to join that particular network. Whereas permissionless blockchains are blockchains that are open source, available to all, and anybody can join that network given they are able to clear that particular KYC, etc., right? It's like creating a bank account now, but without the extra restrictions that come with a bank account. But of course, you nowadays, for regulation purposes, you need at least an ID. So a permissionless blockchain is a decentralized database that can be read by all, written by all, and it is immutable by all, right? So one of the most famous permissionless blockchains that came just after Bitcoin was Ethereum. Now, one of the other interesting things about blockchains is that we can't just transfer cryptocurrencies on top of that. So cryptocurrencies are nothing but digital cash with some underlying cryptographic principles, right? That rule the way the transactions of the cryptocurrencies work, and all the things that you would have heard of: Bitcoin, Ether, Ripple. These are all cryptocurrencies, right? But as you just saw a video where it spoke about different types of use cases, and there was something called smart contracts that the video mentioned. So what those mean, what the smart contracts mean is that they are the computing arm or computational arm of blockchain, which can be used to write business logic that you can deploy on the blockchain. For example, legal contracts, right? So if you want to have contracts, or if you want to build contracts with different entities, what you can do is you can put them in a smart contract, which will then be deployed onto the blockchain. And as we know that whatever we deploy onto the blockchain is immutable, right? So that logic, that agreement that you have built with someone else is now cannot be tampered by anyone, right? And that resides on the blockchain, and that agreement is something that you can use for future purposes when you need to, maybe the agreement says that after a particular date you need to transfer some money, etc. It could be anything, right? So these different kind of agreements and this business logic can be written in the form of smart contracts and deployed on the blockchain. So if we look at blockchain, what is the blockchain promise, right? What does it say that it will offer, right? The blockchain promise is that it will give transparency, it will offer trust, and it will offer immutability, right? We just saw how immutability can be offered, and transparency also we saw how the distributed ledger system helps you provide transparency, as well as trust that it establishes between the different peers who are a part of the network, right? So this is the blockchain promise. Now, when we think about building a blockchain, there are two major questions that we ask, right? One is that how is the blockchain immutable, right? And the second question is, when a block is selected, we say that a couple of transactions will be selected, it will be clubbed into the block, and then the block will be added onto the blockchain. But when a block is selected, who selects the block, right? Because a lot of transactions, when we think about millions and billions of people on the network, simultaneously lot of transactions will be going on, right? So which of the transactions do we pick? How do we pick the transactions? And how do we ensure that this particular block which has these many transactions, block A versus block B, which has some other transactions, right? Which block should we pick? Who selects the next block? Who gets that priority, right? Now, the first question is answered already by us. How is blockchain immutable? By, thanks to the cryptographic hash that is keeping the information safe, right? As well as the distributed ledger system. But to understand how a blockchain or how a blockchain is created with the help of blocks, how is the next block mined, right? Is where this concept of consensus protocols comes into picture, right? So as the name itself suggests, consensus, right? Consensus is nothing but a way to come to an agreement, right? So how does everybody agree to a protocol or to an algorithm, right? That this is the right algorithm to mine the next block. That is, everybody who joins the network agrees that yes, this network is having the right algorithm to add in the next block to the blockchain, right? Now, these consensus protocols are broadly split into two umbrellas, right? I will not go into the workings of each of these protocols themselves, but we will look at one specific protocol under proof of stake today as a part of Algorand. So when we talk about consensus protocols, like I said, there are two broad umbrellas. One is proof of work and one is proof of stake. Let's take a closer look at proof of work, right? So the Bitcoin blockchain itself and even Ethereum actually currently, though the first migration to proof of stake has already begun, till now Ethereum was also on proof of work only. So what is proof of work? What happens? In proof of work, to add each block to the chain, there are a group of people, right, or group of nodes who are known as miners, who/which are known as miners. What should they do? The miners must compete to solve a difficult puzzle using their computer's processing power, right? Now, let me show you, go back to this again, right? Your blockchain visual, where you see that that if you see the hash that is being generated has some kind of pattern. There are 4 zeros that are present at the beginning of every hash, right? If you see here. So this is one of the patterns that was fixed for early on 4 zeros. Now probably the number of zeros has increased to more than 32. But the idea is that when your computer is computing, it should compute some kind of random number, so that random number is nonce, which also comes into picture, right? Nonce is combined with some other addresses to create this particular hash. But what you should ideally do is your computer should keep keep running the processing, right? It should keep computing, and it should find out a random number, which then creates a particular type of hash, right? So if your computer, your node is the one that has created that hash, then you get the opportunity to select the next block, right? So you can say that I will choose these particular transactions, club them, and add the block, right? If you have successfully solved that puzzle. Now you may think that, oh, 4 0 to just develop to create a hash with 4 zeros is not that difficult. I can just do it on my own laptop, probably, right, in a couple of hours. But as the number of people on the network keep increasing, the problem to solve, or that particular random number that needs to be generated, is more, the complexity of that increases exponentially. And that is the beauty of proof of work, right? So in proof of work, everybody is equal. I mean, as long as those as long as we don't compare the computing powers, right? So if you think about, the idea was that if everybody has equal computing power, right, then everybody is going to work on solving a particular problem equally. There is no bias over here, that if you have more money, then you get to take a decision, or if you have more assets, then you get to take a particular decision, right? That was the idea of proof of work, that the next block is added based on some kind of work that you're doing, right? And in order to add a malicious block, you would have to have a computer powerful than 51% of the network, which is now almost next to impossible, right? The first miner to solve the puzzle is given a reward for their work in the form of bitcoins as well. Now, this proof of work has completely gone out of hand from what it was actually visualized by Satoshi, because of the immense amount of people who are on the network, A. And the second is, now the problem to solve has become so exponentially difficult that you can't just use a small computing resource like your laptop to solve that problem. You need to solve it using lots and lots and lots of computing power. And that's why there have been so much negativity, mostly around proof of work, though the idea is so brilliant, right? Because you're only dependent on a computer algorithm to solve a particular problem, right? So now it has become like a lot of waste of energy resources, because people are simply interested in setting up huge infrastructure, huge computing systems, just so they can mine bitcoins, right? Also because the number of bitcoins are limited in circulation. So the more you mine, the more, of course, depending on the price and things like that, you get richer, poorer, etc. Now, this is where, based on this proof of work, and because so many barriers to adoption are there when it comes to proof of work, there is also another bigger umbrella of consensus protocols known as proof of stake. Now, as the name suggests, proof of stake is not based on a puzzle. Rather, it is based on how much stake you have in that particular network, right? So you are chosen if you have more stake in that particular network. That is, you are given some kind of reward if you believe in that network, right? What do you mean by more stake? As in, you are more invested than that in that particular network, in that particular framework, right? So in this, what happens is, for example, in Algorand, right, when you have when you keep some algo tokens on your wallet, that's why I mentioned that you can download your wallet and share your wallet address, right? I will send you some algo tokens. The more algo tokens, for the longer time you hold in your wallet, you will see that you will start getting some rewards in the form of algos only, right? So what that means is the more stake you have, the more you invest in that particular blockchain framework, the more uh, probability you have of being selected to mine the next particular block or to choose the next particular block, right? And in order to add a malicious block, you would have to own 51% of the network itself. 51% of the tokens in the network you would have to own, right? Over here, there is no reward for making a block. So the block creator will get a transaction fee. Now, okay, so before I introduce Algorand, right, let's talk a little bit. I will share with you as to what are the different proof of stake protocols that kind of exist and how they're functioning right now. There are several types of proof of stake protocols that are under implementation. Even Ethereum is moving to Ethereum 2.0, which is going to be on proof of stake. But primarily, it is everybody is experimenting with how proof of stake works and how they can make it more and more decentralized in nature, right? So if you think about proof of stake, there is one algorithm called delegated proof of stake, right? So what happens in delegated proof of stake is that a set of delegates are chosen for that particular network by everyone, and then those delegates will always get to vote on the next block, right? And now this again becomes more of a centralized system because you're already choosing a bunch of people, and you are if any of them turns bad or malicious in the future, then there is no way you can do anything about it, right? You can remove them as a delegate, but much of the damage could have already been done. And another issue in this system is that since the delegates are already known to everyone, the hacker can easily hack that particular delegate and change the information of the block that they have selected, right? So there are also a couple of other proof of stake algorithms that are being experimented as we speak. But one of the most effective ones that have come out is by a framework called Algorand, by a blockchain company called Algorand. And this Algorand is built on a version of proof of stake known as pure proof of stake consensus protocol, right? Algorand is an organization that is co-founded by Professor Silvio Micali. He is one of the Turing Award winners, and of course, he has a great vision about how decentralization can actually bring about a borderless economy, right? That's the whole idea. You can build a range of decentralized applications, DeFi solutions, that is decentralized finance solutions, and processes on top of the Algorand platform. So your decentralized applications are nothing but applications that are built on top of any kind of blockchain framework, right? So I'll quickly explain how a block is selected in Algorand, or how does pure proof of stake work, right? And post that, perhaps we can take a quick 2-minute break while you set up your coding, coding related infrastructure, and we will be back with the code along and some more explanation of the concepts, right? So I'll take probably another 3-4 minutes, and maybe we can go for a break at 5:26 and come back at 5:30. Okay. So very quickly, how does a block get selected in this pure proof of stake based Algorand ecosystem, right? So the first phase is the proposal phase. Now assume that each of us, like whoever is invested in that particular blockchain, that means we have bought some tokens, right? Like I showed you my wallet, I have some amount of algos. I don't know if you can see, but I'm trying to show my mobile. I have like around some 4,000 algos, right? So these are the tokens that I have in my account, right? And for those of you who are participating in the giveaway, I will be sharing some of my tokens with you as well, right? And these tokens have some monetary value, right? So now a random token is selected amongst all the tokens that ever exist, right? So whoever has a wallet, whoever holds some token, they have a chance of getting selected in this first phase. This is the proposal phase. Now, what happens once they get selected amongst all the tokens? Their corresponding public key becomes known to all the users. So the key that I was talking about, this is your wallet address, right? A cryptographic key. This is the one that gets that this is a public key that becomes known to all the users. So this is your account address, and this corresponding user will propose, sign, and propagate a new block. So every time a new block is needs to be added to the blockchain, only at that particular time a random token is selected. So the hacker is not aware as earlier as to who is the person who is going to be selected, because it's going to be random selection, right? Now, another security threat over here could be that once a person has been selected randomly, even now the hacker, before the block is added, the hack and the time when this person signs, right, to add the block to the blockchain, it takes 4 to 5 seconds, which is one of the fastest transaction speeds, right, in amongst all the blockchain frameworks. But even in this 4 to 5 seconds, a hacker can hack, right? So that is where there is a second phase, right? In the second phase, also known as the agreement phase, amongst all the tokens, 1,000 tokens are randomly selected, right? So anybody again who now in this case, what happens is you can volunteer to be a part of the agreement round if you have any tokens, right? So 1,000 tokens are randomly selected in the second round. In the second round, their keys become known to all the users, right? So for example, now if I am selected, I am one of the 1,000 people, my key will become known to everybody else, right? All the users. And these 1,000 users will agree on, I mean, if majority of them agree and sign the block proposed by the first user who was randomly selected, that's when the block becomes approved, right? Now, in the second phase, if you see, there are 1,000 people who are selected, right? And it's not selected by any bias, it's not selected by the system. You have to run a particular small puzzle on your own system, and if you get the right answer, that means you will get selected in this 1,000 lot, right? So everything in this is extremely random, and there are two phases to ensure that high level of security is maintained and the hacker cannot hack easily, right? So the second phase or the agreement phase is required so that the hacker cannot hack just one person, right? Having just one key which is known publicly can be risky, or can be a hindrance to the security. And that's where in the second phase, 1,000 tokens are selected who will vote on the first block whether this block is the right one, and if majority votes, then that block gets selected. Now, for this entire process to happen and for a transaction to get selected, it takes less than 4 to 5 seconds for a block to get added onto the blockchain, which is one of the highest transaction speeds that is present in all the blockchain frameworks. So some of the technical advantages, I'll close, we'll go for a break with this. Some of the technical advantages of this Algorand framework are that it is truly decentralized, right? Because everybody is chosen randomly. Computation is trivial. It is not like proof of work, it is proof of stake. So you're not computing using too much heavy computation. Finality of payments, that is the blocks that are added, and that these are the final transactions added onto the blockchain within 4 to 5 seconds, right? You can build scalable solutions on top of this particular blockchain because it is highly secure and because the transaction time is very less. And security part we have already seen, right? It is very hard to crack the protocol. So before we start with the code along and I start with the dev stack, let me stop sharing and maybe we can take like a 1 or 2 minute break and come back, so that whatever links are there, I'm going to be sharing the prerequisite links with you, so you have it all in place. Okay, there is a question on to share email ID to share the Algorand wallet address. I will share the email ID. Sure. Give me 1 second. So what I'm trying to do is I'm trying to reach the YouTube link where the web streaming is actually happening, so I can share all my doc links that can be helpful for folks to get started. All right. YouTube. Since we have already done over an hour, I suggest please walk around, stretch your arms, get some water. If you have been attending sessions since morning, um, just trying to figure out the YouTube stream link. Yes. All right. So you're seeing myself here. Okay. Here is the prerequisites doc. Oops, sorry. Copy link. I have posted the prerequisites doc. Here is the email ID, right? And I have another doc which has all the code that we are going to look at today. So I'll copy the link. All right, now anyone with the link can view the code. There is SDK related documentation, which is also available. All right. So yes, I see that some people want to ask a question. Please go ahead and ask your questions, and you can. So Saurabh Dikshit, I saw that you want to ask a question about blockchain. Please feel free to go ahead and post your questions. I will try to take it one by one, and yeah, definitely try to solve all of your doubts as much as I can, of course. So I hope everybody has the prerequisites document. Okay, I don't think I'm sharing my screen now. Let me do it right away. If you have any basic questions, if you have any complicated questions, or just anything, just feel free to pop it to me, and I will make sure to get your questions answered. I meant to copy paste this link on YouTube as well, but I will do that once the live stream is over, right? So you can practice this part. So before we go into the code along, which is now that we will be writing some code together, I hope you have this prerequisites document. And what I want to say is that if you have Python 3, that is the first ever prerequisite for you to start writing some code on Algorand. And the second is to install the Algorand Python SDK. So the latest SDK that we are working with is version 2, V2. So if you don't, this is the first time ever that you're installing the SDK, don't worry about it. You will automatically get the version 2. So you can do pip3 install py Algorand SDK. So this is the command. And yeah, let me highlight this. So you need to install this, and you will, once you have the SDK ready, there are a couple of more libraries that are required, but you can install that on the go because they are not heavy libraries, right? And I had an optional installation, which is setting up and running your own node. This is highly recommended if you are interested to deep dive into Algorand and understand what is a node, and basically running your node, your own node is highly recommended. But the setup takes some time. It's not that time consuming, but it takes some storage and some time. So I would just let you do it on your own time. And right now, to program, what we will be using is we will be using a third party key, right? So okay, so let me just quickly explain this Algorand dev stack. I'm not going to go too deep into it. I'll just explain like some high level elements that are good enough for us to get started with coding. And of course, the more you're interested, the more you can always explore, right? So the three main elements of the dev stack are the key manager, a node, and the indexer. Right? We will not be working with the indexer in today's workshop. We will probably not even be working with the KMD at all. We will be working with the algod node. Right? So what is a node? Right? Like I said, for you to be a part of the for you to run the for you to run the particular network or that particular instance on your particular system, right? Wherein you offer the
Excuse me, ma'am.
yeah.
Sorry to interrupt you, ma'am. So they were like, they did not receive the prerequisites documents
Oh,
which we
so
shared.
I can, while I'm explaining this, you can still install the prerequisites. I mean, you need to install a Python 3 environment and just this SDK library. That's it. And we can get started. So should I share I have shared the document on the YouTube link. Should I share it elsewhere? The prerequisite document?
No, ma'am. Actually, we didn't get the link, ma'am. In the comments, we just got your email ID.
And above that, you didn't get the links? Okay.
No, ma'am.
No problem. I can reshare it. Not an issue. Um, 1 second. Copy link. So if I put it in the StreamYard, will you be able to take and put it in the chat?
Yeah, ma'am. I'll do it. Yeah.
Okay, awesome. So I will share both the links. One link has the code itself, right? So it's okay if you don't have the prerequisites or if you don't have Python installed on your system, that is fine. As I walk through the code, you can just take a look, and once you go back, since you will have this as a reference, you can also run it on your own system, set it up, and do the whole thing. So I'm not going to be taking anything too deep dive today because we are just getting started. So I want you to get comfortable with understanding that programming for creating a blockchain solution is not that difficult. That's the idea of the workshop, not to go too deep dive into anything, right? So don't worry about it. Don't fret too much, even if you don't have the prerequisites installed. You can install it as we go and work with me, or you can install it even post the workshop and take a look. Most important is to understand the concepts, so later you can use these to convert and build solutions. So if you think about the three important elements, like I said, key manager, node, and indexer, right? Running a node on your own system will give you the advantage that you will directly be a part of the network now. Like I said, right? Nodes are the ones that form the network itself. So once you are running a node on your system, you are a part of the network, right? And the node has something called the algo D, that is the algo daemon that is running. And the algo daemon offers APIs, right? If it is running on some other third party node, we can take the APIs and still build solutions, right? Because see, the idea of blockchain is what? When we want to store some information, that is the most important thing, like you saw, right? It's about securing the data at the end of the day. So what you do, you choose, if you, whatever network you choose, whatever framework you choose, right? You're choosing that framework because that framework is secure, it is more scalable, you can build more solutions, there are faster transactions, right? So what we are going to do in today's workshop is that we are going to choose an API based service, a third party service, which is running the node for us. So we don't have to worry about setting it up. but I highly suggest setting it up on your own laptops. I have a node running. I have it set up on my system, so I can bring up a node anytime, right? Which I'll show you in just a bit. But in today's workshop, we'll be using a third party called PureState.io, who are providing a node for us, and we just need the API key and the API details, right? Now, once we get the API key, what we can do is we can use our Python Algorand SDK. So there are SDKs, as you can see, in multiple languages: JavaScript, Python, Java, Go, right? So there are SDKs in multiple languages. You can choose the language of your choice. Today, I'm going to go with Python. So what we'll do is we'll take the API and we will use that particular node instance to perform our transaction, right? To do whatever we are doing. And that particular API will give us an algod client, right? A client instance, an indexer, and a KMD client as well. I'll explain what all of these are, right? A KMD is nothing but a key management daemon, right? A key manager will help you manage your keys. Now, what happens when you become a part of a network? What do you need to do? You need to create an account for yourself, right? In your account is where you will store your assets, and you can use that for transferring your assets, etc., right? So you need a placeholder to get started, and that's your account. Now, each account will come with set of keys, right? There is a public key, which is used to identify your account publicly, which I asked you to download your wallet and give me your account address, right? That is your public key. Everybody knows it. But to sign the transactions, right, to perform the internal authentications, there is another key known as a private key. So every account comes with this public private key pair. The public key is known to everyone, and the private key is known only to you. So for my account as well, there is a private key which is known only to me. This key management daemon, when you download, or this API when you use, it is helpful to manage your keys, right? Now, your keys are nothing but your public key is an address, your private key is like a small JSON file, right? So your keys can either be stored in a hardware that is over here on your local system, or you can store it in the cloud, right? So if you want to store your keys locally, you manage your account locally, then you can use the key manager, right? Manages the keys. The indexer is an interesting feature. It's an interesting API actually. So when you think about blockchain, right, there are so many blocks that are added onto the blockchain, one after the other, one after the other, right? Now the indexer is an element that helps you search for a particular information, right? So suppose you created your transaction, suppose a month ago, right? If you think about blockchains like Bitcoin and Ethereum, which are where transactions are happening every second, right? If you have created something months ago, how are you actually going to go and look at that information, right, in a blockchain? Because blocks keep getting added one on top of the other, one on top of the other. Every second there's a transaction that's happening, right? So that is where the indexer comes into picture. The indexer helps you find out more details about a particular transaction, right? It's basically a search, right? You search for something particular in a huge linked list. That's it, as simple as that. So today we will primarily be working only with the node, right? So all right, if you have this particular code along Algorand document that I've shared the link of this as well. If you have this, then I would suggest to copy the code till accounts.append and paste it in any editor of your choice, right? Like over here, I have this. This is my VS Code editor. So I already have my code. Should ideally not be showing you this, but that's fine. Okay, once you have this code, just store it as your accounts.py or something, right? We will be running this code together. I will take you through what this code is line by line, right? And what this all means and what are we doing in this process, right? If you see, the code is hardly like what 26 lines, given that I have like beautified it by spacings and all that. So this is all you need basically to create accounts, right, on your particular blockchain network. Here we are going to be creating 3 accounts, right? That's what we are going to do as a first step. Before this, what you need to do is you need to get your API key. Like I mentioned, we are going to access another third party, right? So we need an API key for that. So we will go over here. We will go to, so if you see the prerequisites, right? I have told to go to developer.purestake.io. Let's do that together. I already have my API key. So once you go to developer.purestake.io, you can register for free, right? And it asks you for your email ID and things like that. So I'm just going to log in because I already have an account, right? So once you log in over here, right, in the dashboard itself, you will find your API key, right? Why I went away from the API key is because ideally you're not supposed to share your API key, right? Because this is how your account can get compromised. But since this is for a development workshop purpose, it's fine. I don't mind. And what I'm going to do is I'm going to show you under the APIs that there are a lot of these different types of APIs that you can work with, right? So you can get the health of a node, and these are the APIs related to the node, right? Before showing you these APIs, as you can see here, this is Indexer Testnet version 2. AlgoD Testnet API. AlgoD version 2.1.3 Testnet, right? What does this mean? Now, the network architecture will consist of different types of nodes, right? So you have 3 types in Algorand, 3 types of network itself, right? One is called the main net, which is actually the main Algorand network, where for whatever transactions happen, there is some transaction fee. So unless and until you actually have some algos in your account, you can't transact on the main net, right? Because you need to pay some fee. Now people are when they think about blockchain, right, they think about, oh, we trust in the network and we can just transfer money to each other. But how does the network operate? Network also needs some computation, right, to operate underneath. The consensus protocols that are running, algorithms that are running, need some kind of fee for them to keep running, right? If you think about, it uses storage, it uses CPU, it uses computation, right? So there are transactions for the transactions to happen, as well as for somebody to take your money through an online through a digital infrastructure. There is an incentive that is being given to the person miner who has been chosen, right? So the incentive is given in the form of the transaction fee, whatever we have to pay. So unless and until you hold some algos in your account, right, you cannot transact on the mainnet. So for development purposes, or for you to test your applications, the best is testnet, right? So testnet mimics the original mainnet network, right? It has everything that the mainnet has, and the extra thing that it offers is that you don't have to have any algos in your account, right? There is something called a faucet, which I will show you, using which you can fill up your account, right? Which gives you some free algos, which don't mean anything, right? They don't have any monetary value. There is another type of network known as beta net, right? In Algorand, the beta net network is the one that is frequently updated with all the information. So think of it as like, how you keep like a production code and you keep a development code, right? So here you keep development part 2, where in development is where you push all your development changes, and then later you push it to the production code. So it is something like beta net, testnet, mainnet. Right, so BetaNet will get all the updated changes that are currently available. Now, for our purposes, testnet is good enough. So the API that you can see for testnet that you need to take is HTTPS testnet Algorand API pure stake. So you will find this API. So if you go to the dashboard, right, you can see here okay, this is the beta net. Here you can see, right? Algody testnet API 1 and more. So what more exists over here? Okay, and one more. Okay, it's probably referring to this diagram. Anyways, so you can see that this is the link to the testnet. So this is the API that you can use to access the testnet that is being run by PureStake for you. So you can access the Algorand network. You can query for the block. You can query for information. You can create assets. You can create accounts. You can perform transactions. Whatever you want, you can do using this API, right? So if you see here, the ending is PS1, right? But I have used PS2. That is because for version 2, the latest API upgrade, the ending is PS2. So you have to copy this particular, link, API link, and then paste it at your Algody address. So this is your address where using which you're going to access the Algorand daemon, Algorand network. Okay. And then and there is a token that is so if you are running the node on your local system, right? So let me show you that. So I have installed my node, okay, on my local system, right? So if you see, oh wait, I don't know if you're able to see my screen. Are you able to view my terminal?
Yes, ma'am.
Okay, awesome. So this part is not compulsory for you to do it, but like I said, if you run a node on your own system, this is how it would look like. And Algorand provides a command line tool called Gold, using which you can run your own node, right? So here, if you see, I have my own. I have Gold node start. So I'm starting my own. And the data directory that I need to provide. Don't worry about this. We're not going to get into this. But here it just says that a node has successfully started. That means a particular, I have started running the node on my own network, which is possible, right? So this is what it will actually be running at PureStake, and you will be taking this API. So here I came to show you the address and the token, correct? Slimy. So now if you see this, okay, so if you go inside the data directory, so here I have created two directories. One is for data mainnet and one is for testnet. So I'm going in, I have started my testnet node. So once I go inside this, there will be something called algody.net. Okay, so if I open this, that means this is where my algody is actually running, right? So this is the actual this is the algody address. If you think about if I want to access my local node running, right, on my local system. And then there is also a token. So if you open this, so this is the unique token that identifies your testnet, right? So if you see here, this is the token that is generated for my node that is running. But since we are using a third-party node, we don't have to worry about the token. We only have to worry about this API key. So if you have already created an account on PureStake, then you will find on top your API key. So it says keep your API key secure. That's why I'm not going to show it to you for long. So in the headers parameter, right, just type your API key. So when you want to connect to the Algody client, right, when you want to create an instance of the client, you need to provide the token, the address, and the headers. In our case, because we are accessing a third-party API, we don't need to provide a separate token. So we can just provide the address and the headers, right? In the header, if we provide the API key, it will take care. So this is where we are creating an Algody client. Now going back over here, right? So first is we import JSON. JSON is a library. Now, since we want to use the version 2 client, we are saying from algo sdk.v2 client import the Algody. Okay, so AlgoD is the library that we will be using here, right? The function. And then from Algo SDK, we will also import account and something called mnemonic. Okay, I will share with you in just a bit what a mnemonic is when we run this program, right? So we import the account functionality and the mnemonic functionality. Okay. Now, in this line number 13, if you are able to see, what we are doing is we are initializing our AlgoD client. So we use the AlgoD function here, and then we call the AlgoD client by passing the token, which we don't have to pass right now. But in case we have to connect to our local node, then we have to pass a token, AlgoD address and the headers, right? In the headers, we have our API key. So here you need to replace this API key with your own API key, right? Now, once we have a client, what we are going to do is we are going to create create accounts, right? Now, before we create accounts, let me share with you what are the different types of accounts, right? What are the different types in which we can create the accounts? I'll also share this documentation link. So there are primarily two ways of creating accounts. One, like I mentioned, is known as wallet derived, that is by KMD. The key management daemon is a process that runs on Algorand nodes, right? So if you see over here, I already started, I had started the node, right? 1 second. So I had started the node using goal start node, right? Goal is a command line. So if I say goal start KM, sorry. So here I'm starting my KMD, which is going to be my key management daemon, right? So this is, if you want to create accounts on your local system, you can use a key management daemon. So these are the accounts that will be associated with your Algorand node, right? Now, what we will be doing, so that is one type of account creation, that is using the key management daemon. So this runs on the Algorand nodes, and if you are using, if we are using a third-party service, then this process will likely not be available to us, right? We will directly be creating an account on the third party using the third-party API given to us, because KMD is the underlying key storage mechanism which we can use with Goal for our particular node, right? Now, there are two reasons why, there are, of course, reasons why we want to use KMD and reasons why we don't want to use KMD. Like I already told you, every account that we create will have a public-private key pair, right? And it is derived from a single master derivation key. So your KMD will help you create something called wallet, right? And for wallets, in your wallet, you can create multiple number of accounts, right? So if you want to use KMD, all your accounts will be tied to one single wallet. So you have to only you have to only remember the thing that is generated for that particular wallet. Using that, you can retrieve everything. But the other way to create account is known as standalone accounts, right? So standalone accounts are accounts, like the name says, it is not tied to a particular wallet, but you are creating them standalone. And for each of them, you have to remember the mnemonic, right? And they are not stored on the disk. So you have to store the mnemonic. You're not storing the key pair on the disk, right? The Algorand address and the private key pair is not stored on the disk. In the KMD, you're creating a wallet and storing everything on the disk. But in standalone accounts, you're not creating it. You're not storing it, right? So you have to remember the mnemonic for each and every account. Right now, I'll show you, I'll share to you what a mnemonic is in just a bit. If you see it, you can relate to it much better, right? So so these are the two types of accounts that we will be creating, right? I have some slides on that. You know. All right. Okay, let's move on to creating our account. So So like I mentioned, we are going to use the account library to generate our accounts, right? The simple function here, we have created a function known as generate underscore algorand underscore key pair. That means for each account, like I said, a public and a private key pair will be generated, right? The private key is the key which you use for signing the transactions, and the address is your public key, is your public address that is known to everyone, right? So if you create, so the simple command is the account dot generate underscore account. This generates a private key as well as a public address for you, right? And in this function, we are printing the public address and the private key and the mnemonic for the private key. So when I print this, you will know what a mnemonic is, right? So in any blockchain framework, if you see, right, a mnemonic is nothing but a set of words, mostly 25 words that are strung together, right, that are created for you to store your key pair information. So you can always retrieve your public and your private key if you have stored the mnemonic. So the mnemonic is in the form of English words that you can remember easily, right? Because you don't want to print your private key, neither do you want to keep your private key as it is, right? So because it is then prone to hacking. So you create a mnemonic out of your created account and store the mnemonic instead, right? And once we create the public key and the passphrase, which is the mnemonic, this function will return both the private key and the address, right? Now I create an accounts array so that I can store the generated key pair, and then over here I'm just storing it in the account list, right? This is what I'm doing. Simple program where we are creating 3 accounts on the algorand network. That's it, right? And we'll be printing the public key of that account and the mnemonic. That's it. This is a simple program to do that. So if you have all the prerequisites, let's run the program together, right? I'm going to open a new terminal and close this one. So you just go to wherever you have stored your program. Let me see, I've called it accounts.py. So here it is. Don't forget to fill your API key in. That's the only change that you will have to make from the program that I have written. Other things will remain the same, right? So if you have installed the SDK, you can run your program, and you will see that the public key and the mnemonic for that particular account is created. So here we have created 3 accounts. Each account has a public key and a 25-word mnemonic, your passphrase, right? So here the 25 words that you have to remember are movie, dolphin, broken, misery, rap, perfect, cash, acoustic, right? So this is the series. And you can see that none of the mnemonics are the same, obviously, right? Because all the 3 accounts are different. So if you have reached this point, right, what I suggest is copy your mnemonic as well as your public, key, and store it in a file, right? Because you need this to retrieve your accounts later, which I will be showing another program where you will need to retrieve your accounts. So you need to store your mnemonic safely, right? Now once you have your mnemonic saved, so right now we need the next step that we will do after creating the accounts is creating a transaction, right? A simple transaction that is transferring some amount of algos from one account to another, right? But right now in the accounts that we have created, there are no algos, right? Because we just created these accounts, and of course we don't we have created them on testnet, so we don't have any money to right now fill up these accounts. So what we are going to do is we will go to something called algorand dispenser, right? So the I'll share the URL on stream here as well. So if you go to the dispenser, the URL is bank.testnet.algorand.network, right? This is the dispenser, right? So you can copy your public address of any one. You have to copy one by one for each account. First, you copy for this account, first account. I've copied this. Now I paste it as a target address, right? I do the I'm not a robot thing. and then I say dispense. Okay, so what I'm going to I'm asking is, I'm asking the dispenser to dispense some amount of algos for me, right? So now the dispenser has given me code 200 success. That means some amount of dummy algos have come into my account. How can I check that? So what is given here as a string, right? This is a transaction ID, right? Now we can check whether our account has been populated. So what I'm going to do is I'm going to go to the Explorer, right? So there is the testnet Explorer, right? Because we are running on the testnet. We have taken the testnet API. Now, if you open the Explorer, let me copy paste this as well. If you open the Explorer, you can see here that there is a testnet, there is the mainnet and the beta net that I spoke about, right? But our transaction actually took place on the testnet, right? So here we can search by, so any other transaction, if you're doing on any other network as well, whether mainnet or beta net, you can copy paste the transaction ID or address of your account or group transaction ID, etc., and find out the status. So, sorry. Here I'm going to copy paste this transaction ID, right? And see what happened. So I clicked on search. It's taking a bit of time. Come on. Awesome. So here we see the transaction details, right? So for any other transaction, you can use the Algo Explorer, right? And explorers are there for all the different frameworks. This is the one for Algo, right? So you can see the transaction overview, the transaction ID that was given to us, the timestamp, when did it happen, right? Saturday, September 19, 2020, 6:04. Oh, that gives me a good indication of timing as well. The block number, right? What is the block number? Remember, we saw that each block has a block ID and all. So if we click on this, we can get more details about the block itself. What was the type? The type was transfer, right? The faucet, we call it the faucet, transferred some money to my account, right? And the transaction is already completed. We didn't have to wait. Now, how many algos do we have in our account? We have 100 algos. 100 algos is what the faucet has given us, right? Now, similarly, what I need you to do is I need you to go and copy paste all three of your account addresses, and let me do the verification again and ask the faucet to dispense, right? So again, it has dispensed and it has told code 200 success. So it takes just 4 to 5 seconds for a particular transaction to take place. So this was something that gave me the block details, right? So one transaction, right? This much rewards was given to the miner for this particular transaction. This is the block hash. This is the previous block hash. Oh, sorry, I clicked on it. Now it went to the previous block. But yeah, so this is the transaction ID. When did it happen? Just a minute ago. All the other details you can find about the blockchain, right, over here. See, this is what I meant when I meant by distributed ledger, right? When I meant by transparency of information. All the information is available on the blockchain to you. This is what it means to build solutions on a public blockchain, right? Now, I have copy pasted 2 addresses. Let me copy paste the third one as well and fill up all the accounts, right? So this is the step that you will have to do as well, because you're filling up all the accounts one by one. This is also success. Just for fun, let's copy this transaction, paste it in the Explorer, see how it looks like. All right, the fun is loading. Awesome. Completed. Yes, thank God. That's what I need. So now all 3 of my accounts have dummy 100 algos and I am ready to perform some transactions, right? So I hope so are you. I hope all of you have all 3 of your accounts ready. And awesome. Now, what I need you to do now is if you open the code along sheet that I gave you, there is another code that I have shared with you, code 2, right? It looks a little bit more longer because it has all these mnemonics, right? but pretty much what we are doing is very, very simple. So if you can just copy paste this whole thing, which is code 2, right? From starting to beginning, where at the end you have the last line is print wait underscore for confirmation algodi client transaction ID. Once you copy paste that, then if once you're ready, I will start explaining the code to you. All right, another minute. I'm not sure if any of you are stuck. If you are, I'm probably going to take a look at the comments. Thank you, Usha. Can Algorand wallet have swap cross-chain DeFi built in for all-in-one app? People could raise capital in their desired stablecoin and spend it. That's a great question. And as of now, I don't think this functionality exists, but there are a couple of coins that are supported by Algorand. So recently, USDC was one of the coins that was supported by the that got enlisted on the Algorand wallet. So yes, we are working towards it, and of course we so there's a question around uh, how people can raise capital in their desired stable coin or CBDC and spend it. That's the goal that we are working towards. Some of the functionalities exist as of today, but not all of it. But having USDC enlisted is a great start for us. All right, so let's get started with this next piece of code, right? This is the payment transaction. So in this piece of code, we will be doing a small payment transaction from one account to another, right? So till this part of the code, it's all the same as the previous. We are importing the algo D. Over here, we are importing the account, the mnemonic. And from another library called algo sdk.future, we will also be importing the functionality of transaction, right? We don't need the KMD, but it's just, yeah, it's fine. Now till here it is the same. We have the address, the API token. The token needs to be left blank. You need to fill in your API key, right? You call the initialize your algodi client by sending in your address and headers. Now over here in the next 3 lines, you can see that I have stored 3 mnemonics, right? These are the 3 mnemonics of account addresses that I had created early on, right? So, and over here, you can store the mnemonics that you have created just now, right? The passphrase, this one. So you can store your mnemonics as mnemonic 1, 2, and 3, right? Uh, over here, what we are doing is for ease of reference and to directly access the public key and the secret key or the private key, right? We are going to be converting the mnemonics to the public keys and to the private keys, right? And storing it in our accounts picked, right? So we have created an accounts with 3 counters, of course, as the counters increment, right? So we are going to be storing the private key and the secret key. Sorry, the public key and the secret key. So this is a simple function where we are going through all the 3 mnemonics, right? Mnemonic 1, mnemonic 2, mnemonic 3 for M in each of them. And we are just creating one dict, right? And for each of the counters, we are storing the public key by retrieving it from the mnemonic to the public key. That is, mnemonic is the functionality that we have imported, right? To public key, this will give us the public key, and in the bracket we give our mnemonic. So it will first take mnemonic 1, mnemonic 2, and then mnemonic 3 as we go through the loop. And in the second one, SK is the secret key. So we are saying mnemonic to private key. We give the mnemonic in the bracket, and then we increment the counter. Now, here are certain things that we need. So how do we create a transaction, right? A payment transaction. So from the transaction library, we need to call the payment transaction function, right? It needs a sender address, who is sending, right? What are the different parameters? So when we are performing a transaction on a network, we need to have certain parameters, right? So the parameters will be something like, what is the fee, the transaction fee that we are having? What is is there going to be a flat fee, or is the fee variable, right? So there are several parameters, something different frameworks will have different parameters, but we need to send the parameters for that particular transaction, right? The receiver address, of course, who is going to be receiving that money, and how much amount do we want to send, right? So right now what we are going to do is we are going to be sending from account 1 to account 2, right? So here we are, the sender address is going to be the public key of account 1, right? And the receiver address is going to be the public key of account 2. So whoever has shared their address with me, right? Like I said, I will do a giveaway. So I can even program the giveaway. Actually, I can write a program where I will be sending from my public key to your public key, right? And I will need to sign in with my secret key because I'm sending the transaction, right? So the params we can get from the algorithmic client, right? There is a function called suggested parameters, so suggested params, which will give the suggested parameters, or if we want, we can even set it. So here we are just setting the fee ourselves, right? And we are saying that the send amount is going to be 10. We can even increase it, right? Because it goes in micro algo. So sorry. Now the transaction. So here we have created the first set of parameters, right? For the transaction, the sender address. Oops. So if you want, you can comment it and say that transaction parameter. So you will remember, right? So sender address, receiver address, how much amount, and the parameters, right? These are the 4 things. So using this, we have created our transaction, right? Once we create our transaction, we need to sign the particular transaction from the sender's secret key. That means I am performing my signature on that particular transaction so that the transaction can go through, right? So we say TXN, the transaction dot sign. The dot sign function is the function that we call. And here we have to pass the secret key or the private key of the transaction initiator, of the sender, right? So once that particular transaction is signed, we can call the send transaction function with the signed transaction and get the transaction ID. That's it. This is very, very simple and a straightforward way to perform a transaction on the Algorand blockchain, right? Here we are printing the transaction ID. I will also explain the next part of the code, what it means, but basically this is all it is. These are all the number of lines that you're writing to perform a transaction from one account to another. There could be different types of transactions, asset based transaction, etc. But just to perform a payment transaction, this is all that you need to write, right? Of course, this function is also important, not ruling this out completely. But let's take a look at what this function is doing very quickly, right? So when we say transaction, that means it doesn't mean that the transaction is completed immediately after we initiate. Though it is completed in the next 4 to 5 seconds, you want to ensure that your transaction is completed, right? So we wait for confirmation that that particular transaction is completed. So that is where this function comes into picture, where we are sending the client and the transaction ID to just wait and check if a particular transaction is completed. So you can see here that I'm not going to go deep into what this last round and all this, but what was the last round of block that was mined, right? For that particular client, you get the status of that. Then the transaction info. So using the client, we call the we send the transaction ID and get the info about that transaction, whether it is pending or not, right? And then we check whether that transaction has been confirmed in which particular round, right? And we send the status saying that transaction is confirmed in this particular round, right? And we are printing the transaction info over here. So we are calling this function and sending the our algorithmic client, whichever we have received, right, from the API, and the transaction ID that we created. So let me copy paste my API key again. Oh no. So what you can do is just copy paste your API key over here. That's the only change you have to make. And the other change, the other change you have to make is copy paste your mnemonics that you generated, right, just now from the accounts. So you just save this and go to your terminal. And then let me see the file name, payment transaction.py. So I have got the transaction ID, but if you see, it is still waiting for confirmation to see in which round did this transaction get confirmed. So the confirmed round number is 9342339. And then there was no pool error. You can see the transaction details, amount, fee, other parameters. So these are the other parameters, right? Like what is the network? It is testnet version, then other things, right? The type of transaction that is paid. So here, what you can do is you can copy this transaction ID and paste it in your Explorer as well and see. So let it load. Awesome. So like I said, it will be sent in micro algos, right? So because I sent, I think 1,000, no, 10,000. Okay. So it sent 0.01 algos, right? And from this sender to this receiver using the mnemonics, right? From the mnemonics, these are the public addresses. And this is the transaction ID. And here we saw that in this particular round is when it got confirmed, right? 9342339. So if you want, you can click on that and take a look. The type is again transfer. And again, the timestamp, as you can see, it happened at 6:20, right? Now, if you click on this public address as well, you can get more info about that particular account and other details, right? What is the account balance, etc. If you want to take a look, that you can do as well. So let's see this. Yeah, you can see. So this is an asset that I created myself, my own asset, right? Called Algorand standard asset called Gyan, right? So if you want to build some applications, you can create your own assets on top of Algorand as well. And you can see that I have used this particular address to transfer some assets. That was 21 days ago. And here 13 days ago, I transferred some more micro algos. And then today I transferred 13 seconds ago, 0.01, right? So you can see all the details about this account and what were the rewards that are given away, what is the balance, right, of my particular account. All right. I had a couple of other slides on two more topics, but I think we have already covered a bunch of stuff. So it might be too overwhelming if I just like cover multiple more slides. So what I'm going to do is I'm going to leave you with this, the two coding problems that we have done. One is creating our own Algorand accounts as well as creating a payment transaction, right? So I hope that this part at least was clear, right? Whatever you have learned so far. And you have now an introduction and understanding of what is Algorand, how does it work, how can you create accounts, what are transactions, how do transactions actually work. You have an understanding of overall blockchain, a little bit at least about the blockchain architecture, how do transactions work, how do blocks look like, what are the information that is present inside a block, etc. Right? What are accounts? How can you create your accounts? I haven't shown much about the wallets, but that's okay. You're still familiar with accounts, so you can get started from there, right? And here are a couple of questions that we started out to address, right? What is a blockchain network? And Yeah, what is a blockchain network? How can you be a part of the network? And what is a ledger, right? So I hope these are the primary questions that are answered for you, right? What is a blockchain network? A network that consists of just interconnected nodes, right? So when I was running a node on my own system, I became a part of the network, right? And when you created some accounts just now online, then you became a part of the network, right? How can you be a part of the network? By creating accounts, by creating your wallets, by storing that particular token. That's how you can be a part of the stake networks, right? Where you can stake your tokens and kind of get rewards for that. What is a ledger? Of course, all of you have seen ledger. Looks something like this. It contains all the information about all the transactions that are happening on that particular blockchain, right? So as you can see, here is a pictorial representation of what we set out to understand, and I hope this is clear, right? So I've spoken to you about. I had a couple of more things about Algorand network architecture and assets, but I'll keep it for another time, right? And I just wanted to say that if you are interested in getting into any type of blockchain framework, or understanding more, whether trying on different hands-on techniques, right? Then there are a lot of communities that are out there that are there to help, especially in the space of blockchain, right? For Because I'm an Algorand ambassador, I have been exposed to so many different things. I get updated information about so many things that are happening in the Algorand developer space, right? And then I can experiment and I can try to build my solutions, right? So for Algorand, here is some specific information. If you're interested in the community, you want to, develop something. There are a lot of grants that are available to develop solutions on top of Algorand, right? There are uh, there are ambassador programs where you can become an ambassador. If you build content that is engaging as well as informative, then you can get rewards, right? You saw my wallet. All of my wallet tokens are from my rewards. So you can build content, you can engage with the community, right? And it also helps you learn and pivot, right? So that's why blockchain has great community support all across the globe. In fact, you get a lot of international exposure, right? So you can join the community at community.algorand.org. If you have any specific questions, feel free to reach out to me. I've posted my email ID as well. There are a lot of developer documentation is available, as I'd already shown you, and I've also posted a link for that as well. So feel free to explore and let me know if you have any questions, or if you have any interesting ideas that you want to brainstorm. Just happy to book a slot on my calendar anytime over the weekends and just talk about things. Yeah, thanks a lot for everybody. Thanks a lot to everybody. I think a huge shout out to Usha and her team, Samuel, Arya, whoever's been behind the scenes. You guys have done a great job. So thanks a ton for giving me this opportunity. I think it was a huge learning curve for me as well, as I sort of put together all the material. So yeah, you can always reach me for any kind of question answer. If you have any questions, feel free to reach me on LinkedIn. There's a small tweak with respect to my name on the link, but you can actually find me with my original name as well. And of course, you can email me if you want to just chat about anything. If you want to chat about AI, you want to chat about blockchain, you want to chat about quantum, want to chat about diversity, inclusion. These are some topics. I'm community. Just happy to chat with you and help you in whatever kind of help you need from me, or whatever I can do from my end, right? So yeah, that's pretty much me. I think I've wrapped up 13 minutes earlier. So that's awesome. And yeah, thanks a ton everyone who was able to attend today. And I hope you had a great day as well.
Thank you, ma'am. It was a great session. Thanks for taking time and coming and giving a workshop, ma'am. Thank you.
Awesome. Thanks a lot. I just wanted to say that those who have sent me your wallet IDs, then please share. Yeah, I mean, yeah, I will. If you have not yet, please share your wallet IDs with me over email, or you can just post it over here as well. Not an issue. And yeah, I will send in your rewards to your accounts.
Okay, so thank you. And any clarifications, I think you all can text ma'am. So before we wrap up, we'll just have a look at the opening video of the Women in Data Science conference. So I'll just be playing that.
Data science and any data-inspired and data-driven science is so critical right now. More and more decisions are made based on data. The amount of data that we gather every day and the insights that the data can provide us is just growing exponentially, and that is no exaggeration. The market for data science and related areas like AI is booming. It is so important to have women in artificial intelligence in the area of data science and also in leadership roles. Being able to use data to solve issues and understand bigger problems, it's critical. And we need women in these roles. Every individual brings their own perspective, and so we need to make sure the entire workforce is represented. The good news is there's so many jobs and many different ways to combine their passion area and their skills in data science and get involved.
I would like you to say, what are the problems in the world that absolutely have to be changed? And, can you individually, given all the amazing background that you've had so far and all the education that you've got so far, what are the unique things that you can do to change the world towards that mission? And then think of the technology.
If that is going to become completely data-driven over time, then you can't miss that opportunity. You've got to join in and have a say. If you're not looking at the data from all sorts of different angles, then you could introduce a lot of bias. So it's really important that we have around the table all genders, all races, all backgrounds.
We can't ignore social structure problems. We can't just go in a corner and write some code and read math and then that's the solution, right? We can't do that. So we have to think about who's being affected by these algorithms. Welcome to WIDS!
When we first started this conference, we never would have imagined that we'd be sitting here today with over 200 regional events. We've got over 500 WIDS ambassadors worldwide. Many of them are women, but we've also got a lot of men. And these are people who are just passionate about inspiring others within their community. We're in over 60 countries, and year after year, we're blown away.
Let's make this next decade the Women in the Data Science decade.
What I love about it is that growth is viral. That people will attend one event in one city and then they'll want to bring it to their cohort or colleagues the next year.
This type of industry can be done everywhere, so it should be accessible to everybody. And this is one of the reasons why I love that we are global with WIDS.
So we wanted to create opportunities for women to inspire, educate, and support women at many different times throughout the year. And one way that we decided we could do that was through a datathon every year, which is a predictive analytics challenge using real-world data. We have over 900 teams from 85 countries, and that's in every continent except Antarctica.
When we started WIDS in 2015, we had no idea this was going to be a global movement with tons of international events and a datathon and a podcast show and now outreach to middle school and high school. It's just been such a ride.
Our latest endeavor is to work on some materials that we can hand off to teachers in schools around the world.
This has provided a platform for literally hundreds of women, if not thousands of women, to have an opportunity to be heard.
But the truth is, these are really simple experiments, but they had profound impact because they empowered someone else to be able to do their job better or to be able to take that message.
5 years ago, when we were sitting around a coffee table thinking about what WIDS could be, I never in my wildest dreams thought it would grow so far and so wide around the world in just 5 years. What I'm most excited about is the next 5 years, because I think this is really just the start.
So that was the video of a conference of women in data science in Stanford University, and here we are today organizing the WIDS Mysore, an independent event to coincide with WIDS conference held at Stanford University, and an estimated 150 plus locations worldwide. So all the genders are invited here to attend WIDS regional events to celebrate, appreciate, and glorify outstanding women doing extraordinary work across the globe. So this WIDS Mysore event has a big team behind it. So we have Usha Rengaraju, ma'am. She is India's first woman Kaggle Grandmaster, and she takes the strong lead to organize and conduct talks and events all throughout by us. You can get in touch with her at Twitter at Usha Rengaraju, and she leads 8 communities in Bangalore and Mysore. So she plays an avid and important role for making these successful events a dream come true. WIDS Mysore is also organized in collaboration with 4 major universities: NIE, Mysuru, VVCE, JSS, and GSSS. The organizers of these teams at the respective universities have extended immense support and played a vital role, and we appreciate their efforts and continuous support. This here is the core team of this is the JSS team, and here is the NIE Mysuru team, and this is the VVCE team. So they have played an immense role in supporting us throughout. This here is the core team of the Women in Data Science Mysuru team, and a huge team which works with immense coordination and determination towards making all the events a success. From marketing to designing to anchoring, this team has worked unanimously under the guidance of Usha Rengaraju, ma'am. So our team consistently organizes such events throughout, and to keep yourselves updated, you can stay tuned in and catch us up on the upcoming plans of our further events on our meetup pages. And so here are the links which have been displayed. So don't miss out on anything. Lastly, I would like to say and render a huge thanks to all of the speakers who came out here today and took out time from their busy schedule to be a part of embracing this celebration. We thank all the universities for their tremendous cooperation as well. And I'd also like to take the opportunity to thank each and every one of the team members and volunteers for helping us ensure the peaceful conduct of this event from the start. So WIDS Mysore is an 8-day event. So the next event is scheduled up for tomorrow. So we have a lot of further events even after that coming up. So please be a part of it and kindly stay tuned. Please subscribe to our YouTube channel to get further notifications automatically. Also RSVP for the event if you wish to receive a certificate of participation for the event. A huge thanks to all of you all for joining us today. We hope to see you all in our next session, awaiting us with zestful speakers marking milestones in data science. Thank you and have a great day.